बहुत ऊंचा नहीं है,
नहीं ठीक है।
A very good morning to all our esteemed guests, speakers, and attendees who have joined us physically or virtually. I am Madhura Sandeep Sompulkar, Research Associate at the RBI Unit IRMA, and it's my honor to welcome you all to the International E-Conference on Water Management in Dairy Sector, organized by Verghese Kurian Center of Excellence and IRMA Water Center at IRMA. The conference has been co-organized by National Dairy Development Board and Indian Society of Agricultural Economics. This quaint town of Anand has seen the birth and spread of the white revolution, pushing forth the Indian dairy sector as a highly successful and profitable cooperative model. Water consumption remains an integral component of this industry, right from fodder production, livestock management to dairy product processing. Thus, it is an opportune occasion for us to come together and share ideas about the water management practices in the dairy sector. I now request the dignitaries to please begin the program with lighting of the lamp and paying the respects to IRMA's founder, Dr. Verghese Kurian. 2021 is a special year for all of us as we celebrate the birth centenary of Dr. Kurian. I request Dr. K.B. Kathiria, BC Anand Agriculture University, Dr. Shashwata Narayan Biswas, In charge Director, IRMA, Dr. Tushar Shah, Professor Emeritus, IRMA, Dr. J.P. Prajapati, Chairperson, BKCOE, and Dr. Uday Shankar Saha, Convener, IRMA Water Center to please proceed. I now invite Dr. Shashwata Narayan Biswas, In charge Director, IRMA, to welcome all in attendance.
Thank you and good morning. This is the e-conference, so we have participants both physically and virtually present. So Professor Abhijit Sen, I think he's there, but the speaker is not here, so I can't see him, but I get to understand that Dr. Abhijit Sen is there. And sir, welcome to IRMA once again. I remember, so he's not new to IRMA. Earlier we had, sorry, yeah, this. Good. So, Professor Abhijit Sen, President, Indian Society of Agriculture Economics. Dr. Kathiria, Vice Chancellor, Anand Agriculture University. Sri Minesh Shah, Chairman, NDTV. And Sri G.S. Rajoria, President, Indian Dairy Association. Professor Basant Maheshwari, Western Sydney University, Australia. Dr. Pranav Shah, SPX Flow, Denmark. Sri S.K. Panigrahi, Regional Director, Ahmedabad, Regional Director, RB Ahmedabad. Professor Tushar Shah, Emeritus Professor IRMA. Dr. J.V. Prajapati, Chairperson BK COE, IRMA. Professor Uday Shah, RBI Chair, Professor IRMA, and all the delegates, dignitaries, invitees here. It's an opportunity for me to welcome you on this e-conference on water management in dairy sector. In fact, here I was just telling before the start that in IRMA has a long history since IRMA was established in 79. So we are here for more than 40 years. And I think Professor Tushar Shah started his whole work on water and in IRMA, water management. In fact, one of the first projects that I did in IRMA was on irrigation management. That I took because that time two things were, the in thing in IRMA or mainstream in IRMA. One was cooperatives, research on cooperatives and research on water. And Professor Tushar Shah, and we are so happy that he's here, had spearheaded both. In fact, he started the whole research agenda in IRMA, and at one time, many faculty members, including myself, who was totally foreign to water. I'm a behavioral scientist, but I had also got into water issues and behavioral issues in water management. That's what we did. And I'm so happy that Professor Uday Shah has been able to organize this e-conference, one-day e-conference in water management in dairy sector. In fact, worldwide, I think sometimes dairy industry or any such industry is often blamed that they use maximum water. That's that water usage is very high, and we know, I think since 90s we have been talking about it, that future war will be war of waters, and it has already started. It's not that it is not there; it has already started. The war in a very different form. So it is important and very, very interesting. Given I think Amit is not there. Amit was once very Amit has yet to come. So Amit had very, very interesting. He had said that you see 85% of milk is water, and if 85% of milk is water, and why can't we use water more prudently so that we become self-sufficient with water? What we call Atmanirbhar and in water, and that for dairy sector, and some of the dairy unions have actually started it and is in a big way, and they have become models, sort of particularly in Gujarat, some of the dairies which have started managing water, and Amit was telling that the last stage of it would be how to use the sewerage water, recycle and use the sewerage water and be self-sufficient. And but I also take this opportunity to introduce IRMA to participants, those who are new to IRMA. first time maybe coming. IRMA was, as I told you, that it was set up in 1979 and was set up by economic Dr. Varghese Kurian. And one thing that I should say in this instance, that one question that used to be asked, and people still ask it, that how come Amul was so successful in Gujarat? And many dairies, which Professor Tushar Shahagiri wrote in his book, one of his books, he has written this, that dairies which came much later but not so successful in other states. There are many reasons, maybe one can debate on it. But one thing I am reminded, which Dr. Kurian used to say, that look, Amul had come up as a movement. It was a revolt, which Professor Shah, I think, termed it as Swayambhu, which came on its own. So anything that comes on its own as a movement, as a revolt, or against the status quo in the existing society, those organizations, those institutions, they may take time, but their roots run very deep. IRMA, as an institution, I am very proud to be associated with IRMA for a long time. And pride comes that IRMA is also, that Kurian had set up IRMA as a sort of a revolt against the way existing management education has been carried out in the country. And that's what puts IRMA in a very different. It's earlier we used to say that this is not a mainstream management institute. For example, I'll give you an example that whenever we talk, like a few days back, someone approached us, say rural marketing. There's some association of rural marketing, and whenever people talk about rural marketing, mainstream people think that marketing of goods produced elsewhere in rural areas, lipstick, snow, cosmetics. Whereas in IRMA, we have taken marketing as marketing or value, adding value to rural produce for urban consumers. That's the starting point. So you will have to understand the differences that we that IRMA as an institution started with a very modest start, starting with a single educational program with about 44 students. In 1980, the first program, the postgraduate program in rural management was started in 1980. Today, it has grown into 3 programs, of which the flagship postgraduate program runs with 240 students, 250 students in a batch. We have added fellow program. We have 10, which is a doctoral equivalent program. And then we have a 15-month executive program. And today we have about 600 students on campus. So that's a size and in also types of programs that we are offering. It has increased. And I'm sure Professor Uday Shah, I will not take much time of you, and Professor Uday Shah will give an introduction to the theme of this conference today. Thank you so much. Once again, a hearty welcome to you. Thank you.
Thank you for your welcome address, sir. I now request Dr. Smriti Smita Mohapatra and Mrs. Prakriti Pranami to welcome the guests by offering a rose and a khadi handkerchief, which is in sync with the mission promoted by Honorable Prime Minister to promote the khadi gram udyog and also to reduce the usage of plastic.
Senior most person is deepest person former director.
Thank you, Dr. Smriti and Mrs. Prakriti. I now invite Dr. J.B. Prajapati, Chairperson, Varghese Kurian Center of Excellence, to say a few words about VKCOE and its mission towards today's conference. Thank you.
Good morning, everybody. Honorable guest, the president of today's program, Dr. K.B. Kathiria, Vice Chancellor of Anand Agriculture University, Director of this campus, Professor Shashwata, the former director and the founder for this water center, Professor Tushar Saha, my colleague Professor Saha, the senior professors and colleagues sitting in the audience physically here, Professor Hitesh Bhatt, Sri Shyam Chaudhary ji, Dr. M. K. Jala, Dr. Supikar, Dr. Mitra, Dr. Jana, and all my colleagues. I see in the virtually present Dr. Rajoria, Dr. Sangram Chaudhary. I'm sorry I cannot see others' faces, but I'm very happy to see all of you here in a very important program today. Water is very important and is going to be very critical in the near future, that all of us know. And dairy industry is one of the major user of water, starting from consumption by animals to processing. So, I know that we are improving. Just I recall that when I was doing my training in Amul 40 years back, 1980, the water usage was almost 1:7 or 1:8 like that. Means handling 1 lakh liter of milk was using about 78 lakhs liter of water. And now it has gone to less than 1. Means 1 lakh liter of milk, but less than 1 lakh liter of water. So that is the improvement. And we still want to go further. And probably we'll hear a lot more about Amul's experience than Amit Vyas will come. Dr. Varghese Kurian Center of Excellence established at this institute, probably one of the most beloved of Dr. Kurian, because he wanted to train and generate the manpower for management of the rural cooperatives and so. It was established in 2015, and we are thankful to Gujarat Cooperative Marketing Federation for supporting it. And we are also getting support from NDDP and CDFI and other organizations. The main mandate of this center is to work on the critical issues which are required to strengthen the Indian dairy industry, and that too in a way on the values promoted by Dr. Varghese Kurian. So we are there for cooperatives, we are there for all forms of collectives that is managed by farmers or the producers and so. So we do research related to that, some extension work, publications related to that. We are also showing our presence on social media and print media, discussing about the current issues. Some people call them as threats, but we call them as challenge, and we are preparing our minds that how we should go in future collectively. Sitting here at a common place in Anand, we have all sister organizations. So we have a pleasure in coordinating activities by the other organizations also, like NDDP, Amul, GCMF, NCDFI, IDMC, and many others. Having worked for 40 years in the university, especially the college, and also associated with Vidya Dairy. And I remember Dr. Kurian celebrating his last birthday in Vidya Dairy, Vidya Kaksh, with the students. He used to go every year for meeting all the students, and he loved that organization which he created. Probably it was last creation. So training of professionals, training of students, and then continuously remaining attached with all those stakeholders is very, very essential. And we did all these things which he wanted us to do. And at this center, we are very happy that we are promoting the industry in his way. So this is a brief introduction about the VQC. We have put the brochures and annual report in the back. You can have details about it on that. At the moment, I once again welcome you all and thank you all very much for being here. And also all those dignitaries who are virtually present here. Thank you very much. Thank you.
I now invite Dr. Uday Shankar Saha, convener, Irma Water Center, to say a few words about the water center.
Good morning. Good morning to all. Dr. Katuria, Professor Shah, our chief guest, Professor Abhijit Sen, President of Indian Society of Cultural Economics, and the former member of Planning Commission, and Sri Sel Dadich, Secretary and Treasurer of the Indian Society of Agricultural Economics. Our colleagues, Professor Jhala, Professor Mr. Subhakar, and all other distinguished guests, and my beloved director, Professor Shashwat Vishwas. So, I must acknowledge here that we are very proud and fortunate enough to get Professor Sen's presence as a chief guest, and not only that, and he is so magnanimous to give us time in the shortest possible invitation, in fact. So spontaneously he came for our. We are really indebted to him. It's a hearing such a distinguished economist of the country is real fortunate, and our day, this program has got a very different kind of values today, and I must express my gratitude to Professor Sen and also for other distinguished professors and from different parts. Here we have 62 participants we can see from here, but there is another link online. There are large number of students and professors from different universities and dairy industries they are joining. Like here you can see that Dr. Sangram Chaudhary and Dr. Rajaria and others are there. Similarly, there are many who are others. So I would not like to name all of them. So, but then I would not like to take the time for this water center. So, regarding water center, today why we have taken this particular program, one thing I would like to say just now, a few minutes back, as our director mentioned, that Professor Tushar Shah has initiated this water management work, as also the movement in cooperative. We are proud to celebrate now our founder and of IGMA, as also the father of the white revolution, Professor our Dr. Vardis Kurian's birth centenary celebration. We thought that this will be a very befitting kind of occasion to work on this burning issue of the water in the dairy sector. And because when this water is a very scarce commodities in the whole world, there are many reports, many studies, whole world they are concerned about this water if we see the water is primarily is used in agriculture sector over the year, and over the period of time, this is the demand for water is increasing, and irrigation for agriculture is taking the major part of the water. Besides, all other purposes water is being used as part of irrigations or water uses in overall agriculture sector. Dairy sector is one where also water uses are more as it was been reported. Now, after a lot of effort, which we will hear from the industry experts, that there is a quite high water efficiency in the sector as well, and we are confident that water use efficiency can be enhanced. With this idea, the IRMA has taken initiative for working in a dedicated manner by setting up that IRMA Water Center, which was inaugurated just last December 2020. So that is the position. Why all this concern worldwide? If we look at how the different countries, how they're using or withdrawing the groundwater, if we find that in our country, the groundwater uses are much more as compared to all other countries, including China. This is one of the concern area. There are many reasons. We would not like to go ahead in that analysis, but I'd like to focus the concern. If you see this, then you will see that there are many districts and many towns of the country which are now facing the acute water shortage, and that situation is compelling us to rethink the water management issues, whether it is harvesting, conservation, or any other mode of way to do for increasing the water use efficiency. There are a lot of emerging technologies which are coming. So when we look at the water, we'll try to see the feasibility of using several different type of emerging technologies for enhancing the water use efficiency. This is another very significant one, which all dots are signifying that more than 5,000 tubewells. That shows that there is a huge number of tubewell and concentrations of the tubewell and pump sets are many, and that is also one of the causes for this water crisis in our country. So now gradually, if you look at the scarcity is increasing, we are moving towards the water scarcity zone. If you look at over the years, our water availability, per capita water availability has enhanced, has reduced very drastically, and it is apprehended by 2050, perhaps we may face much more water problem in our country. So this is the situation of different blocks, which now Central Groundwater Board has indicated. The most concern for this is the critical and over-exploited area in this, and keeping those situation in view. So now there is a concern worldwide, and that is also finding place in a Sustainable Development Goal Agenda 6, directly targeted on this water. So keeping that in view, so IRMA has decided to set up this water and that water center, and to do whatever little bit possible for ourselves to contribute for the country's development. When country becomes robust and economic progress is also increasing, naturally the demand for water also will increase, not only in agriculture for the people, but also for the economic prosperity. If in such a scenario, we had just contemplated to have some kind of work in this IRMA Water Center. In this, our productivity, equity, and sustainability are the key points, and we look like water infrastructure, services, and resources with various type of institutional and management practices to be done, and also the policy initiatives. This is how we would like that our approach is completely on participatory, partnership, and collaborative mode. We believe that nothing is possible without joining hands together and work together. That is how the cooperation is successful today, at least greatly in the dairy sector. which was visualized and started in the country by Dr. Varghese Kurian. We are indebted to him for his visionary kind of work, and that has led to us for achieving the self-sufficiency in milk production. So in such a scenario, we wanted in a different mode of work, and then ultimately by doing this, we can try to help the society through for their water security and livelihood improvement. In short, if I mention, Irma Water Center is primarily working towards it, and we have started in a modest way in a very shorter time. And this is also one of the initiatives, and we have started also working with Dr. Varghese Kurian, our Center of Excellence, where Dr. Devi Prajapati is now presently chairman, working in the dairy management in the dairy sector, and hope that we will be having a footprint on water in the dairy sector and create this and create some efficient methodology for increasing the efficiency in the country and help doing it. With this, once again, I welcome all of you and would like to hear from all of you today, and particularly distinguished Professor Vijay Sen and other distinguished guests, and our today our President Dr. Kathiria, whom we request to preside over this deliberation today, and we would like to hear him today, the Honorable Vice Chancellor of Anand Agriculture University, Dr. Kathiria. Thank you. And Professor Shah will be giving more details about the water center work, as also that our theme of this work and why dairy sector is so important. Thank you very much.
Thank you, sir. I extend a very warm welcome to our esteemed guests of honor who have lent their presence virtually to this gathering, physically or virtually. I now invite Dr. K.P. Kathiria, Vice Chancellor, Anand Agriculture University, to share a few words.
Good morning to everyone. So in the International E-Conference on particularly water management in dairy sector, in this function, the dignitaries on the dais, particularly Professor Biswas, Professor Susasa, Dr. Shah, Dr. Prajapati, the audience, Dr. Bhatt, Dr. Chaudhary, our Director of Research and PG Studies, Dr. Jala, all other these scientists and other professors, those who are sitting in the house, and those who are joined online. The speakers, renowned, I can say these very learned, these speakers are also there, and for whom this function is arranged, particularly the participants and the student fellows and other scientists, professors, and teachers, those who are joining here to attend this seminar. Really, I'm happy to be with you in this morning, particularly because a lot of things have been talked, and the expert, particularly, and Dr. Shah will also tell a lot of things about the expertise is there in water management and other things. So I don't want to take much time, but I would like to say a few things about particularly today's the topic which is selected for water management in dairy sector. So as previously also talked about this, because agriculture and allied sectors are using a lot of waters, particularly the major use is for the irrigation purpose, and and other these dairy and other sectors are also there for utilization of the water, particularly in irrigation, because I'm also from the agriculture sector. So we all know very well that in irrigation sector, lot of water is used at different levels, particularly I can say, and the irrigation purpose, different crops are there particularly. And for different crops also, the water use efficiency is different. Some of the data says that in case of rice particularly, 1 kg production of rice, more than 50,000 liter water is used for the production of this rice. In total, if we can calculate the round the life cycle of the crop. So in this way, different crops are using different amounts of water, particularly for the end product, I can say. How we can go ahead for the use the water use efficiency particularly. So drip irrigation, and there are different methods of irrigations have been emerged by the scientists of agriculture, so that the minimum water can be utilized and the maximum production can be gained in different crops. In rice also now different methods have been developed which can be utilized. 50% water can be used and the same production level can be maintained. So in this way, in different crops, particularly in wheat and these irrigated crops, a lot of these technologies have been emerged, but these technologies must be used by the end users, particularly farmers, because if they don't know the actual the method of the irrigation, or sometimes they don't know how much this over irrigation can be useful to them. Particularly in the canal area, we know very well that the flood irrigation and over flooded, I can say, not flood, but over flooded, this situation is there. Farmers are just putting the water in the farm, and just it is just what we can say flooded the whole field. And even in the wheat or some of the crops where such kind of the water is not required, and sometimes it will adversely affect for the productivity. Even though farmers are utilizing that kind of these techniques, and why they are doing that kind of thing, that is also most important, because we are telling that yes, farmers are not knowing, but sometimes why they are utilizing that type of water at a time, because they don't know when second turn will come for the irrigation through this canal. So they think that yes, let it be flooded, and what we can say is some more irrigation, more water is in the field, so it will be prolonged, this crop period will be there, and second irrigation will be delayed, or sometimes they will not get. At that time, they may be safe. So in this way, they are utilizing more water, particularly in the irrigation. Government agency and government schemes, there are a lot of these schemes are also there for drip irrigation, sprinkler irrigation, and that has also helped a lot to the farmers, particularly to reduce the water, because when the water is extensively used, then there are not only the water is what we can say more used and excessively it is utilized, but when more moisture is there, more water is there, then always the disease and pest infection may be always more, and it will damage to the crop at the end. So this is also these are some of the consequences of this what we can say more utilization of the water. Conservation of water, that is also important. We know very well that and different these areas. Suppose in Saurashtra area, we know very well that before 5 years, lot of the check dams and small dams and the quarry bunds have been constructed, and in some of the villages where not any what we can say crops they were not taking during the Rabi, but after some kind of these water conservation, the local these bodies, local these NGOs, they have done a lot of work for the conservation of the water, and nowadays this conserved water is used for the later on these crops, particularly Rabi season. For the irrigation, farmers are utilizing, in most of the areas generally, they are utilizing the open well or dig well, the bore well, these water. So in some of the areas, we know very well that the bore wells have been dig more than 1,000 feet. Suppose we are digging more, we are going more deep to take the water from the lower strata, then what will happen? Always the poor quality water is coming through these lower strata. And when this poor quality water is used continuously for the irrigation purpose, then what will happen? The soil will be deteriorated after a few years, and ultimately the production and productivity will be drastically reduced. And it has already happened in some of the areas of the Gujarat and elsewhere in the country. So this is the scenario of all the what I can say cycle of this water particularly. In dairy sector particularly, we know very well that this water is used for production and processing purpose. These are the major two, these what we can say utilization of water in dairy particularly. In dairy sector particularly, I would like to say that from very beginning, if we can start from the feed and products, if we can grow these fodder crops in the field, what is happening? Lot of these green fodder is required, dry fodder is required to feed the animals. At that time also, whatever crops we are growing, that is also important, because there are a number of crops which are using less water and it will produce more this green and dry fodder with very good nutrition. So that kind of these crops should be promoted at national level, so that the water can be efficiently used for the production of these fodder crops. Not only that, but some of the varieties of the same crop, some of the genotypes are also more efficient for the utilization of the water. At that time also, it can utilize minimum water, and it will also, that particular variety also I can say, it can utilize minimum water and it will give more these green and dry fodder yield. So in this way, if we can, this is also what we can say researchable area, how to minimize or how we can use minimum waters for the production of the fodders. This is also, I can say, this for development of the variety, or we can say for the production technology and other these angles, if we can say at that time also, if we can give very good technology to the farmers, then we can save the water for the green and dry product production. So this is also most important part of today's we can say this seminar. Another thing is that at processing level, as Dr. Prajati, it is not my what we can say subject, but I am seeing that one unique example I am seeing, because I was working in vegetable research station, and our this common wall was there between the Vidya Dairy and vegetable research station. When I have joined 1997, at that time, whatever quantity water was out from Vidya Dairy, and how it was, we can say, this pond was there, and today the minimum water is out going from the same Vidya Dairy, even though the capacity is enhanced. So all these machinery, mechanization and other things are there, which can also help to reduce the water for the processing of any kind of these milk and milk products. That is also most important part, because when any outgoing water is there, it will go elsewhere. We are not what we can say checking it sometimes. And during the monsoon, we know very well that there is a flood situation is there, and whatever water we have kept anywhere in ponds, some small ponds, and it will what we can say go elsewhere. And it will what we can say damage the other these crops or some soils also. So what I would like to say that if that kind of these machineries and latest technology we can utilize, then I think that is also most important part, how we can minimize the, what we can say, these water use in particularly these dairy sector. Last point I would like to say that the quality of water. Quality of water is also most important because for the drinking of human beings or even animals, we know very well that in some of the areas, very even brackish water is there, poor quality water is there, saline water is there, and due to that reason, what is happening in the production side, if we can talk, even though if poor quality water is given to the animal, then what will happen? We know very well. Definitely, it will not adversely affect the health of the animals, but definitely the production and productivity of animal milk will be reduced. Not only the milk, even I can say that sometimes the quality of milk may be also adversely affected if that kind of water is what we can say given to the animals. So these kind of things are there, and this climate change. Now we are already talking about the climate change scenario. In contrast to that, also, if you can see, then now we are seeing that this year, last year, what happened in the Gujarat and in some of the park. Even today, yesterday, before yesterday, 5, 3, 4 inches rain was there in some of the part of Saurashtra and elsewhere. So in this contest, we must have to also see that how this water 5 inch, 1 hour 5 inch rain is there. So it will what we can say ruin everything, and at the end it will go in this way. So in that context also, if we can think for water, the what we can say conservation, water use efficiency, and all the what we can say arena, which if we can think, then I think today this one day this seminar, very learned speakers are there. They will talk about all the things about particularly in the dairy sector, but these all these related, the peripheral, these sectors are there, so that if we can keep in our mind, so that at the end it will helpful to the dairy sector. So with these few words, I am thankful to Dr. Prajapati, Dr. Shah, and all the IRMA, the delegates, those who are here. So thank you very much. Thank you to all. Thank you.
Thank you, sir. I now invite Dr. Tushar Shah, Professor Emeritus IRMA, to grace us with a few words on the theme of today's e-conference.
Thank you, Dr. Kateria, Dr. Sen, distinguished participants and friends. I think it's truly apposite that the KCOE and the IRMA Water Center have taken this initiative to organize this discussion in Dr. Kurian's centenary. The subjects issues very close to his heart. But I really wonder, what would we have to say if we were to be talking about the challenges facing our dairy today? When I joined the NEDP way back in 1978, he used to give us, there was a regulation lecture that he would give to all the new young officers who would join. And he would present his own unique view of Indian dairy. And Dr. Purin used to think that that Indian dairy had very unique strengths. He says that the traditional milk producing countries of the world, New Zealand, Europe, I mean, India has nothing of what those countries have. There are those miles after miles of grasslands on which cattle can graze free. We don't have that. We need all the land for our human beings, people. There is a temperate climate where temperatures are cool all through the year, and you can breed high quality cows to produce with high milk production. There is that rainy climate where you have rainfall drizzling all through the year, like in most of Europe, and you can grow grasses and grains without using any irrigation. Here we have all our rainfall in less than 100 hours, and we must provide for maximum amount of storage so that we can keep growing crops all through the year. So he thought that Indian dairy was a miracle. And the biggest strength of Indian dairy was that it presented no contest between man and animal. There was no competition in Indian dairy. In Europe, almost all milk or all dairy production occurs by using resources that have alternative uses in the economy. In India, what animals eat, mostly, at least those years, animals mostly eat crop residues. Nobody wants crop residues. Animals deliver millions of tons of manure, but for which India would need so much more chemical fertilizer. So he thought that the way mixed farming in India was organized was pretty ideal anyway. I mean, these are the kind of ideas on which young officers in dairy board will kind of raise enthusiasm. Last week, The Economist ran an article, Is beef the next sport? And I really wonder whether it's just a matter of time before somebody says it's milk, the next code. You know, when Dr. Gurin taught us about the marvels of Indian dairy, the environmental movement was just beginning, just rising. Nobody had heard about climate change. Nobody was talking about global warming. And therefore, the entire understanding of the perspective of how the dairying works was very different. But today, the environmental movement, we talk about climate change, they are coming to us like a tsunami. And I think that it is in this new context that that we really need to define the challenges that are facing Indian dairy. That is the first important point that we need to recognize, is that processing is just a very, very small part of the water consumption. In fact, less than 1% of water used by Indian dairy is used in dairy processing. And second, almost all the water that is used in dairy processing is amenable to recycling, reuse, and reuse. And as Dr. Prajapati mentioned in his, we have already made rapid strides. So that challenge is. But the elephant in the room is the water that is used by animals in the dairy production. And that is 99% of the water used in Indian dairy. Dairying uses needed between a fifth and a quarter of total water use in India. And all this water use, none of this is in animals. I mean, some of that is in washing and treatment. So almost all the water that is used, 95 to 93, 94, 95% of the water that is used in dairy is used to grow feed and fodder. Now, in water discussion in the water center, we talk about water productivity and water efficiency differently than we normally talk. We think that when somebody keeps a tap in a bathroom open, you're wasting water. Or in a dairy or in a power plant, if you use a lot of water for cooling, we say that water use is inefficient. But in the hydrologic language, you talk about water savings in the context of a basin, of a river basin. We know that the hydrological cycle is kind of been going on for millions of years. There has been no change in the amount of water that the earth has been receiving year after year after year. So we basically talk about talk about wet water saving or paper water savings and real water savings. All the water wasted that gets recycled is not waste, is not a waste of water. If, for example, there is a dairy which actually recycles all the water, 95% of the water that uses in the dairy process, there is no waste.
Excuse me, somebody has to look at the audio, but the audience is not able to hear properly. So I would request that somebody adjust the audio.
So the only water waste on a major scale is water that is dispatched to the sink or water that evaporates. When you grow crops, when you irrigate crops, then plants need water to cool and to maintain the temperature and so on and so forth. But not all the water that is applied to a crop is wasted. In a country like India, most of the water that is applied to crops actually goes back to the ground, to the aquifer, and the farmer next door pumps up that groundwater and uses it again. So in states like Punjab, the same drop of water gets recycled 3, 4, 5, 6 times before it actually transpires and disappears. Now, what is water waste in this context? It's hard to define. Irrigation engineers say that all the water that is dispatched from a dam, the water that gets delivered to the plant is a ratio of the water that is released from the dam, is the water used. But that's not true, because a lot of the water that is given to plants gets recycled, it gets pumped up back by farmers. And so if you take individual farm, yes, but if you take the basin as a whole, then basically what the water use productivity, water use efficiency becomes a different idea altogether. So in dairying, the real waste of water occurs in growing feed and fodder. And so it is here that the work of the veterinarians, the work of the animal nutritionists, the work of the agronomists is as important in reducing water footprint in dairy as the engineer in the dairy technologies. So I have just 5 or 6 slides in which I want to kind of just show the national picture so that the coming discussions they basically have. So since 1961 census, our milk production has increased 660%. But the bovine population, the big animal population, has increased only 28%. So obviously, the bulk of the increase in milk output, the meteoric rise that we witnessed in milk output, is a result of intensification. And intensification of which result, the animal population could grow in fact very fast with the amount of dry fodder that is available. But intensification has basically occurred by better use of land and water, or more intensive use of land and water. Now, how does that happen is shown by these 2 maps. Both the maps we show, the darker areas show the regions where per hectare milk production per hectare of farmland. That is what is mapped. In 2012, many more areas are greener, deep green. Whereas in 1961, most areas had less than 100 kilograms per net sown hectare. So we are treating milk also as a crop in the Indian mixed farming system, where crops and milk are produced basically in a complementary manner. Unlike in countries like Saudi Arabia or in Australia or New Zealand, there are lands separately assigned for crop lands. So the milk miracle that we've seen today is basically a result of intensification of land or intensification of farming. And that is shown in the 2012 map. And all the red dots, they show the role or areas where cooperatives have played a pioneering role in intensification. These are the areas where increase in milk production per net sown hectare has occurred primarily through the efforts of the dairy farm. One inevitable consequence of this has been increase in water consumption, because most of these areas are irrigated. In districts like Banaskantha or Anand or Kheda, where most of the crops that are grown for feeding animals, they are irrigated. almost every dairy farmer in Anand, for example, has a small plot for the crop. Now, alfalfa is a crop which needs to be watered every week, 52 weeks of the year. So the amount of water that alfalfa or any of these green fodder that you grow to feed crossbred cows and buffalo is very, very high. They are more water intensive than paddy. Now, this is the picture between 1961 and 2012. The total water use in Indian dairy has increased from 89 billion cubic meters or 89 cubic kilometers. The total water use in India is about 680 BCM, of which 89 BCM in 1961 was kind of allocated to dairy, which has increased to 140 BCM in 2012. How about the milk production during this period? It has increased 6 times. Therefore, the average water use per kilogram milk produced has dropped from 4450 to 10. So there is a 75% decrease in water footprint of Indian dairy. In 1961, if we used 4 cubic meters of water to produce 1 ton of milk, today we use 1/4 of that. So in that sense, the things have improved. That we are using less water, we are producing more water, more milk with the same amount of water, and that is directly attributable to the rise in irrigation. As the two charts in the bottom show, in 1961, only 3% of the water used in dairy sector was blue water. Blue water is water that is used for irrigation either through canals or through groundwater. Green water is soil moisture or direct rainfall. So blue water is the water that is manipulated by human beings. That increased from 3% to 23%. So it is basically irrigation, which is accounted for the big increase in dairy production. This spaces the blue water consumption in dairy has been very high. You can see that in this map. Punjab, parts of Gujarat, here we see a lot of blue water use. But if you look at Jharkhand, Chhattisgarh, some of the tribal areas, there is hardly any irrigation use in dairy production. And this is connected with the water crisis that we have. If you see the second map, it shows the water stress in different parts of India. And the third map shows the areas where we have a groundwater crisis. So areas where dairy is booming, there are also areas where groundwater is in deep trouble. And I think this is where much bigger interventions are called for than just improving water use efficiency in dairy processing. So basically, these circles are the hotspots of water crisis in dairy. There are basically 4 types of dairy economy that we find in our country. One is urban dairy, which can be called landless dairy. We use no land at all in producing milk in cities like Delhi and Chandigarh, where everything gets all inputs get imported. Here, the productivity of dairy animals is very high. I mean, per animal milk yield is something like 3,000 grams. The second category is irrigated or irrigation driven dairy production. It's like here. Again, productivity is very high, but water use or blue water use is also very high. Third is rain-fed farming driven dairy. These are the problem areas. All the red areas here, these are the problems. Here you use very few resources, but the productivity of water is very, very low. And fourth are of course areas where beef and milk are produced, like in Kerala or some in the northeast, where again you find water productivity in dairy production is very low. So actually the challenge is posed by these red areas. If these red areas are turned into more like blue areas, then probably we will be able to reduce water footprint for the dairy. Now, these also happen to be areas which have high rainfall, which have good aquifer systems, and therefore they are available to more intensive dairy production. So, dairy cooperatives have done very well elsewhere. If they also make a foray in these areas, in tribal areas, and improve the density of dairy production, we would reduce the overall water footprint of the dairy. So there are 4 key points that are taken. Water use in dairy processing is less than 1% of water used by India's dairy economy. And most of water used in dairy processing is amenable to recovery, reuse, and recycling. We really becoming the best. But that is not the main challenge. The elephant in the room is consumptive water use in milk production. Water needs of bovine drinking, bathing, washing, plus water embedded in feed and fodder used for maintenance and milk production from 300 million bovines. I think the real challenge that we have is that we are maintaining 300 million bovines, but only 60 million at any point in time are productive. So you're carrying 5 times the baggage that is needed to produce a given. So I think strategies like sex semen, improved breeding, feeding, these are the big ticket answer to reducing the water footprint of dairy. So dairying based on green water has low productivity, that is rain-fed farming. Dairying based on blue water, where irrigation used is very high water productivity. And finally, breeding, especially sex semen, that holds the biggest promise to reduce water footprint to the. So I think in the discussion that we have, this is the 4th or 5th seminar that I'm speaking to on water in dairy. And almost everywhere, 4/5 of the time goes on improving, efficiency of water use in dairy plants. But the real challenge is out in the field. And I think we need to kind of give it the challenge what is due. Thank you very much.
Thank you so much, sir. We'll now watch a message from Shri Manish Shah, Chairman, National Dairy Development Board. Unfortunately, he couldn't be here with us today due to some other prior commitment, but he sends his regard through the thoughtful message.
Good morning. Good morning. I am thankful to IRMA and the newly formed Water Center for inviting me to be a part of this conference. I think today's conference is of very much significance for all of us representing Indian dairying and especially National Dairy Development Board, which continues to drive efficiency and innovation in dairy sector. While dairying is obviously about milk, it's water which is one of the most critical components of dairying. A lot would be discussed today about optimizing or rather reducing water footprint in dairying. But I think we all must also appreciate and discuss our achievements in optimizing the water footprint in dairy processing. Academicians, experts, and practitioners present here can share their experiences on the path we have traversed in this aspect. The stakeholders of dairy sector, both nationally and internationally, must know the significant strides our country has made in this regard. We all will agree that our dairy processing is now more efficient because we had a clear measured reference of water requirement in a closed setup, that is the dairy plant. But when we move further in the area of milk production, I think a lot of work needs to be done to arrive at clear measurable references. Can we access the water footprint in milk production in isolation and not adjusting against the agriculture? Most of the animal feed and fodder in India is still crop residue based. Then how much of water footprint do we attribute to agriculture and how much to dairying? And how do we rationalize, if at all, we decide to water usage in feed and fodder without affecting or taking into account the impact on agriculture, for which basically that particular crop is grown. I look forward to get the answers or the solutions to such challenges from this conference. I feel very happy that Vikas COE, now Water Center, has come up in IRMA. While VKCOE has started providing the much needed academic and expert support to the dairy sector and also cooperatives in particular, I am very much optimistic that Water Center will support dairying in accessing, analyzing, and also optimizing water footprint in dairying. The learnings from today's conference from the guest experts and especially young scientists shall certainly help us in refining our strategies, adopt newer approaches, and I wish the conference all the success. Thank you.
Thank you, sir. Now I invite Dr. G.S. Rajoria, President of Indian Dairy Association, New Delhi, to please say a few words. Dr. Rajoria is an illustrious personality with a career spanning over 40 years in research, consultancy, and training. He has developed innovative products and processes for the Indian dairy industry, earning him many accolades internationally.
आवाज मेरा नंबर नहीं है
सर Rajoria sir, आप ही का नंबर है, please go ahead. You are audible.
Okay.
Audible and visible.
Okay, thank you very much. Distinguished panelists and the participants, the problem of water shortage is to be seen everywhere in the global perspective. You are all aware that India is home to 18% of world human population, 15% of livestock, with only 2% land mass and some 4% of fresh water. Out of 70% water that is found on earth, only 3% is drinkable. Our country is at present facing the challenges of depleting groundwater levels, safety concerns relating to the quality of potable water, losses due to insufficient sewage systems, and the untreated wastewater. Projected demand for clean water in India in the year 2030 will be almost double than what is today. Groundwater plays an important role in food production and in sustaining the reservoirs, lakes, wetlands, forests, and other ecosystems. All living organisms on the earth will require water for metabolic functions. Ironically, it is available free to those who have means to extract it without concern for prevention of ecology and environment. You are aware that about 24 million tube wells are run on free or subsidized electricity in India, depleting the groundwater resources fast and uncontrolled. According to the National Groundwater Board, over 17% of functional units have been categorized as over-exploitative, with groundwater extraction of more than 100% of the annually replenishable recharge. The groundwater levels have declined to more than 200 centimeters during the last 1 decade across major parts of India, necessitating the farmers to dig deeper wells and also allow to high power requirements for extracting the water. Since most of the speakers have spoken about the problem of shortage of water for agricultural purposes, I would like to go straight to the consumption of water in dairying. Most of the dairy farms consume about 1 to 10 cubic meter of water per cubic meter of milk production. This amount is lowest in Australia and varies from country to country. Besides drinking by animals, which is about 86% of the produced milk, water is used in the cleaning and disinfection of udder and teats and for cleaning of equipment, facilities and floors. Water for animals is indispensable for life, maintenance of thermal and osmotic balance, metabolic functions, growth, digestion, and lactation. It is very challenging to quantify water uses, drinking milk production in India, as the farmers do not maintain any record for measuring water use efficiency as it is freely available. Dairy processing plants use substantial volume of water for cleaning, for chilling, use of water in brine tanks, cooling towers, steam production, gardening and drinking. Water coming in contact with product should meet the standard for drinking water quality. Water is also used for reconstitution of dried milk to meet the shortage of milk. Now I like to say that the water has to be further adjusted to match different needs, or such as softening, addition of chlorine to minimize count of potential spoilage microorganisms, removal of color, etc. Drinking water can be a significant source of Escherichia coli and so in contaminating dairy foods. Health risks can also be caused by microbial contamination and chemical hazards. Toxic substances found in water like pesticides can accumulate in body and create carcinogenic manifestations in both animal and human beings. Safety and quality standards for water should be understood by dairy professionals. Water supplied by the municipalities or from uh, uh, tanks specify the standards for chemical, physical, and biological properties for use in food plant production. The presence of toxic, mutagenic, and carcinogenic substances should not exceed permissible limits besides parameters of color, turbidity, total viable counts, total organic carbon, taste, hardness, and smell. Their presence will determine the water treatment process further. Water management is linked to many policy matters. Case studies are called for, generating knowledge, including water consumption in various technological processes in dairy industry, the flow and load of the sewage, water quality sampling for contaminants like manganese and ammonium nitrate, iron, turbidity, pH, electrical conductivity, etc. Dairy wastewater is characterized by high COD, total solvent solids, nitrogen, BOD, and phosphorus, pH and temperature. Suspended solids are the main pollutants that arise from leaks, spills, and removal of adhering materials during cleaning and sanitization of equipment. Water used in boilers may require filtration, softening, and reverse osmosis. If whey is not used and discharged along with wastewater, it would increase the organic load. It will be desirable to monitor the quality of raw water and treated water. Condensate should be collected and recycled in proper manner. Dairy processors are challenged to conserve water by employing measures for recovery and recycling of processed water. The volume of wastewater is about 90% of the water production. Potentially exists for reducing water consumption by automated rinsing of milk to remove milk solids from tankers at the dairy plant, automated processing operations, automated CIP, the use of water to save up to 20 to 40% of the total cost associated with production of water. We shall encourage researchers to look for new systemic methodologies, improve the efficiency of water management, and to reduce water use. Magnetic treatment of plate and tubular heat exchangers to remove milk stones was found very effective in one of the experiments that we conducted at Karnal. Selection of suitable detergents and their combinations is essential to remove deposits from milk production. It is nice to know that many state governments under Jal Shakti Abhiyan are now concentrating on water conservation, micro irrigation using spray and drip irrigation, rainwater harvesting, renewal of water sources, use of bore wells, integrated plantation, diversified crop cultivation, and which require low water consumption. There are many areas which need further research to ensure that our earth, doesn't get dried up, and we have to work together to ensure that good quality water is available for both human and animal system. Thank you.
Thank you, sir. We have with us today Dr. Vasant Maheshwari from the Western Sydney University, Australia. His transdisciplinary work in groundwater management and sustainable water use has been pivotal in community engagement for good water management practice. I now invite Dr. Maheshwari to share his views with us.
Thank you and namaskar. I wish to acknowledge all the dignitaries at the site and also online. Thank you for the invitation. Australia-India Water Centre is pleased to be part of this event. AIWC is a consortium of 25 partners from Australia and India. So there are 8 universities from Australia and 1 government department. And there are 15 universities or IITs and 1 government department from India. And so this center is a collaborative center, and Irma Water Center is a founding member of this.
Audio band kar do.
So please continue.
Am I audible?
Yes, sir, you're audible. Please continue. Thank you.
Oh, okay. So the main purpose of AIWC is to promote collaboration in research, education, outreach, and networking. And there is so much common in the water sector between Australia and India. And so this collaboration in water between Australia and India is quite natural. Today's theme of e-conference on water management dairy sector is an example of common interest between AIWC and Irma Water Center. As many of you may know, Australia has a significant dairy industry, particularly in Victoria and New South Wales states. And there is enormous pressure on the Australian dairy sector at the moment to be water efficient and sustainable. There have been a number of initiatives in Australia over a number of years to innovate and make the dairy industry water efficient. An example of such initiative is water trading, that is selling and buying of water licenses among farmers. And this has indirectly influenced how water is used, and there is some evidence that this has led to improved water productivity and sustainability. Also in Australia, I have been involved in what is called the National Smart Approved Watermark Scheme. This is a national body that gives certification with a special logo to indicate a particular industry product is water efficient. So it goes from the various equipment, various services, and this gives consumers choice to which product they should buy if they are water conscious. And this scheme has been running for last 20 years, and it has worked very well across different water sectors. And currently, we are considering to develop a certification for the dairy industry. I have been in collaboration with a number of partners in India on groundwater through a project called MARVI, Managing Aquifer Recharge and Sustaining Groundwater Use through village level intervention. And groundwater has been mentioned a few times in the last half an hour or so. Groundwater is an important input to dairy sector because many of the farmers use groundwater to produce the feed for the animals, and also groundwater is important for other operations of the dairy sector. So what we found was working at the village level, working in collaboration with farmers, and help keep building their capacity to monitor and understand what is happening to their groundwater is a way forward. And this sort of model of MARVI has been adopted in Atal Bhujal Yojana, which is being implemented in 7 states of India. And Dr. Tushar Shah, who is here, he was one of the key people who collaborated on this MARVI project, and is one of his ideas we implemented. So very pleased to report here in Anand. And I'm really pleased to be here, and I thank organizer inviting me to speak few words here, and I wish all the success for this event. Thank you.
Thank you, sir. We have with us today Shri Pranav Shah, Director of Process Solutions, Dairy and Plant-Based Products at SPX Flow, Denmark. I invite Shri Pranav Shah to please say a few words.
Am I audible now? Is it clear?
Yes, sir.
Okay, very good morning, and thank you for VCOE for organizing this seminar and webinar, a combination of it, because we have some people being there, some people joining online, and all the organizing committee. This topic for today, which is focused on water conservation, is actually a subset of what we call a bigger part, a sustainability. And sustainability in dairy systems, in dairy industry, has been often oversimplified. So it is not only conservation of energy, but it also includes conservation of water as one of the resource that we use a lot in the dairy. It is also managing multiple nutrition. So whatever milk we are getting, making it into a value-added product without losing any nutrients, and also underlining the economical, environmental, and social concerns. And why we need all this is because by 2050, we will be 9.6 billion people on this planet, and we need to conserve the resources. And for today, our main focus is water. So I will go ahead talking about water. There are lots of aspects here when we start talking about dairy in a country like India, where we see that the milk is often being transported from village level to the chilling centers, and from chilling centers to the dairy. So in this case, there can be lots of ideas and avenues to reduce the volume getting transported, which can be done either by membranes, by reverse osmosis, and by doing this, whatever water is collected at the source, that can be used for cattle feed. Because as we were talking, and as I could hear from our other guest, that lots of water is being consumed on the farm itself. for cattle feed, for cleaning, for irrigation, lots of purposes. So when the water is being transported, if we reduce the volume, it will reduce the carbon footprint because we reduce to 1/4 of the volume. So we need less trucks and tankers, but the water that is produced at the site, at the production site itself, can be reused by the farms, by the farmers, for the kettles, and for many other processes. So that was one idea that we from industry, as an industry, process industry, can help on reducing the volumes by either membrane filtration, that is RO, as we discussed, and another process is also what we can do is by evaporation. Evaporator is a big equipment, a little complex for farm level to operate it, but membranes are a little compact. It can sit in a small hall and can be used. So that was one of the ideas. Now, when the milk reaches to the dairy, the layout of the dairy is of very significant aspect here, because the layout, if there are two ways of making layout, one is compact layout, one is liberal layout, as we call it. We recommend to build a dairy as compact as possible, yet ergonomic. So the operators should have ease of operating the plant, but should not be so liberal that all the 25-30 years of the life of the plant, you need to pump lots of fluid, you need to clean lots of pipes. And in the dairy, what we see, the processed water that we use in the processing is not much. In fact, most of the water usage is coming from cleaning of the plants by CIPs. So any idea that can reduce the CIP timing, the CIP circuit, the CIP chemicals, CIP temperatures, that will be a huge step towards conserving, towards the conservation of water. There are many aspects of it, which I will not go into details today, but we have been discussing with Dr. J.B. Prajapati, and VCOE will be organizing some detailed presentation on the sustainability in dairy, where we will be presenting exactly each and every equipment, how we can reduce the water consumption, starting from pasteurizer, homogenizer, separator, some special processes where we can reduce the water. Today I have limited time, 5 minutes, so I want to emphasize here that we from industry, the process industry people, we want to emphasize that when we work and design for any dairy, when we design a plant, we are working towards reducing the total cost of ownership, making the operations more efficient, focusing on product quality and consistency. Automation is also very important to reduce the water consumption in the plant, because the clear cutoff and low margin of error enhances your efficiency and reduces the water. So from our side, what we were supposed to focus and deliver to our customers in the dairy is what we call these days as 3BL, that is triple bottom line. So the plant that we build should focus on the people, that is the people working in the plant, as well as the people living in the society around the plant. Less water being used in the plant, less water used in the CIP, less effluent being generated. And we all know, whenever there is a lots of effluent, if the processes are not efficient enough, if there are lots of total solids going into the ETP, then it smells a lot. It's also annoying for the people living around. So by employing proper scraping systems, pigging systems, recovering total solids by what we call as gold stream, where we use RO for flushing, using all the flush water to catch all the total solids and only release good water. So when I was talking about 3BL, triple bottom line, it is about people inside and outside the plant, about the planet. So it should be green processing, it should be less on waste. And the third P is about the profit, also making profit for the industry. So this was my input, that water conservation being a subset of sustainability as a whole is one of the very important aspect. And we from process industry are working towards addressing this triple bottom line for people, planet, and profit. And we'll meet again soon, where we will discuss some components and the processes in greater details, where we will see how we can help in achieving this triple bottom line. Thank you.
Now I invite Shri S.K. Panigrahi to address this gathering. Shri Panigrahi's career has spanned over 3 decades in the bank and NBFC supervision areas, with focus on data analytics and risk management. Currently, he serves as the Regional Director for the state of Gujarat and the Union Territories of Daman and Diu and Dadra and Nagar Haveli for Reserve Bank of India.
Thank you. Am I audible? Am I audible?
Yes,
Yes,
sir,
sir.
you're audible.
Yes, sir.
Okay. Thank you very much. Respected Professor Abhijit Sen, President, Indian Society of Agricultural Economics and former member of the Planning Commission. Honorable Vice Chancellor, Anand Agricultural University, Dr. K.B. Katharia. Sri Manesh Shah, Chairman, NDDB, Professor Basan Maheshwari, Professor Hagare from Western Sydney University, Australia, and other members of the Australia-India Water Centre. Sri Dr. G.S. Rajoria, President, Indian Dairy Association, Professor Tushar Shah, Professor Emeritus, IRMA, Director IRMA, and in charge Director, Professor Saswat Biswas, Dr. Pranav Shah, and Dr. J.B. Prajapati, all dignitaries from international and national arena, and faculty members, researchers, students, and ladies and gentlemen, I'm extremely happy to be part of this conference, and I'm thankful for the invite and feel really privileged. And before me, I have seen all the speakers who have spoken about this very important subject, greatly enlightened by the experts and scientists who have provided powerful insights into the subject. And I do not have anything to offer from my side in terms of those kind of insights. And this is an extremely crucial, important area of policy analysis, area of impact on social welfare and everything. We don't have to overemphasize it. And as a common citizen, to begin with, let me pay my homage to the great Indian, that is Dr. Varghese Kurian, father of White Revolution, and also his institution of eminence which he has built, which is Institute of Rural and Management, Anand. And within that, again, I congratulate the Varghese Kurian Center of Excellence, the work that has been done, and also recently set up the IRMA Water Center for taking the initiative. And this initiative for this water conference is very topical, very crucial at this point in time. What we see right now is, globally, despite the increasing awareness and increasing sensitivity, and also a lot of interest from multilateral institutions and institutions and jurisdictions, there is still a lot of urgency for doing much more, and also searching for solutions, since the scenario that is put out, like what Dr. Tushar Shah showed, and Dr. other experts have shown, that we are already, in terms of the impact, much below the sustainable level. So with further use of the water resource for different economic activities, our ability to provide ensure availability and quality of this water resource for different economic activities and for citizens will be extremely difficult in our country and elsewhere. And the country also has major challenges in the sense that being monsoon dependent, and also a lot of our activities are not having kind of wherewithal to manage without the help from the monsoon and with the recent erratic patterns of weather and the other climatic issues that is actually impacting the overall position, we have a very, very serious crisis at hand. And there is an imperative, despite the action that is taken, great initiative that is taken by the governments and the other agencies in the country in collaboration with the global agencies, also the global initiatives are there through the sustainable development goals and all that. And with this, even with all this, there is still an imperative for much wider level of engagement and also sort of a more decentralization of the attempt and of the engagement to get best benefit of all the people in this whole process. The dairy sector, as the experts have told, is crucial for our country in terms of providing, first of all, livelihood, and at the same time also meeting the nutritional needs in a very, very significant manner. And the water management in that, as other experts have told, also a key theme where we can get insights from all the experts, researchers, and experience, more importantly, across jurisdictions, global practices, and all that. And for the further work that is required, this water center, what has been set up here, I also congratulate Dr. Saha, who is actually RBI chair professor in the institute, for having taken this initiative. It is an extremely important step, I would say, for taking this discussion forward, for actually doing action research and getting, providing the real insights for policy action at appropriate stage. And Gujarat, as we know, is at the core of the dairy sector and dairy industry. And I think some good work already is being done, like in Irma, other places also, some other places. And sometime I read that Niti Aayog had actually assessed the work done by Gujarat state among the leading states in the country in terms of water management and all that. So the key theme, in my opinion, is, like, I'm not an expert in this area, but my general opinion is that both the efficient use and then efficient preservation or conservation would be best taken forward only with good level of an collaborative structure where all people come together. So then the partnerships actually should be among all these stakeholders, looking at specific strengths and capacities and things like that, how to leverage the whole ecosystem for betterment and all that. Now, remembering Dr. Varghese Kurian, he was a visionary and innovator, entrepreneur, project manager, professional par excellence, and a great institution builder, and also a great human being. I think realizing the need for this particular revolution, I think the pioneering work that he has done, we all in the whole country are now enjoying the benefits. And the IRMA also set up by him has done pioneering work in the country in actually really making the rural management a sort of a really likable thing in the whole country, that when he said that the graduates from IRMA would actually traverse a path less traveled by others and try to contribute to the rural livelihoods and create value in the rural sector. So I think this whole initiative of water center and looking at this theme of the conference, where more engaging discussions will be there in the specific aspects of water management in the dairy sector. I believe this will go a long way in actually paying our tribute to the great person that Dr. Kurian. And I also request that the legacies of Dr. Kurian in terms of his ideals, to follow the ideals which were of charting a life course which is towards creating value and looking at welfare of people, and also with the utmost complete total integrity that would be kept in view by all. So I again, thank all the organizers for having invited me, and I am greatly enlightened by all the talk who have the eminent speakers who have spoken before me, and only in my opinion, a holistic and a scientific approach leveraging the technology that is available and which is supported by good research and collaboration across all the stakeholders and resources globally can be shared. And this India-Australia partnership is a very, very important case in point where the Australia-India Water Center and especially Western Sydney University Australia, this partnership is very valuable. I wish everybody all the very best. Thank you all very, very much. Thank you.
Thank you, sir. I am honored to welcome our chief guest, Dr. Abhijit Sen, President of Indian Society of Agricultural Economics, to address our conference. Dr. Sen has donned many hats, including the member of the erstwhile planning committee between 2004 and 14, a professor at Cambridge and Oxford universities, and advisor to several international organizations. I request Dr. Sen to share a few words.
Hello,
Yes, sir, Dr. Sen.
can you hear me?
You are audible, sir, and visible.
Can you hear me?
Yes, sir, we can hear you, sir.
Okay.
Please go.
I've heard everything that's been said so far. And let me just begin by giving you the greetings from the Indian Society for Agricultural Economics. This is a very important and rather ignored area. And I wish that more research is done, much more is published, because there is a general feeling that the livestock sector, which is growing much faster than the crop sector, has fewer problems from the ecological side. And a clear perspective here is absolutely essential. And I look forward to conferences like this, because with livestock now accounting for almost 40% of crops plus livestock, we are in an agricultural situation where much of the interactions are the ones we're going to talk about today and tomorrow, and which, if you look at our publications, look at agricultural economics publications in general, have ignored to a fair extent. So, since I myself have very little to add, let me just end by again giving you all the encouragement and bringing all our compliments for arranging this. To Irma and to all participants. Thank you.
Thank you so much, sir. Now I invite Dr. Uday Shankar Saha, convener of Irma Water Center, to propose the vote of thanks. Sir.
Honorable Vice Chancellor, Dr. Kathlia, Honorable Professor Abhijit Sen, the Chief Guest of the occasion, Dr. Meena Shah, the Chairman of NDDB, Dr. Rajaria, the President of Indian Dairy Association, Viceroy Pranab Shah, Mr. S.K. Panigrahi, the Regional Director, Reserve Bank of India, and other states and other duties, and Professor, again, esteemed and most distinguished Professor Abhijit Sen. At the outset, I would say that today's deliberation will definitely enlighten us and will definitely take some course of action, and we will also hear from the remaining sessions from the technical session 1 and 2. I would first like to thank our Professor Dr. Kathria. Despite his busy schedule, he could take out his time and then agreed to be the chairing for today's international e-conference. And Dr. Kathria, expectations for the sector would definitely would be fulfilled. And when we will work together with the technologies, like in the university, Anand Agriculture University, which was also set up at the behest of the Iron Man of the country, and also our esteemed institute set up by the great visionary Dr. Marcus Kurian. I thank you, sir. I thank you for spending your time and sharing this, and also being with us all throughout during this. I am really indebted to Professor Abhijit Sen and grateful to him for sparing some time. We all are aware that despite his many engagement schedules, busy schedules and others, Professor Sen could bless us for today's occasions, and we are sure that we will be able to move with his directions and all. And we will be also hearing him more often for this particular purpose. And if you all work together, definitely would like to do something for sustainable society and livelihood. Now, other distinguished personnel, Mr. Meena Shah, the chairman of NDDB, he, due to his urgent and sudden engagement, he could not be there. Then he has to be away. So he has given a recorded message, and his message will be also taken to care. I thank you, Dr. Meena Shah as well. Dr. Rajoria, the president of Indian Dairy Association, he could spare his time and being with us and illuminating with his own expectations in the sector. And he is a very rich, experienced person in the sectors. With his guidance, definitely we can also move further. I thank you for being with us. Professor Vasant Maheshwari, the distinguished professor from Sydney, Western Sydney University of Australia, and he is the chief convener of Australia-India Water Center. The dream of increasing the efficiency of the Prime Minister of both the country would definitely help us attaining sustainability as we are working together with the Australia-India Water Center. IRMA is also one of the founding member and with the Australia-India Water Center. Thank you, Professor. Thank you for being with us and sparing your time. Although we know that it is a different time zone, but despite that, you are with us in this morning hours. Mr. S.K. Panigrahi, who is our Regional Director of Reserve Bank of India, looking after the Gujarat states and others. So he was to come to our campus, physically address us, physically being with us and being part of the whole conference. But due to sudden engagement, he could not come. However, he could spare his time, the morning time with us, and then address whatever he has expressed, which is very practical, and we would like to take it forward. And as we are aware that Reserve Bank has been always encouraging for increasing the water efficiency and water management through not directly but through different organizations set up by it, whether it is ARDC, NABARD or other organizations. So this mission of Reserve Bank will continue, and then through policy directions and through the investment for its infrastructures and other purposes, definitely our mission in increasing the water efficiency will be sufficient. With this, once again, I would like to thank our esteemed professor, Professor Tushar Shah, with his encouragement, with his guidance. We are still working, and this IRMA Water Center has been set up under his guidance and his rich experience. We are sure that we will be taking it forward, and we will also get your guidance continuously for doing our bit for the change of the society and in the water flow, and particularly in the dairy water footprint. We may be able to do. Lastly, but not the least, our director, Professor Shashwat Vishwas, and though he had to go, but then he could spare his time and manage his time in the morning to be with us. And he was always been very inspiring to us. And I again thank him for being with us and inspiring all throughout. And our director has communicated his message and is given. He has to be away from the campus and he could not be with us, but he has already wished us good luck and he apologized for his absence as well. Otherwise, we would have been here today. So with this, thank you very much. Thanks to all, and we will break for few minutes. I think our break.
10 minutes. We can have 10 minutes tea break and then go. Yeah. We're only half an hour late.
Thank you, sir. Thank you for joining us at the inaugural session of the International Tea Conference on Water Management in Dairy Sector. We will now take a short break and reconvene in 10 minutes. Thank you.
Hello.
Hello, am I audible? Hello? Hello? Online participants, am I audible to you? Can you please confirm?
Yes, I can hear you.
Thank you, sir. Hello? Hello. I request all the participants to please come in and join for the technical session. We'll be waiting shortly. Good afternoon to one and all here. I am Pranjali Potkar, welcoming you for the first technical session of the International E-Conference on Water Management in the Dairy Sector. The lead presentations will be presided over by the Chairman, Professor Tushar Shah, Professor Emeritus at IRMA, and co-chaired by Dr. Atanu Jana, Professor and Head, Anand Agricultural University, and Dr. Preeti Shukla, Senior Manager at Amul Dairy. Without much ado, I invite Shri Subir Mitra, Group Head, SAS, NDDB, to put forth his views. Sir, please.
This one is. Can you see the audio is working? So you can just move it this way. Simple, okay. Yes. Good afternoon to all of you. It's a pleasure, and really I am feeling very proud to come back to your alma mater and deliver an address. And whenever I enter this institute's portal, I always feel like a student. I don't know why. Even after so many years, the moment I enter the gate, That's what I was telling my professor, Tushar Shah. He was our director at that point of time. And whenever I enter this gate, I feel like, the learning comes back. The second thing which happens is when I listen to him, and then the unlearning starts. So many learnings and so many unlearnings, and unlearning particularly in a dense subject like this, where words experts from all areas, and the biggest expert is Google Baba. Anytime you see and you get a lot of expertise from them, sort of and it's very easy to make presentations also because of Google. With all the conflicting interest, and particularly for this kind of a subject, which is so crucial for us, it is really very important to understand what are the crucial areas where we should focus instead of going into all kinds of directions. I'll just share one of my learnings which I had right now today when Professor just showed it to us. And I was also doing a bit of a homework, and I found that dairy processing by itself may not even be taking 0.1% of the whole problem. So the focus of the problem should go to where actually it is. And there are two ways of looking at it. One is on a holistic one, on an overall way, and also at a local level. Both are very important in their own places. I'm very sorry I did not introduce myself. I am Mitra. I am working with Sectoral Analysis and Studies Group of NDDB. And I want to give my respects to Professor Tushar Shah, Professor Kathrinda, Professor Biswas, Professor Prajapati, Professor Saha, and other distinguished guests, and fellow and student researchers. Okay, you have to make something. Okay, sorry, we'll continue in 2 minutes.
Hello. Hello, I'm audible. Hello, I'm audible. Getting voice. Okay.
Yeah, it is okay. Outside.
Yeah.
No, not outside.
Online. Those are online.
Online आ रहे हो?
Okay, let me continue. So, in general, if you look at it, the requirement of water to produce livestock products is generally higher than to produce crops, as animals consumes a lot of feed crops, water, and cleaned and washed several times in its lifetime before it produces some output. Now, through these slides, what I will be trying to show you some of the important insights what we have from the industry side. If you look at this current slide, which is on your screen right now, you will see that India's picture is not very bright in terms of the studies which have been done by FAO, and the red spots, the stressed areas is quite high in the case of India as compared to other countries as such. Then if you look at the sector-wise water demand for 2025, again, this is based on some studies that by National Commission on Integrated Water Resources. India is home to around 18% of the global population, but only has 44% of the global water. And as water resources are getting depleted, in this scenario, we need to produce more food for our growing population. And if you look at the bulk of the demand, that is coming from irrigation. Now again, very important to underline the productivity, like what Professor Tushar Sir was saying. At the irrigated areas, the water productivity was higher. But irrigation itself, the demand of irrigation is 70%. And that includes our fodder crops as well. Now, if you look at milk production, there's quite an interesting trend what all of us can observe. And particularly if you look at the years right now, particularly after 2014 onwards, you will see that the share of India's milk production is going up, and it's in an accelerated manner. Right now it is 22.7%. And what we think is that, the Niti Aayog says, right now we are 200 million metric tons, roughly we are producing. Niti Aayog says in another 10 years time, by 2030, we will be producing around 300 million metric tons. That will add up another 50% of what we are doing right now. And if you juxtapose that with other studies and what is happening in the rest of the world, it might be just that India's share in world's milk production increases. And that is going to happen because of two reasons. One is India's production will increase by its own reasons, intensifying dairying activities. But the second more important reason would be what we now feel. If you look at Europe and other countries, the dairy farmers in those countries, they are living up their profession. Okay, you look at Europe, you look at US, more and more every day you will hear that dairy farmers are quitting. Okay, so end of the day, who is going to produce milk for the world? So it will not be a surprise that maybe in 10-15 years time, India becomes a leading exporter of milk and milk products. And that may be, that will have a lot of other things along with it. So that's a distinct possibility right now. Now, if you look at, again, where does India stand in terms of footprint of milk? Roughly around 1078 or 1060 liters of water per kg of milk. We are somewhere in the between, like, the global average is 1021. So we are not very far from it. We are not doing bad in a way. Now, this is what, again, Professor Tushar Shah was talking about. And somehow we are very lucky in the sense that our diet predominantly is a vegetarian one. Okay. So if you look at a vegetarian diet and the kind of water requirements, what it is having, you start with, normal vegetarian diet will be having vegetable, fruits, milk. And if you compare that with the European diet or other countries' diet, predominantly which are meat-based, so there the consumption of water, as you can see, is very, very high. But then again, the problem with dairy is we are mixed up. Okay. Milk is mixed up with meat. So we have to find a way out what can be done about it. But even then, in today's context also, if you look at our dietary patterns, and the kind of, the protest and all that what is going on regarding vegan in other countries, and we are also not left untouched. Day by day, we are also increasingly, the voices are getting very shrill that, we should all avoid dairy and all kinds of things. But if you really look at the kind of dietary patterns and the way most of the Indians eat, we are very much a product of the mixed farming only, where milk has got its stand and the farm sector has got its stand. Meat doesn't really play a big role. This is again a slide where some of the studies which has been done on breed-wise consumption and not consumption, I would say, the footprints of water, milk production. In general, if you look at this data, you will find that to get a kg of milk from a buffalo, I have to spend more water than to get a kg of milk from a cow. In general, that's in general. The second important thing what we can see is that again, a lot of variation in this water footprint in area to area, and particularly in those areas, some of the studies which has been done. I would like to direct your attention to the bottom one, Shavik and Dixit, where they have also shown what is the footprint in critical, in safe and semi-critical and overexploited areas. But it is not very clear how much is the role of irrigation over here vis-a-vis underground water. So again, this is the one area where maybe VCOEC can think of undertaking studies and to find out breed-wise what is the difference in cows and buffaloes. Again, you must have seen what Professor Shah was showing right in the morning. But now we are juxtaposing, milk production density with net groundwater availability, and it is very clear. I mean, it's very, very clear that the groundwater availability has got not much with milk production density. Milk production happens for many other reasons. So irrigation, as you said, where water is not there, but irrigation facilities are there, water crops are getting grown, and milk is produced. So particularly if you look at the western side of the country, where the net groundwater availability is nothing to speak about. But then if you look at the milk production, they are having the highest. Okay. And even look at the other part, like where the groundwater availability is really high in the eastern and the northeastern regions, but we don't have milk production there. So there are other reasons why milk production happens. Water may not be one of the very important reasons there. But nonetheless, it is very important that we have to tackle this water management at the farm level by looking at two things. One is the animal productivity, and the other one is feed and fodder productivity. That I think many speakers have elaborated on that. Again, this was a study done by NDDB, particularly in some places during the National Dairy Plan 1 in Gujarat state. So what our interest was basically to look at, does ration balancing help? And we were very happy to find these results that yes, if you are feeding your animals with a balanced ration, so definitely it is going to help the footprints. Like you can see 15% in cows and 13% in buffaloes. That's a kind of savings which you can make if you feed a proper balanced ration. But feeding a balanced ration takes a lot of efforts in inculcating the ideas in the minds of the farmer. And that is where efforts were made. And even any kind of effort you are trying to make for water, I think it will take the same kind of efforts to inform the farmer, to train the farmer, to make him understand that he is going to get better results with less water usage. So that has got a very important role. It will just not come by giving lectures. You have to go and handhold with them, explain to them like we did under our NDP 1. And then we saw the results. Even then over here you can see for green, bran, oil cake and all, the blue water and the green water components. Effectively, if you can mix and match, definitely the water footprints are going to go down. Now again, this is what I was telling, that we are putting a lot of focus on dairy processing. Yes, definitely it is required. And why it is required, I'll come to the next slide, which will make it very clear why a local focus is also required. Though in a holistic view, processing doesn't take much of a this thing, even less than 1%. Roughly around 1.8 liters of water per liter of milk. You can say 1.5 because of efficient use of technologies. These things are coming down. And day by day, definitely with improving technology, this will further go down. So our efficiency in processing in any way is more or less guaranteed. Okay, and people will be following. not much to think about it and not much to worry about it. What we need to worry is more on the feed and fodder side. Okay. Now, how this has been achieved, you can see the technological improvements. Way back in 1970s, we had around 3 to 3.5 liters of water per liter of milk. And today it is 1.5 or even less, or even many places less than 1. Now, how it is done, these are the technological improvements. And day by day, new and new improvements are taking place. I was just listening to Amul Dairy's GM recounting his experiences. I think you'll be sharing it with us with the different ways how further it can be improved upon. So these are some of the places like steam condensate and CIP and ETP treatment. One place where we really find, taking these technologies to other places in cooperatives, in the private sector, and in small dairies is particularly the high cost of treatment. Somehow we have to get a good technological solution. Roughly right now, what we estimate is rupees 150 per liter of effluent. So maybe we can think of technologies which will further bring it down and make it more affordable. Again, this is again done by our engineering group. New technologies like wastewater management systems. We have been using this membrane bioreactor system and chemical oxygen demand and biological oxygen demands. The good thing about this is the pollution control boards are also increasingly day by day, they are also getting very much interested in seeing to it that at least this effluent treatment is being done properly. There are proper regulations. And this is just another example. You can see a meter over there. So water quality monitoring is happening for effluent treatment plants. So on every time you can see the by the hour you can see what is the pH, what is the POD, COD, and all those statistics for controlling the effluent. So this is in practice. So like I think in Ajmer, Jaipur, and we are going to do it in Rohtak now. You'll be having this kind of a system where the effluent treatment parameters are getting monitored. This is Ajmer Dairy project, and we are very proud to show you to you. This is a green project. More than 95% of the roof and non-roof rainwater runoffs were captured. We are fixing the plumbing so that flow rates are less than the conventional fixtures. And lastly, the ETP water is getting utilized for gardening and other purposes, also for floor and dock cleaning. So this is a new plant where we call it a green plant that we are following these measures. This is what I was talking about, focus on the local. So just a holistic focus will not help. This is a big warning sign for all of us. This is Golad Milk Union's dairy plant. Over the years, when procurement side improved, they are increasingly procuring more and more milk. The more and more trouble they are having in getting water. And that is because of depletion of the underground water. And the thing has come to such a pass that now they have to buy water from a nearby village through a separate pipeline at 6 paise per liter. Now, this is a warning, and all of us, particularly again in dairy processing, we have to be very careful. You have to think about how to recharge the area in and around your dairy plant so that the water level comes up. You don't enter into this kind of a situation because your dairy plant fixtures are fixed in that place. You can't, maybe you cannot move it further. And you are expanding your dairy plants. And you are expanding it thinking that more and more milk will be coming, more and more milk will be procured. But at the same time, more and more water is also required. And if you are not provisioning for them, you are in for a big surprise. So that's what Kolar Milk Union is experiencing. And it's a lesson for all of us. It's a high time that we also start thinking that in and around our dairy plant, in and around our chilling centers, bulk milk coolers, just putting a tube well or a pump down will not help. Maybe the water level will go down. So you have to think about it, how to recharge it and make it sustainable. So again, This is, I think, a very standard diagram. They reduce the wastage, reduce the water, we recycle the wastewater. So we need all the stakeholders together to work together in this area. How to do it is, again, coming back to the first original problem, that 90% of the freshwater consumption in the dairy sector is happening through feeding. So it is the feed and fodder crops. We have to think about how to come out with less water intensive feed and fodder crops. And that is the key to success. So way we can achieve this, that if we today, tomorrow, our scientists, our researchers, if you can discover areas or if you can invent areas where feed and fodder, the amount of water which goes into that, if you can even make a 10% improvement in that, that will give huge improvement in reducing the water footprint. And the second thing is, again, anyway, I will just try to read this off. A lot of things are happening in improving the animal productivity, which is equally important. I was just, yesterday there was an article from Professor Gulati. He said that rice requires 1 kg of rice requires 5,500 liters of water in Punjab. And in China, it just takes 1,000 liters. So what does China do better than us? So these are the kind of things we have to think also about fodder crops. Our fodder crops are very water intensive. Let us think of making crops or developing crops, hybrids, which are lesser water intensive. And along with that, we have to think about animal productivity. And here, where we are thinking of increased coverage of AI, use of genomics, sex semen in a big way now. Government of India has also given a lot of focus on sex semen. And obviously this ration balancing program, which we piloted in National Dairy Plan 1. But now this has to be spread around across the country. It is very much required. With NDP 1, we had a dedicated team where in every village we used to go and teach the farmers the benefit of ration balancing. But right now, what is going to happen is that focus maybe we are missing. Many people are not doing it anymore. So maybe at a large scale, all the milk unions, private sectors and others, they should raise their hand in going back to the ration balancing, inculcating to the farmer that whatever resources he has got in his command, that is good enough, provided he feeds the ration properly. In milk processing, a lot of technologies we have already discussed: zero liquid discharge, membrane filtration, water recovery, ETP. That I think we give some examples. As NDDP, we do provide a lot of advisories. You can go to our portal, dairyknowledgeportal.in, where a lot of advisories on water conservation in dairy sector is given. Thank you.
Thank you, sir. Now I invite Shri Amit Vyas, MD of Amul Dairy, to take the dais and present his thoughts. Sir, please.
Good afternoon, everyone. First of all, let me congratulate everyone for this centurion year for Dr. Varghese Kurian, and we are, as Amul Dairy, also is in the 75th year of its existence and moving ahead. And on this day, the International E-Conference on Water Management in Dairy Sector, organized by Dr. Varghese Kurian Center of Excellence, IRMA Water Center, Institute of Rural Management, Anand, and the National Dairy Development Board and Indian Society for Agriculture Economics. So we have seen a lot about, talking a lot about how the water scarcity in the country is basically creating a lot of, discussions about how should we control it. So I'll talk about Amul Dairy, how Amul Dairy in last 75 years been able to, first use more water, and then now it's time to get back into the give back to the environment. We are also working on that. As you all know, I just brief you about. I think most of the people know about Amul, but as we know, we are in the 75th year now. Our architects have been, Sardar Vallabhbhai Patel and Subhan Kaka and Kurian Saab and Ram Bahadur Shastri ji and Morarji Desai have been pioneers in making this what is Amul today at the 75th year. Now, as it's a three-tier structure, as we all know, I'll just give you a brief because some of the people and the new students may not be knowing about how Amul was formed and how it has been done. It's from milk cooperative village level society to district unions and milk marketing federation. It's a three-tier structure, and today you understand that Kera Union in the 75th year has reached almost around 10,000 crores of turnover, and GCMF has reached almost 50,000 crores of turnover. And we have now 42 plants across the country, and in 13 states, Amul Dairy has been operating. And let me tell you, we are now 100% digital. So there are no paperwork, and everything is on system at this point of time, right from the main gate till the payment goes to the vendor or payment goes to the farmer into their account. So 100% it is digital in the 75th year. So we have been working a lot on the energy front, which everybody knows that, all the delicious what you have the product in the morning or afternoon, evening. We are there on your table. Now about the supply chain, let us understand about this supply chain. It is at every level that we need to work on the water conservation. Whether if you see at the village level cooperative society, today we are talking about the animals. Yes, at that level, because of the input services we need to work. At village level cooperative society we need to work. We need to work at the milk union level, at the same time in the market also, because when you give the milk and milk products, again the water is used for cleaning of crates and all. At the consumer level they are consuming. So if you see the entire chain, everywhere we need to work on water conservation. A lot of discussions on this, I will not go into that, but yes, per capita water availability was 1,816 cubic meter, is now in 2011 it is less than what I see, it is up to 2011. But yes, it is further going down. And that is a matter of great concern for all of us. I saw some of the data here, but this is what I got from the Central Water Commission report, is 70% for irrigation. And now if you see in dairy, we are also related to this, and this is where we really need to work. Our focus up till now was on the industry, where if you see an industry 22% water, we have done a lot of work. Every union has worked to their extent to bring down the water consumption. But I think the lot of more focus is now required on the fodder side, which is 100% true. So we are also working on that. I'll share on the glimpse. Obviously, the approach of this management, we again go by PDCA cycle. Let me tell you, Amul has always been working on a very, very basic model, and how can we reuse the water. I remember in Israel, it is for 1 liter, if you take it out, they use it 5 times and then turn it to the out of the system. How best we can do it? We do it around 3 times of maximum up to 4 times. That how this water can be reutilized in the system. So if what we have seen, if you see this data, I was looking at this data and I fully agree that we have got some data now that per yield for average animal of 7.4 liters giving milk, 870 liters of water required, of which maximum is from the feed, that is 743. So from the fodder, feed and the fodder. And for the commercial, it comes to around 740. So average is around 1,000. Let us put it like 1,000 liters of water. So it's an area where we really need to work upon. Now, talking about the water management in the dairy industry, all we know, it comes from borewell process. We use processed water like soft water, DM water, RO water, cooling tower water, boiler water, everything, and for cleaning purpose. Now, these are the areas where we use the water. I'm talking more about the dairy now. I'll talk about what is to be in the future later. Now, the basic fundamental I've been always working on for last 30 years with Amul, and I always say the basic is to go for putting up flow meters. As you see today in Amul Dairy, we have got more than 400 meters been installed, each and every plant across Amul, just to have the data and then take a decision based on the data where the water is going. So first, for the industry to put up is to put up a flow meters in the system. If you do that, things will certainly, you will have the data. Now what happens is, once you have the data, you can see this is I have put up a slide of 2019 also, and the last one is the Kaisala group. Earlier it used to be WhatsApp group, it is Kaisala group. How best we go on continuously improving. Once you have the flow meter, you have the data, then you analyze the data, where the water is going. If RO water you are generating, what is the waste that is generating out of it? What is the soft water use? How we can reutilize the soft water? If you have a DM water, how best we can utilize the DM water? And then this data will give you the entire economics of handling your water balance in the system. Now, I also personally believe that we should also do water audit reports in the dairy, but I personally now feel that we should also have water audit done at the village level, at the farm level, at the generation of the fodder level. That is the future on which we would be working. And at least now from dairy, we have shifted our focus dairy now up to village level cooperative societies and how best we can reduce the water consumption over there. And I fully agree that in future, with the technology available, IoT-based system, how can we go to the farm level to bring down the water consumption itself in the farm, so that the overall water consumption goes down, the one which is around 1,000 liters for 1 liter of milk. So water consumption dairy industry, once you have the measurement of the water, you have where you are going to store it. The most important aspect in terms of saving the energy as well as reducing the water is the prescribed pressure that is required in the entire industry. And that is where now we have done. It is not that it can be done in a new plant. It can be done across any of the plant. And we did it in Amul that today we have, you can see some of the photographs where we say that the water across, whether it is raw water, whether it is RO water, whether it is soft water, all the three headers are put with a variable frequency drive and a pressure balancing system, wherein you have a constant pressure, and then you have the guns at the source, and then you can reduce the power of consumption also, at the same time water consumption also. That is an area where everybody needs to work upon to bring down the water consumption. Now, someone's talking about the quality of the water, that also plays a major role. We can also put some sand and carbon filter into this. So the most important aspect in this is the source. First is flow meter, then where the water is getting processed, that's an area where we need to work, and then where it is getting utilized. The third area is the effective user of milk processing. How best we can automate our process. Now the question comes in conventional plant, it's very difficult, all the flow meters. Let me tell you, in Banas Dairy, I worked for 10 years. 10 years I worked with Subul Dairy. You can see that there how a conventional plant, Banas Dairy was an automated, we made automated plant with those days. Now it is #1 in the entire Asia. If you see in Subul Dairy, it's a conventional plant today. The entire Subul Dairy water management, or you talk of the entire processes itself from conventional plant is to be converted into automated plant. If you come to Amul Dairy today, the old conventional Amul 2, which is, we showcase our Amul 3, but in next year we will showcase Amul 2 also. That is going to be a fully automated plant. Almost 70% of the work has been done in the plant where we have converted the old conventional plant into fully automated plant by putting up CIP, putting up, how do we save water? How do we automate the system? So that area is why I'm sharing this, is that it's not necessary to have a new plant for putting up all the technologies. You can always do it in the old plant. And we are now replacing all the manual work with the fully automated plants in the system. So that's an area where we need to work. CIP system, we have talked a lot about the CIP system, but CIP system needs to be, validated. We know it's an automatic system, just press a button, water will flow, we will have the conductivity automatically. But if you really go in depth of that, we realize that fine tuning of this can bring down the water consumption to a large extent. We have seen in reception area, I showed 1.5 liters. Yes, by putting up a spray ball, which is more effective with pressure. Again, the pressure comes into picture with hydroflow system. Good design of the spray balls, rotary type, with high pressure, cleaning with less water, and we realize that this can reduce the water consumption at each and every level. Now, the future is, I'm talking about dairy right now, the future is that each and every process, you have to have the measurement of the flow of the water, but at the same time, the water needs to be purified over there only. At source, we are now working on a system where we can, how best the generation of wastewater can be processed at source rather than taking it to the effluent treatment plant, and then second processing can be done. So there's an area where we can fully automate this. You can see some of the pics of our new Khatraj plant, which was very old plant, but now it is fully automated. So again, when you talk of, in many of the dairies, the system is available, but I've seen that many of the control process operators generally try to skip it. Why to take this flush into a raised water? So we have now controlled the entire automation. I'm talking about both the aspects, whether it's a manual dairy or whether it's an automated dairy. In automated dairy, we need to work a lot on the standardization and controlling checks. Now, without rinse selection, the process will not work. That is what is required. Otherwise, when there's a flush season, operator would just bypass that and push the flushing through the water and it goes to the drain. We said, no, it has to be through system only. So if you want to increase the capacity of pump, increase the capacity of pump, plan your activity in such a manner that even rinsed milk, every drop of rinsed milk is recovered in the system. Obviously, the guns would help, and guns with high pressure would also help, because with less, then you don't require pressure pumping over there, because the common header that is working around. Coming to the powder plant, I'm talking only on the big, the areas where we can save tons and tons of water. First stage condensate in the boiler can obviously go to the boiler house, which I think most of the unions are doing. But that's an area where people don't have even the trap, the steam trap condensate is also being pumped back into the boiler, where we miss this, and that water goes to the drain. Again, it's a huge quantity. At the same time, in the boiler, we have now recorded all the data of how much water and condensate is coming in the system. The cow water, again, it is an area where we really need to work, and the efficiencies and selection of the sensors for the pure conductivity plays a major role. And that is where now we have worked. And let me tell you, from second stage evaporator, we are now reusing it. See what we have done up till now in dairy, butter, liquid milk, butter, ghee, paneer, dahi, ice cream, all chocolate, all other, not chocolate, but a process. It's a process plant, and technologists are basically working on that. We said no. Effluent treatment plant or water management is also a process. So we have now kept water of second stage is processed as by a process person. So he would now ensure that yes, it goes through different processes and a batch is prepared. And with batch and with the UV panel, we have ensured there is no bacteria in that water. That water is 100% recyclable and reusable in the process itself. It's been done. You can see we have got old tanks. We have used those old tanks to reuse this entire condensate back into the system. But it is a batch process where we 100% ensure that there is no chance that any contamination go into the product. Area for cheese plant, and this can be thought of. We really work very hard on this, and we have now worked. When you do a nanofiltration of the whey, you have a water coming out. But when you do nanofiltration of the whey, it is at 10 degrees centigrade. So earlier this water used to go to the drain. We said how best we can use this 10 degree of heat into the system. So what we did was we transferred this whey, the permit that comes out at 10 degrees centigrade. We used it for the whey which is coming out from mozzarella, from cheddar, or from paneer for cooling of that system by putting up the pH. So we have utilized the water again. Now this temperature goes up to 20-25 and the heat is transferred, the whey is cooled down, their process heat refrigeration load has come down. This water then goes to the CIP station in the storage tanks. And then from there, because once you heat this water, you are having a crystal clear water. So once you heat it to 75 degrees, it's the water that can be used in the secondary heating, which is not coming in contact with the process. So that is where we have now utilized it. And then after flushing and cleaning, this goes to the effluent treatment plant, and then from effluent treatment plant is again recycled to use for other area. So you understand that how many times you are using that same water before it goes to the drain. That's an area where we relate on, and you can see the consumption of water come down by 33% in the entire area. Now, when you process water, when you say that RO, you are doing reverse osmosis of the water, that is a rejected water that comes out. What you do? It used to go to the drain. Now, again, the question is, you put it into the drain of effluent treated water, means a water which was good but having more TDS is now mixed with the effluent. We said no, let it go to the final outlet to see that how we balance the TDS level in the outlet to ensure when you mix with the high volume treated water, you are avoiding the process of doing the treatment of the water itself. So we use this now. We have put, you can see some tanks over there. We fabricated the structure, we put up the tanks, use this water for toilet flushing, use the water for dishwashing. It's a good water. Many of the places across India, sir would agree that very high TDS water has been drunk by people. Here we are utilizing it for cleaning in the canteen or the toilet blocks or for the crate washer. So how then it goes back to effluent, and again effluent treated water is treated. So you can understand that how many times this cycle is happening. Then comes, because you have used the water in the plant, Wastewater plant, if you see, this is an of Amul Dairy, you can see it's all lush green now area. You can have the the irrigation, anaerobic digesters and gas you can utilize, and you have the treated water. But with treated water, we have done that as was shown by you also, that we are now having, it's all digital, and the data comes into the system with the COD, BOD, everything is available to us, and we are monitoring that data of water to be used in the system, back in the system. But at the same time, gas is also getting purified. You're using a bottling plant, Amul Green, you can see. So one side, it's a process again. Now effluent treatment plant is a plant. It's like a dairy plant. It is a plant where we are now working to see that how best we can recover the waste, and it becomes. What you see today in across Amul is all our plants in Anand, Khatraj, Bombay, Pune, or in Punjab now are having hydroflow system for the treated water for gardening. We have now not used hydroflow system because then you can see the sprinklers running. We have put up sprinklers across Amul. So we will, if you come to visit any of our plant of Amul Dairy or in Khatraj or Mugar, you will find only either grass or the blocks. There is no mud across, and we have ensured that 100% water is getting reutilized in the system. Or what we did, some of the unions can do it, is the irrigation purpose for the farmer. We discussed with GPCB and what we discussed, and we said that we give the treated water to the farm. This is a farm of Anand only. It is not that nearby area we are giving, and for the development green belt within the premises, you can see all this is next to ETP. This is next to ETP. It's been well maintained. Then comes, see, areas we identify where the water is. We have at Kapli almost around 200,000 liters of water is being used daily for cleaning purpose of the drivers that comes to that plant. So we said that why this water of 200,000 liters is been used by almost more than 200 trucks coming every day and then taking bath and all. We basically put up a sewage treatment plant over there, and then we started using that water in a dry zone of Kapli, which is considered to be a geological survey. It's a dry zone. Today is totally green. What you see over here is the garden of effluent of the area which is a dry zone, and that is where you can bring down the cost. Then I'm talking about effluent treatment because the water has now reached to the treatment plant. Then the first initiative that we did in Mumbai, as you rightly said, in Kolar, the water is the same terrain in the Virar area. They're all rocky terrain, so water will not go inside. You cannot take out water from there. Even though we put up rainwater harvesting system over there, and if you want to take out the water, you have to pay for that. You pay we pay almost 10 paisa for giving the water away. So that's the first experiment we did. And for zero discharge, today this plant is so successful that 100% water is basically reprocessed RO, and this water is used in the plant itself. So that's an area where that every union, every organization has to work. Coming to rainwater harvesting, as I told you, we have now 57 units. Every drop of water in premises of Amul Dairy will go back to earth, and that is where even we calculate. I was sharing that almost 27,000 liters per hour is a percolation rate into the earth. We put up a tanker to see that how much water goes inside the earth at every point. So today we have 57, and in coming days it will be more than 100 in next 2 to 3 months. So next season would be 100%. We don't want, if we have got 50 acres of land, 50-acre land water should go back to the earth. That is what our target is. And you can see this all be new developed in the rainwater harvesting. And let me tell you, it doesn't cost much. Rainwater harvesting is an investment people talk. I remember to share in Sumul Dairy, when I first proposed this almost 15 years back to do the rainwater harvesting, I was been told that it's the Tapi River nearby. What is the need of rainwater harvesting over there? And today, if you see, the waters are going, tables are going down, and now Sumul Dairy is also now putting up the rainwater harvesting across the organization. Again, a very good example of one is about the talk and one is about implementing the system. 6 years back in dry zone, 20 rainwater harvesting done in Kapliwao area, where the tables have increased to a level where we need not to send tanker from Anand for water. So that's the beauty of this rainwater harvesting. We can turn around. It is not that it's not possible. We can always. What we did was we also ensured that the water that goes inside the rest of the water should be taken to the pond in the nearby area. That also we have now started doing in different areas so that the water table goes up in the system. So if you see, most of the people, I don't know if you are in Anand, we used to have a Ragadi Talav, we call it Ragadi Talav, was built in 1946. At that time, there were no effluent treatment plant. from 1946 till 2013, the water used to go backside of the railway station. It's a huge pond of almost 30 acres of land, which was digged almost 10 feet, and it was filled with water. So we have able to dry that. Today the land costs 150 crores for us, and now we have started using it for, you know, for the fodder. We have started utilizing that, and using the treated water in our area, you have started getting the results. So ultimately what happens? Results are, you can see, over from 13, 14, from 2 liters of milk has come to 0.93. The targets are very, very tough, but yes, what is the future? Future is ultimately we want zero liquid discharge from the dairy in next 5 years, and we are going to achieve that, because now we are working on with the experiments of rainwater harvesting, with the experiments of zero liquid discharge in the system. We are also working on how best we can evaporate this water from the waste heat generated out in the system. That is what work is going on. So we are confident that maybe in next couple of years we will be able to break the technology. Target is also that Amul would be water surplus by 2027. With the kind of approach we have taken, 0.93 minus the water that goes to the earth, at the same time reducing the water at source, would make us water surplus in next 5 years. That is what we are now targeting. And this was all about plant, but our focus is now going towards the villages where the 1200 societies of Kera or 18,500 societies of entire Gujarat, and then across India you got so many societies. How we can put up a effluent treatment plant for the big societies at least to start with, and then this water can be utilized on the Gochar land at the village level, so that this water can be utilized for growing the fodder. So you have utilized, before going it to waste, you have utilized that water over there. At the same time, in the 75th year, our chairman has also given the consent, and very soon we'll be declaring the policy that rainwater harvesting at all the village level cooperative societies. So whatever water is on their roof or nearby area should go back to the earth at the village itself. So what we are doing is, with effluent treatment plant at the society level, and the rainwater harvesting would bring up the table at the village level, and using the land of Gochar, which we are trying to discuss with the government, you can use this fodder for giving it to the animals in that village only. So transportation costs, other all areas, we can bring down the cost. IOC based farming for the fodder, again, we are working on this. I'll show you a last slide where we have now cracked the, the technology of getting good fodder with high protein and everything. But how can we reduce the water is now we are working on IoT based system, so that that quantity of water usage will come down. And as this morning people were talking about sorted sex semen embryo transplant, I'm very pleased to inform you in the 75th year, last 31st October, we made a policy that we would give sorted sex semen for the farmers. Today in India we are number 1. 20,000 sorted sex semen has been done at the Kera district, of which we have now started getting the results. 91% are the female calves that are happening. And with sir, I would again, Tushar sir, aapko batana chahunga, sir, what we realized, why we went ahead with this, is the very important point is that when we saw the data of AI, when it was digitalized, that almost 65% of male calves are coming in the system, which has to be 50-50, means that 15% more male calves, and then you have utilized all those things. At the end of the day, farmer does not realize anything. So we said this is an area where we need to work, and with 90% of accuracy, we are getting 91% of accuracy now in the female sorted sex semen, means 40 plus 15, 55% of the calves that will be coming up in next couple of years would be almost female. So what happens is that, and the same time, this is one part. The second part was the embryo transplant. In India, last year, almost 1,000 embryo transplants been done in the country, of which 600 done by Amul Dairy itself. And up till now, we have now done almost more than 700 embryo transplant. So these are the high genetics. The animals that are coming in will, what right now we have got 10 animals. With 5 animals, we want the more result than that. So you are basically reducing everything on every aspect. This morning we have listened a lot. So we are already working on that. And we are also ensuring that in next 5 years, there will not be any AI. It will be only embryo transplant at the village level. So if that can be done, we can turn around the entire, the consumption of water, water sustainability, everything can be done. Obviously, if you do that, you have National Energy Conservation Awards for that. And this is what, thank you very much, but this is what you see is not from outside country. It is Mogar, it's one of our Sarsa farm, where now this entire farm is fully automated. So So now here we are going to put up the IoT based system so that water, this will become a benchmark to learn and then bring down the cost of the water itself in generation of water. Thank you very much for this.
The efforts of Amul Dairy in water conservation, recycling, and management are all inspiring. Thank you, sir, for this presentation. Now I invite Shri Sangram Chaudhary, MD of Banas Dairy, who has joined us virtually to lead this session. As an
Hello.
alumni of IRMA, he is currently the Executive Director and member on board of NDPP.
Hello,
Hello, sir. Could you?
are you able to hear us?
Yes,
sir.
Okay, very glad to see very familiar and very dear friends there, and I'm very glad to see Professor Tushar Shah. My reverence and namaste to Professor Tushar, who has worked as EME for lifetime and for water. Mr. Amit has done a great favor to me. He has said whatever I wanted to say because we have a similar situation, similar dairy. So probably it would serve the purpose if I skip the presentation. But I would like to tell you two things. You see, there are people who get 500 liters of water and there are people who get 4 liters of water. This inequality and all sustainability is a concern. Well, the world has been talking about water conservation, climate change, sustainability, SDGs, and all that thing. What we need is real action. I think I congratulate Amit and his team. They have done an excellent job as far as the water management is concerned on dairy systems. They need to be replicated. We have already started learning from them. But since the time allotted to me is 10 minutes, and probably all of you are running late, I would skip the presentation, which is much similar to what Amit has made. But I would like to show you 2 videos which I have collected from the public domain. Please bear with me.
There is no planet B. There is no planet blah, 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 blah. This is not about some expensive, politically correct green act of bunny hugging or blah, blah, blah. Build back better, blah, blah, blah. Green economy, blah, blah, blah. Net zero by 2050, blah, blah, blah. Net zero, blah, blah, blah. Climate neutral, blah, blah, blah. Our hopes and dreams drown in their empty words and promises. Of course, we need constructive dialogue, but they've now had 30 years of blah, 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 and where has that led us? Over 50% of all our CO2 emissions have occurred since 1990, and a third since 2005. If this is what they consider to be climate action, then we don't want it. They invite cherry-picked young people to meetings like this to pretend that they are listening to us. But they are not. They are clearly not listening to us. And they never have. Just look at the numbers. Look at the statistics. The emissions are still rising. The science doesn't lie.
Second.
So thanks for watching our YouTube channel. Follow today's top story.
This young girl forced me to think that are we talking or are we acting? And where is the action? Do we know the answers or do we don't? And if we know, do we implement them? Let's see what is the situation.
Okay.
Can you repeat once again?
Pizza. I think it has to be my dog. Chicken. Filtered coffee. Electricity. Biryani. Dolls. TV. Bags. Computers. Food.
Super bike.
Ice cream. Cold drink.
Credit card. Clothing. Temple. Food.
Biryani.
Shoes. House. Car. Trees.
Money.
House.
Food. House.
Money.
I think my mobile. I can't live without my mobile.
Water.
Water.
Water. Water. Water. Water. Water. Water. Water.
So it makes me very sad. Professor Prajapati, I thank you so much. Professor Prajapati, I thank you so much for inviting me. I feel that it is not about having water or not having water. It's about sensitivity about water. Water is life. Water is the basic element of life. Life is not possible without water. Are we understanding that? Are we sensitive to that? That is the important thing. I always give this example. What we have, we don't value. When we have, we don't value. When we don't have, we value. In Corona, we valued oxygen because we didn't have oxygen. So point is waking up. How do we wake up? We wake up by making ourselves more sensitive and more aware about the precious 5 elements which we have and the whole universe is made of. I think if we do this and collectively we do this along with IRMA and other the institutions, all the people who are listening, then I think it would be a great tribute to Dr. Kurian. That's the only thing which I wanted to tell you. Thank you very much for inviting me to speak to you. My presentation is there. Those who want to see, I think it is an, yeah. We've been working in Banaskantha because we don't have water. We are borrowing water. We are buying river water for running the dairy. We don't have groundwater. We have milk, but we don't have water. So what we have started is a greening initiative. The part of that, we are building, we are deepening ponds. We are building, we're recharging wells. We are greening our hillocks. We are trying to grow trees. We have target to plant 10 crore trees over a period of 10 years, and that's what we are planning to do. So I think theory, blah, 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 the people have been talking too much, not doing enough. Let's vote together that we do enough. That's the only message I want to convey. Thank you. Thank you very much. Thank you.
Thank you, sir, for reminding us the stark realities of today's industry for the need of water. Now, I invite Dr. Dharma Hagare, Senior Lecturer in Sustainability Engineering, Western Sydney University, Australia, who has also joined us virtually to present his views. He is also the coordinator of Australia-India Water Center. So please.
Sound, sir, please unmute. Please unmute. So please unmute.
Yeah, sorry, I was muted. Thanks very much. Thanks, Professor Uday, for the invitation. I'm really delighted to be participating in this e-conference. What I'm going to talk about today is the sustainable water and nutrient management within the dairy farms in Australia. I think this will be quite different to the previous presenters. Just briefly, I'm basically an environmental engineer. I teach environmental engineering at Western Sydney University. My expertise is in the area of water management and nutrient management. I also look at nutrient recycling for agriculture purpose. That's my expertise. So I'm one of the co-coordinators of AIWC, Australia India Water Centre. We are really delighted to have a collaboration with Indian universities in this in the water area, and we only started in November 2020. So we so far we are having a lot of collaborative activities with the various Indian universities and also Australian universities. So since I've got only about 10 minutes, I would go quickly through my slides. In Australia, what happens is just give me a second. The dairy industry is managed by our industry organization called Dairy Australia. Now, our dairy industry in Australia is about $4.8 billion worth. It has about 8.8 billion liters per year of milk production. And the number of cows is 1.41 million, and we have got large farms. So the average farm size is 279 cows, and there are the farms which are 1,600 or so. So some of these farms are massive farms. As I said, the Dairy Australia is the industry organization which sort of supports the dairy industry in Australia. Now, the Australian milk utilization, 39% of the milk produced goes to cheese production, and 32% goes for drinking milk, 22% used for producing skim milk and butter. 4% is used for the milk powder and 3% for other purposes. The cheese production is one of the the biggest the produce out of the milk which is produced in in Australia, and 29% of the milk products are exported from Australia. So which is almost around it's $1.2 to $1.5 billion worth of produce. As I said, dairy farms are quite a big size, and each the average size is 279 cows, and our dairy farms are quite mechanized, and the farmers use high yielding milking cows. And some of the cows, the farmers use Jersey cows and Holstein cows. Jersey cows produces around 19 liters of milk per day, and Holstein produces around 53 liters per day. So if you look at the average milk production is 20 to 30 liters per day per cow. The milk gate price is around 0.5, but it may be a bit different now because this is a 2018 data. So you're looking at around 50 cents a liter. Now, one of the mechanization we have is milking process. We have got basically two types of milking system, herringbone milking system, and also the rotary milking system. So these are very widely used in Australia. And there is a lot of automation which is occurring within dairy industry. Now the use of IoT is becoming is very widely used in dairy industry, especially at the farm level, because some of the farms are quite massive. So you're looking at 200 to 300 hectare farm. So to manage that kind of farm, so they need a lot of IoTs and the technology, I suppose. Now the water required at so what I'm talking here is more at the shed level, how to manage the water required within the shed, which basically includes the milking, and also there is a bit of holding and feeding occurring within that shed level. So the water required, mainly for the milking equipment, cleaning milking equipment, cow udders, and then cleaning, the holding area and the feeding areas, and also the drinking water for cows. Now, the case study, what I'm going to present, today is one of the farm which we worked on, it's very close to our university, which has got 370 cows, and the total farmland is 142 hectare, and the milk production is 23 liter per day per cow. Now, this the dairy has got a waste management system, which is included as a part of the dairy. We got a primary pond and a secondary pond, which collects all the solids and the water which coming out of this dairy, and then provides a bit of a treatment, and then afterwards it's all the solids and the water is recycled. Some of the water goes back to the dairy for the washing purpose, and the solids are taken out and then put on the land. So we developed a sort of a closed system for this particular dairy farm, so which basically includes an anaerobic pond and a facultative pond. So the supernatant from the facultative pond is basically recycled back to the feed pad for washing purpose, and also the holding part or holding ad. So all the solids are collected and then taken into the anaerobic pond. Now the solids from the anaerobic pond is taken out and then pumped through the irrigation line and applied on the land. Now I'll basically go through why we sort of started taking out the solids from the anaerobic pond a little later, which is mainly to optimize the nutrient utilization. Now, how we achieved this kind of the water utilization optimization was through the stormwater harvesting. So we collected the stormwater around the area of the shed, which was almost 7,000 meter cube per year. That's 7 million liters per year. So we harvested that water and collected into the anaerobic ponds and also the facultative ponds. And we managed that water to clean the shed, and also some of that water was used for irrigation purpose on the land. So through that, we reduced the freshwater consumption to just 324 meter cube per year. That's around 887 liters per day. So if you really calculate per cow, it was around 2.4 liters per day per cow. So if you look at milk, per liter of milk, it's around 1.1 liter per liter of milk. which is quite significantly low. Normally in other forms which do not have a proper stormwater harvesting system, it can go up to 1 liter per liter of milk. Because they really need quite a bit of water for managing the the dairy shed. Now the solids and also some of the water from these the anaerobic and the facultative ponds are taken out and then applied on the land. There are basically two systems. One is to apply on the top of the the grass, or the other system where we can sort of flow into the land. That is a below ground application. Flowing into the land, which prevents the loss of nutrients through runoff. So this is also practiced in some cases, but most widely it is the applied above ground through a irrigation system. So what they do in, as I said, the land is quite big, for a lot of these forms. So what we do is we come up with a sort of irrigation system, which includes a pipeline. So we'll have a pump, which will basically pump the the solids and also the water, the slurry through these the irrigation system. And then the farmer will basically allow the solids be applied on a given paddock over the particular period. So this kind of system works very well for recycling the nutrients within the farm. So the supernatant, which is applied, consists of quite a bit of the nutrients. For example, if you're looking at phosphorus, which is around 65 milligrams per liter, nitrogen 235, potassium, calcium, and magnesium. So it's all very useful nutrients. So it contains those nutrients. So obviously it is good to recycle without losing these nutrients to the runoff from the paddock, from the land. We did some lab studies to look at what whether the pond sludge or the supernatant is a usefulness of pond sludge or supernatant as a fertilizer. So we thought of we realized that the supernatant has got a better yield compared to the sludge. But over the longer run, the sludge performed very well as well. So, but both the sludge and the supernatant did very well compared to the control. Where in the control we didn't add any of those, the material in the pot experiments. So just the concluding, now the freshwater input can be reduced by incorporating the appropriate treatment system. So you need to have a proper treatment system within the dairy farm. It could be just a holding pond, or it could be a some kind of aerobic treatment system or an anaerobic treatment system. Which will retain the nutrients within the pond, and then that could be taken out and applied on the land. And stormwater collection and rainwater harvesting is very important. I think the previous speaker talked quite a bit on this. The capturing all the the water which comes through the stormwater system and also rainwater is very important, which will eventually reduce your water consumption within the farm. So through these initiatives, you can achieve a zero waste system within the dairy farms. And also we demonstrated the appropriate nutrient management could enhance the farm productivity, because particularly the pea can be through this treatment system, the majority of the pea can be made available to the plants and that could be applied on the land, and that could increase the production of fodder for the cows. So that was one of the key findings of this work. So the overall, it's very important that we recycle the water and the nutrients within the farm, because everything is the quite a useful material. So it's very important that we recycle within the farm, so that we achieve the sustainability of the dairy farm, and we don't have any kind of waste going out of the dairy farm. So that's all I wanted to say. Thank you very much.
Thank you, sir, for the insightful presentation. Now I invite Shri Vijay Kumaran KN, former MD, Milma, Kozhikode, to present his views. He is associated with the Institute of Engineers and the Certified Energy Manager, which have been appreciated in his past engagement with Milma. Thank you, sir. Good morning. Sir, could you please present?
Am I audible?
Yes, sir.
Yes.
Yes, sir.
You can start.
Is my presentation visible? Hello? Hello? Hello?
Yes, sir. It's visible. You're
It's
audible
visible,
as well
okay.
as visible. Yeah.
Oh, okay. The network is very slow here. That's why. Okay. Good afternoon. I am Vijay Kumaran, basically mechanical engineer. I retired from Milma service 6 months back. Then thanks to Amit Vyasji, he has extensively explained the activities that dairies usually do. And what is exclusively for Malabar Milma. Malabar Milma is one of the milk union in Kerala, having 66 of northern Kerala in operation. We collect 7.5 lakh liters of milk per day. We have small dairies, that is 1 lakh to 2 lakh liter dairy. And main conservation activities, but we are following rainwater harvesting, reusing of cooling tower water from machines, reusing of latter part of backwash water, ETP treated water prints of milk trays, treated water for gardening and fish ponds. Then in farming sector, we are doing low water usage fodder moringa, and it is a technical and financial collaboration with the NDDB. Thanks to NDDB, drinking and cleaning activities of cow shed. This dairy campus in Malabar Union, Palakkad Dairy. Palakkad area is the most drought affected area, and the water rainfall is comparatively less in Palakkad. That is why we in the campus we have constructed one pond for water harvest, storm water harvesting, rainwater.
Sir, can you please put it on presentation mode?
1 second. Is it okay?
Yes.
Okay.
Yes, sir. Great.
This is Palakkad. It is having 200 lakh liters of capacity, and during rain season we collect. It's mainly it is very much nurtured the percolation of water to nearby areas, and we are the entire area of Palakkad, that village is getting the advantage of this pond what is constructed by us. It is a social activity also to recharge the water. And we usually you can see the one pumping station here. and we are using water to 4 to 6 months from this pond. Then coming to other dairies, rainwater harvesting from rooftops. Every dairy is having rooftop rainwater harvesting system, which is fed to our main water sump. It is rainwater is collected. You can see that filter, both filter, charcoal filter and the activated carbon filter. Both filters are there, and sand filter is also there. Then it is collected and it is mixed with the other water authority or other water mixed with that, and we can survive with this water for 4 to 6 months per annum. Then reusing of water from machine, homogenizer, seal cooling, as well as milk packing machines. In every dairy, we are having on the rooftop, we have arranged one tank, so that sprinkling is there. Then water is not, it is continuously recirculated by water conservation, by reuse and reduced load to ETP. Otherwise, this entire water will go waste into ETP and we have to process it again. That is why every dairy is having. And some of the dairies, we are using chilled water with the exclusive cooling system, that is freon based cooling system, so that water usage is very limited, but power usage is there. But according to the system, water is available, then we are using this system. And if water is very scarce, in that case, we are using the chill water system in UHT plant as well as in normal plant. Then coming to filter plant system, Bayanad Dairy is a prototype. Water is collected from the nearby river source. The sediment of water, that is, we are wasting around some 25,000 liters of water per day for recirculation, washing, backwash of water, and almost 2/3 of the water is recovered by this old tanker. You can see 30,000 tank is there. It is backwash water is collected here, and it's allowed to settle. And it depends on the microbial quality. Top 2/3 of water is taken and 1/3 is drained off to agriculture or other gardening provision. The other, based on the microbial quantity, we are using it. Then coming to the ETP treated water, the tertiary treatment is using the pressure sand filter as well as a carbon filter, and after we are using for first rinsing for soiled tray from the market, so that in Calicut Dairy we are using this technology, and it is very effective, since our soiled tray washing is very tedious job, and this is done by that method, and it is very effectively used. Then of course, in every dairies we are using the treated water for fish farming as well as in aquaculture, and gardening we are using that also. Then in our dairy extension activities, our Malabar Rural Development Foundation, the trust promoted by Malabar Milk Union, and we are in subsidized water drinker for cow sheds and also pressure washers for cow sheds. In dairy, we are using all pressure washers and all the things to conserve energy as well as water. And here the in dairy farmers, we are supplying pressure washers at subsidized rate, so that water conservation in remote village areas where water scarcity is scarce, that we are doing in a better way. And thousands of pressure washers were supplied to the needy persons at subsidized rate by the our foundation. Then coming to the dairy farm sector, we are a pilot project with the technical and financial collaboration with the National Dairy Development Board to increase the Moringa fodder. Moringa fodder, it is considered as increased milk quality as well as 0.2 to 0.3% of fat, and SNF as well as SNF is increased by adding Moringa in the cattle fodder. And dairy farmers, if it is used as moringa leaf as well as drumstick is used as vegetables. Also, it is added income to the farmer in the other sense. And it is more drought resistance in Palakkad itself. In Attapadi area, we have tried this and it is successful. But due to some reasons, some of the areas, the dairy farmers are reluctant to cultivate continuously, since they have to grow some other vegetables and the other things also. In many areas, they are continuing this moringa plantation, and they can yield will be up to 3 to 4 years, and it is very effectively done in that area. And the sorghum as well as Guinea grass, which is having more drought prone areas, we are supplying the seeds of these Guinea grass as well as sorghum, so that the consumption of water for fodder can be minimized. Then I am not going to the other slides, that's the conservation of water using this in CIP, dry washer, and other areas we are not using, since Amul Dairy MD has covered it extensively. And this is similar to all dairies. It depends upon the size of the dairy. And we are main things what we have implemented is the rainwater harvesting, and that is very. And another thing that we are planning to use in my house, it is done. That is recharging of borewell water with the rainwater harvesting. It is being done in and other dairies also. It is being implemented in short while. Thanks. Thank you. Hello.
Hello, check 1, 2, 3. Hello. Hello. Hello, check 1, 2, 3. Hello. Hello, check. Hello. I will let. Open the gila. Chalo. Hello, check. Hello. Clean આવે ને અવાજ? આ તમને બોલો નહીં સંભળાય. તો મારું વાત તમને સંભળાય ને? બસ તો પછી શું? Hello, check. આ તો શું મત લઈને આવે આમાં તો. Hello, check. આવ્યો હવે? તો ચાલો. કાંઈ નથી. હા મને ચેકિંગ તો થાય ને ટાઈમમાં. Hello, check 1, 2, 3. Hello. Hello. Complete. Hello.
Back to the international e-conference.
Madam Kaputo, are you able to listen us? Ma'am?
Yeah, I can listen.
Oh.
I welcome you back to the International E-Conference on Water Management in Delhi. We'll now move to our next presentation. I now invite Dr. Lata Devi Ji from NIANP Bangalore to present her views. Ma'am, please.
Is it?
Yeah, please put it in presentation mode, madam. That's it. Yeah, correct. Done.
Can you
done.
see?
Yes,
Can you
yes.
see?
Yes, madam. Done.
Yeah. So shall we start, sir, or should we wait?
Please continue.
Yeah. Yeah. Good afternoon, everybody, all the respected members of the panel and my dear friends and seniors. So I am Dr. Lata Devi, a senior scientist working with the National Institute of Animal Nutrition and Physiology, Bangalore. So I have a little bit of experience in working on water use efficiency with reference to dairy farming, which I would like to present before you. Before going to what exactly my work, so I would like to, because we have been listening since morning about the relevance and the how important the topic water is, and especially for agriculture and allied sector like dairying. So some relevant questions which each one of us as a citizen of this country and this planet, we should be asking to ourselves. And like, where is the water dependence in my enterprise or in my supply chain till the level that it takes to the final product to the consumer? How well our regulations are protecting our water resources, and how water secure are our supplies? And can I do something to reduce my own water footprint and help us manage water for both people and nature? Because we don't inherit these resources, we are actually borrowing it from our next generation. And we should always keep in mind that water scarcity affects over 2.7 billion people for at least 1 month each year in this all over the world. So water is a very, very important and a scarce commodity nowadays, being in the morning the video which we have seen, that Greta Thunberg, how she was talking, like, yeah, we have talked enough, now it is something to do. So we all know water is very essential component required largely for, and especially the agriculture and the allied sectors like dairy farming is very water intensive. And the major water requirement in dairying especially goes to the drinking and operational purposes. And with the increasing population, industrial growth and water pollution, now the water quality and quantity availability is becoming a huge concern. And the per capita availability of water is shrinking each day, and it warrants judicious use of water. And you know that India, China, and USA are the largest consumers of global water resources. And India and China being the most populous in the world, we are the largest consumers as well. So the water use can be direct. Before coming to my actual work, I would like to do some, because I'm interested in the topic, academically also. So direct and indirect use of water is included in this, and the water footprint will look into both direct and indirect use for a process, product, company, or a sector. And this will include water consumption and the pollution. And so this is actually the water use will be measured in terms of the volume consumed as well as the polluted with each process that is happening per unit of time. So this water use is actually geographically explicit. It has a temporal as well as a spatial dimension. So you will see that the water use efficiency or the water productivity will vary from product to product, process to process, and it will be across the timeline as well as across different territory. This will be different. So this can be calculated for a process, product, consumer, or a nation, or an organization, or a producer. So what is the water footprint? It should cover the whole production chain from the input to the output, ultimately to the consumer. And as I said, it has three components. Like academically, if you read all those papers, you will always get to know anybody who is looking into the water footprint, you will definitely get to know the three water footprints: green, blue, and gray. Other than that, there is a virtual water. So green is the rainwater, which morning also one of the speaker was talking, like the green water productivity is always different than the blue water productivity, because blue water goes into the groundwater and the surface water. And the gray water will be the volume of polluted water, or the volume of water required for removing the pollutants after a process is done. So together, this will give you a complete picture. If you see the average water component of different commodities, you will see that the milk as well as, and if you see across the different countries also, India is one of the highest contributor as well as a consumer also. As we have a huge animal population, and we are the largest rice consuming country. Our basic staple diet is mostly rice. So we are one of the largest contributor towards this impact. So the world average also, see, if you see the different products, definitely our vegetarian diet definitely contributes to a high productivity as compared to non-vegetarian diet, because the meat products consume a lot of water. So if you see the what I have studied is also the exact reflection of what we can see in these slides, because exactly the farm gate production and the processing of the product. So the farm gate production will always be a highly productive. Water productivity will be different as compared to the processed one. The processed one, as well as if you see the milk, liquid milk, as well as the cheese and other product. Cheese is the highest water consuming milk product, and then it is followed by the our cottage cheeses and other things. So these are some of the commodities which I thought of sharing with you. So if you are wearing a t-shirt made of cotton, you are utilizing 2,700 liters approximately. If you are having a cup of coffee, it is black coffee, 140 liters of water actually you are consuming. If you are eating 100 grams of chocolate, you are having 2,400 liters of water. So 1 kg of sugar, refined sugar, will give you 1,500 liters of water. Then 1 kg of tomatoes, you are consuming 180 liters of water. If you are taking 1 glass of wine, you are consuming actually 120 liters of water. And if you are using a leather shoe, you are actually consuming, you are leaving a huge impact on the water resources. If one sheet of A4 sheet, actually earlier when we were kids, we were always told that how many trees are cut for producing a sheet of paper. But now we should talk in terms of water, because we are using 10 liters per each sheet. So when you add the water footprint of different components, you can come to the water footprint of a nation as well, because it is actually all the water footprints of different commodities and services consumed by the whole population, and that gives you the per capita water footprint. So there are two components, internal as well as external water footprints. And then virtual water is another thing, that where you are through your export and import, how much water is being traded. So the major determinants of a country will be consumption characteristics as well as the production circumstances, climate and agricultural practices. That is very important. Climate as well as agricultural practices, because how water efficient is, use efficient is your practices, your crop, your livestock, your each agriculture production practices, how much water saving technologies that we are using, that will come to a picture. So different countries and global average water footprint, if you see, we are in a much safer position per capita water footprint. But if you see that agricultural goods contribute towards the total water per capita water footprint in the country. So it is very important. Global average is around 1,200. So it is very important that you need to have water saving technologies in agricultural and allied sectors. So how you can assess these footprints for different crop, animal, as well as the livestock products, there are different methods. Actually, what we have done in NINP, we have done the water use efficiency for the dairy production system. So actually, this was basically a field study where we have covered almost 240 farms were covered in this particular field in Karnataka state. And one of the districts which we have covered morning, one of the speaker has already spoken, Kolar Milk Union, which they are getting water from the nearby villages, they are getting through the pipes. That's a scenario. Actually, I have seen that Milk Union, how they are surviving. So it is actually, Kolar is a peculiar district where you can see exactly it is highly water depleted. The groundwater is such low depth, but it is one of the highest milk contributing districts in Karnataka. So if you see, actually there are other factors other than water, because it is, they say it is a milk silk combination in Kolar district that is working, because the people are using the agricultural byproducts for the feeding the animals. That is what their how it is going. But since it is contributing more to the milk, their water requirement is also more. So their water productivity is very low as compared to other districts. So assessment of blue water is what we have done, direct and indirect use. So we have collected this from primary data from smallholders as well as the commercial units. And the water use kg per animal, a liter per animal was estimated, and the use efficiency was calculated using this method. And we have developed a prediction model for efficient water use. And the major variables we found were the ambient temperature, body weight, daily dry matter intake, and sodium intake. So the daily dry matter intake is a very important component. So the another speaker who was talking about the ration balancing of the animal, how from which components these daily dry matter intake the animal is getting, the water productivity of that animal will depend on that. So different factors affecting water use efficiency were considered, and we have considered only milk as the output, not the dung and urine. So the different factors were considered. These different factors were considered. So we have calculated, because this is only a primary data from 240 units, there may be some, it may not be exactly accurate. So what we have come out is, it is a smallholder system is only almost 1% use efficient and 1.62 for commercial dairies. And actually this you can see that, because 1 liter of milk, the average when you get a cup of milk in your hand in the consumer's doorstep, it reaches around 990 liters of water as compared to the 1 liter of milk. But in the farm gate production, if you see, the blue water use is only 92 liters. And that is where I'm telling that when you produce at the farm gate, it is only per liter you are using average 100 liters. Or based on your milk yield, these figures will little bit vary. But when you take it further for chilling, processing, pasteurizing, packaging, and reaching it to the shelves and ultimately reaching it to the customers, it becomes another 900 liters of water added to that. So we have come out with the ranking of different problems that farmers face during that different seasons, and different factors affecting. The seasonal variation is huge, high, and the weather parameters, as well as the quality of water that they get, that also adds. So what are the entry points where you can make some changes and improve the water use efficiency of these dairy production systems? There are 3 points which you can keep in mind: water use efficiency of feed crops, then feed sourcing and feeding management, and the animal characteristics. So because feed crops, how you are growing the crops, whether you are sourcing from different places, because some especially in Karnataka, most of the places, because land is a problem, and fodder is not grown on an extensive area. So what they do is that they buy fodder from further places, so that adds more to their water component. And the productivity of animal, definitely where the productivity of animal is more, definitely their water productivity also will be improved. And the management practices like their ration balancing, and a symbol, because one of my personal experience is that generally farmers, what they do, they will use bucket and hose pipes for cleaning and operational management, cleaning of the cans, cleaning of the sheds and all, and it leads to a lot of water wastage. Actually, one of the dairy farms which I have visited, they are actually using, we all use it for washing our cars, very, very high pressure washer. It actually uses only 1/10 of what a hose pipe is actually using. So your productivity rather improves in that situation. So the message which I would like to give out to all of us who are listening, that produce locally and consume locally for less water use and less impact, because if you want our next generation to have the luxury of water what we are having now, definitely we need to use it judiciously, and because every drop counts, we have to be very water conscious. So thank you. I would like to thank the organizers for giving me this opportunity. Thank you.
Thank you, ma'am. I now invite Dr. Shankar Murthy, Professor of Sustainability Management at NITI Mumbai, to present his views.
Yeah.
Can you stop sharing the screen?
I stopped.
No, madam.
No, I'm not sharing.
Okay. Yeah, now it is unshared.
Yeah.
Try to finish in 10 minutes. We are running out of time.
Sir, we request you to kindly finish your presentation in 10 minutes. We are running out of time.
Yeah. Yeah, can you see my screen?
Yes, sir, we can. Please go ahead.
Okay, okay. Yeah, just let me put it in presentation mode. Yeah, I think so. Good afternoon, ladies and gentlemen. Respected chair and co-chair, and Professor Uday Saha for giving me this opportunity to share my little knowledge, what I have in this area. Like since morning, people have been talking about the water management and how to conserve. I'm taking the other route because we have limited quantity of water and it is finite in nature. And it's, of course, a natural commodity, but still, unless we get good rains, we will not have water reserves available for any industrial production. So I've identified the second source, which is the wastewater. Okay. So whatever the wastewater that is generated from a dairy or any industry for that matter, we should try always to see that how it can be reused. So we have wastewater which is released from dairy. It is reported as the largest from the food processing industry. And then water definitely plays a key role in milk processing, and it is used in every stages of whatever the process or the technological lines, which includes cleaning, washing, disinfection, heating, and cooling. And water requirements are very, very huge, and effluent coming out of dairy usually consists of the wasted milk and water, which is used for cleaning, heating, cooling, and floor washing, etc. So the quantity of wastewater generated in dairy depends upon size of industry, the technology used for the processing, method of cleaning, and the best practices that the industry or the manufacturing process follows. On an average, it has been estimated that amount of wastewater generated for every liter of milk processed is around 2.5 times the amount of whatever the raw material processed. And then coming to the technologies that are usually used for treating, it is said that ASP or activated sludge process is the one which is normally used. But still, the effluent coming out of this may not be fulfilling or meeting the criteria for reuse. So therefore, we should think of some other technology which could bring in or which could make the water or which qualifies the effluent for reuse. Like as I said, any dairy processes raw milk and it is used for consumer milk, butter, cheese, yogurt, etc., etc. And then we have some statistics which I think so I skipped because most of you know it, and they have said, I think so Dharma in his Australian statistics said about the amount of milk produced and then the various products for which it is used. In India, I think so it's liquid milk is about 39%, cheese is about 33%, butter is 32%. And then milk powder is about 6%, and skim milk powder is about 9%, etc., etc. Right? And then if you try to look at the main production area in a dairy system, the primary production of milk on farms, that is keeping the cows and other animals, which actually yield milk for human consumption. And then the second main production area is the processing of milk, which with the objective of extending its saleable life. That means we are trying to treat this to ensure that milk is safe for human consumption and also to improve its shelf-life. And coming to the main operations which are in the dairy products, like we have receiving and testing of milk, then staining, then pasteurization, then ultra high temperature heating, and then packaging and supplying to the consumers. So this is the process flow chart of the dairy industry, which starts from collection of raw milk and then clarification, homogenization, then we have the pasteurization, then it is the temperature reduced, that is chilling, and then we get what is known as processed milk. And then it can go for the human consumption, or it can go for deep chilling, where it is kept in cold storage for longer shelf life, and then it is dispatched. Coming to the various sources of wastewater that is generated from a dairy industry, we have three main streams coming from a dairy industry, that is processing water, which is used for all the cooling and heating purpose, etc., etc. And then cleaning, which includes cleaning of utensils, cleaning of various parts, then the floor wash, etc., etc. And then the sanitary waste that is coming from the sanitary units. The major sources of BOD. BOD is one of the parameters which measures the strength of the wastewater the strength of wastewater where the impurities or the pollutants are organic in nature. Okay, and this come from cream, butter, and cheese section. And also dairy effluents include dissolved sugars. And to some extent, they also contain pathogenic microorganisms, which are disease causing in the human beings. So therefore, we do what is known as pasteurization, which kills all the pathogenic bacteria. And the typical characteristics of wastewater is the BOD content in the wastewater that is generated from any sugar in any dairy industry. And the average is ranging from 0.8 to 2.5 kilograms per metric ton, that is kg per ton of milk, which is untreated. And then COD ranges, COD is approximately 1.5 times the BOD. And it is highly organic in nature, and we have total solids and other things. So this is, in short, the characteristics of the different products from a dairy. I'm just trying to maintain or respect the time. So I might skip a few slides. Okay, please bear with me. So treatment options for dairy waste, as I said, it's biological in nature because it is highly organic in nature. And usually this is the various steps used: segregation, screening, equalization, pH control, fat removal, BOD removal, and then final disposal. We have the pre-treatment is essential in order to make the wastewater amenable for biological treatment, because it is mostly consists of organic, the pollutants in the form of organic pollutants. But still, there are few pH adjustment, and then, like for example, the equalization has to be done in order to see that there is not much fluctuation in the characteristics, and also to some extent this fog, that is fat, oil, and grease, has to be removed, which might act as a barrier for the biological treatment. Okay. So here we do screening and then pH adjustment by using either, like usually the dairy wastewater is alkaline in nature. So therefore, because of we use a lot of alkaline detergent or detergents which are alkaline based, and this can be, pH can be adjusted by using low or weak acids, and this is a typical chemical characteristics of different dairy plant wastewaters. So another important pre-treatment is flow and composition balancing. This is essential because the wastewater is coming from different units or different operational processes or different sections, and it varies with respect to volume, strength, temperature, pH, and nutrient level. So if all these things are equalized in a balancing tank, maybe for about few hours, then you will get a wastewater which is almost having some or the fluctuation of these parameters will be within a narrow range. Okay. So we like, as I said, this fog has to be removed because it might have interruption in the biological treatment. So this can be done either by gravity traps or air flotation, or you can enzymatic hydrolysis also we can go for. The other option, or the option available for dairy wastewater treatment, is like, as I said, it's highly organic in nature. So it's predominantly biological treatment. Both we can go for aerobic biological systems or anaerobic biological system. See, there is one thumb rule which by which you can decide whether this can be treated biologically with or without pre-treatment, or without acclimatization of the bacteria or microorganisms in general. If the ratio of BOD to COD is greater than 0.6, which most of the dairy wastewater, the combined dairy wastewater comes around 0.6 or 0.7. Okay, so this can be easily treated without even acclimatization of the microorganisms. See, these are the common systems by which you can treat the dairy waste. I think so. I'll touch upon only one or two, not much. This is simple flow diagram for activated sludge process. This activated sludge process is a proven technology which is more than 100 years old, but it consumes a lot of energy. So we have the pre-treatment done with all screens and removal of fog, and then removal of even suspended solids in the primary treatment tank. And then it comes to aeration tank where you are supplied, it is supplied with the compressed air, and then the degradation takes place, and then the solids which are separated are removed in these secondary sedimentation tank. Effluent goes out, and part of the sludge is put back into the system. So that's why it's called activated sludge process. Why it is called activated sludge process? Because I'll tell you with the help of another figure. So this is basically the entire process, primary as well as secondary process. And we have suspended growth. It's also called suspended growth, where we have either surface aeration or you have diffused aeration. And commonly the treatment is monitored by observing the FM ratio, that is food to microorganisms ratio. Food here is the food available as substrate, as organic matter, substrate or organic matter present in the wastewater, right? And plus it also requires for any biological growth, it has to survive and multiply. So they require a lot of energy, organic molecules and some of the building blocks where they can get these from the complex organic matter, which constitutes carbohydrate, proteins, and fats.
Could you please wind up with the working units, please?
Okay, sir. Okay, so the name like activated sludge process is derived from this. This is the graph of biological growth taken from a reactor which is not continuous. Okay. And whatever the sludge we are returning, part of sludge, that is the microorganisms, they are in logarithmic phase. So they multiply faster and then they can degrade. So this is how it looks. And we can see clearly this is the influent. And then after aeration, it like solids can be separated in secondary sedimentation tank. I'll skip. Of course, another very important is the sequence batch reactor, which we can do it in one particular reactor: fill, react, settle, decant, and then idle. Like all 4 stages can take place in one reactor, and then the COD removal is more than 95%. Of course, membrane bioreactor I'll not touch upon. Anaerobic, I think so, I'll leave it. The important thing which I wanted to share is if we can use some special enzymes whereby the quality of effluent improves, we can, it has got more or it is the best candidate for reuse. Like in some of the small laboratory scale experiment, I've used Actizyme, which is originally from Switzerland, and then BioClear. These are the commercial names given to these enzymes. And the dosage is very small. And this is in granule media material, and the BioClear is in liquid. Okay, this is the role of enzyme. And we used on various industrial wastewaters. Like for example, this was experimented on vegetable oil waste for this characteristics. You can see the BOD is 650 and COD is much, much higher. And this is a simple experimental setup what we had. You can see the COD, BOD reduction, the typical curve what we see in Metcalfe and Eddy. only I would like to say that overall BOD removal efficiency of 89.18% and almost 95%, and overall COD removal efficiency was 93 and almost 98%. Okay, using this both the enzymes. Okay, and we did another experiment on the spent wash, which is supposed to be the highest, or it is the most strongest wastewater, having very high strength. Like for example, if you look at COD, it's more than 85,000, and BOD is around 45,000. And we used different reactor configuration, and what we got results was the COD removal efficiency was more than 90%, and BOD removal efficiency was more than 95%. And then the biogas production increased by 13% as compared to the conventional treatment. Okay, and we also did some work on domestic sewage, whereas the results what we got was very, very within the limits of the disposal standard which was proposed by the state or central pollution control boards. And these are the national minimum national standards for daily effluent disposal, or it is the capacity by which whatever the systems you have, it should treat up to this level. Okay, so this is what I thought I will share. And then there are several preventive measures which we can take up in dairy also. I think so. This I've shared my PPT with the organizers, and it can be shared with all the participants for their consumption. Thank you, sir. Thank you. That's it. I'll stop sharing. Yeah.
Thank you, sir. Now I invite Dr. Ashutosh, Dairy Specialist at NDRI Karnal, to present his views. Sir, we request you to kindly stick to 10 minutes.
I'm audible.
Yes, sir. Yes, sir, you're audible. Please continue.
Yes, respected dignitaries and dear colleagues. First of all, I will thank to management of this IRMA to give me an opportunity to present my work in this international conference on water management in dairy sector. So, in this regard, many scientists and dignitaries have thrown light on different issues related to water usage. So I would like to present my work which we have done at NDRI as a solution. We have developed some products in this regard. So first of all, I would like to take your attention on 1 cup of tea. If you are consuming 1 cup of tea, it means you are consuming 32.4 liters of water, and the data is given here. Now, again, some dignitaries have also presented about the water, so I will not take much time about this. So we have this much of water on our globe, and out of that, the fresh water is only this much. And water availability, if you see, so here different data is given for annual precipitation and total reserves, but we are more concerned about this waste and sewage water, which is 16.24 trillion liters. So if we recycle this water, up to some extent we can solve the problem. And similarly, as Dr. Leta has given the explanation, so these are the water footprint of forest growth, and per capita per year is this much. And India falls in lowest because due to population and water availability, this is the lowest as compared to the US or China. So we have little bit lower footprints in terms of water usage. Now, what is the situation of India in fresh water? That is, Indian economy is driving increasing water usage because more industry is coming up, so we need more water. Then measures for treatment and management are existing for fresh water resources are being followed. As industry will grow, definitely there will be a generation of wastewater and pollutants. Similarly, increase in per capita as we are upkeeping our living of standard. We are going out, we are going for outings, we are going for air travels. It means we are increasing the water utilization per capita. So in rural areas, there is lower water usage as compared to urban areas. Then fresh water rich regions or water abundant areas, they are not caring about these water alarms and water scarcity situation. So they are going on wasting. So similarly, if we see the total water usage in agriculture system, that is around 89%, and out of 89%, we are using 29% of water in animal production system, which is quite a high quantity as compared to other sectors. So it means we have to emphasize on this 29% of water, and we have to find the ways how we can reduce or we can economize this use of water. So if we see the scenario of 1975, we were at adequate level. If you see the map of India, then in 2000, we were under little bit stress, but nowadays our 27 districts, they are under dark zone, and PMO is taking care of those 27 districts at footwall level. Now we are coming to our daily production system. We need water for 2-3 purposes. One is direct drinking water, another one is service water, and third one is for feed and fodder production. So we can see from this slide 3 types of water, and we cannot compromise on feeding of the animal. We cannot compromise on drinking water, but we can have some interventions on this usage of water, that is surface water. We can reduce this water in mist system, in free flow and generation of wastewater. And very interesting fact about this drinking water and service water, we have calculated based on 18th livestock census, annual water requirement for total buffalo, total cattle, and all non-descriptive and other types, we need 23.8 billion kiloliters of water annually. So we can have some interventions here in services water. So if we see it is the normal routine in a organized or unorganized form, the taps are running or leaking. So if a leaking tank is that we study, the leakage of moderate level can generate 17.27 cubic meter, means 1 cubic meter always means 1000 liters of water. So around 17,000 liters of water you are losing if your tap is leaking, and this work is carried out at our station. If we are opening the tap as you are seeing in the organized form, the tap is running 24 hours to supply the drinking water. Suppose you are having 100 animals in a paddock and one tap is running. If animal is consuming maximum 50 liters of water in 24 hours, it means you are just using 5,000 liters of water for drinking purpose. But if you are open this tap for 13 to 16 hours, you are drawing 28,000 liters of water, which is far more than your utilization. It means rest 23,000 water is being converted to the wastewater, and which is further creating havoc in terms of disease, mosquitoes, and to manage that wastewater, you have to create so much of infrastructure. And these things are very common in village. You can see the farmers or dairy farmers, they are generating wastewater, but for handling that wastewater, which is being generated from the fresh water, underground fresh water, the panchayats, districts, they are investing so much of money. So here we have developed this system, and this system is working in our institute at NDRI Kathiawar. This is the inlet, whatever you are receiving from the Kathiawar. Here we have developed 3 tank system here, and here we use Persian wheel system with motorized system, so that the polythene, some gunny bags like these, which are coming in the wastewater from the Kathiawar, that cannot be pumped out with the help of a borewell or a pump. So for that purpose, you need to lift the water and you have to see it through a net. So like that we have developed, and now you can see the quality of water coming out from these 3 tank systems. So we have developed this, and this water will further be purified with 3 steps. Coagulation, because the water purification, we are not using expensive equipment. We are giving this or develop this technology keeping in view the status of farmer. Means whatever farmer is having with him, that can be utilized to save more water. If we save more water at every door, in every village, it means we can save a significant quantity of water at a time in whole of the country, particularly in rural areas. But in urban areas or rich organizations, they can arrange filter system, they can arrange membranes and so many things. But here you can just use the potash alum or caustic soda or sedimentation. Then for disinfection, you can use sodium hypochlorite. And I am explaining the method how we can do from a water source, that is wastewater source. You can take samples. Then these samples for 20 to 30 minutes, you can add with hydrated alum, and then after settling down, as you see in these beakers, because I am just giving a small level system, then you can stir it and you can add activated charcoal or dung cake ash, because dung cake ash is available with farmers. So you can use this dung cake ash instead of charcoal. So after this, you can filter this water with a simple clove, and then this will come out, and you can add 1% sodium hypochlorite like this. And we have given that chart, and total cost per liter is around 13 paisa. And these are the biological these samples studies. These are with without adding sodium hypochlorite, and these are disinfected water. It means this water is more or less comparable to.
Excuse me, sir.
Comparable.
Dr. Ashutosh, sir.
Okay. Now, this is comparable to all international standards as you are seeing on the screen. Then, similarly, these were the treated water samples, and these were the different standards, and our sample was fit in all respects. And these are the different micro and macronutrients, nutrients in controlled water and treated water, which is more or less comparable with fresh water. Now, at medium level, up to 500 liters, you can take this water, and by adding different additives, you can take this fresh water full tank, and all debris are settled down. Another system for continuous, where you want to use 2000 or 3000 liters, here we have developed some 3-filter system, and from here, ETP plant or sewage water plant, you can take this in tanks, and fresh water is coming out after passing through these filters. And these filters are not membrane or anything. These are from the material available with the farmers, like coconut husk, then pebbles, then Yamuna sand, and this coal. So we have fixed the different ratios to clarify this water, and we are getting this. And after adding sodium hypochlorite in this water, we can use in drinking purpose. And another factor, one is recycling of water. Another one is how we can use underground water from free flow. So we have developed this system with meter, water meter, domestic water meter. And here we have put one wall with one hole. And here we put simple wall cock, which is fixed in overhead tanks of our houses. And whatever cow is consuming, that much water will be released, and that automatically it will be fed, and it will not release any water when this level will be achieved. And this whole system is under this structure. Similarly, for bulls, we can have same structure. So we are just avoiding the generation of wastewater and saving the groundwater. Now, you will be surprised to know the cost of operation. If we spend 1,500 rupees per half-inch tap, and expectancy of this system is 2 years. So it is the calculation, 1,500 rupees means this much paisa, and we can save per day 20,000 liters. So in 730 days, we are saving 1,46 lakhs of liter water from a single tap. Now you can estimate how much we can save with this. Another system we have developed at NDRI in our workshop, the air pressure water, and we are using only 25 to 40% of water as compared to those pipe or other systems. Like that, we have calculated that we have all data. And this you can see in the rural area, these are the happenings and how these water is being utilized by the farmers and what quality of water animal is consuming on daily basis. So in this way, we have done some work and which is adopted by many farmers in Rajasthan area adjoining to Haryana, that is Western Rajasthan. And these are some samples before and after our system, and red are showing higher values, and here these values come to normal values. And these are the biological rules according to different standards. And these are the samples from Rajasthan, different locations. Now, these are the water intake which we have calculated, and this is secondary data which is given in literature. So for different breeds of cattle, lactating, non-lactating, we have calculated. Similarly, for fodder production, which is very attractive area, how much fodder we need per day, how much water it will supply to the animal in addition to direct water intake, and how this wastewater can be used in crop production. And we have grown this these experiments on 70 acres of land, and these are using these are the yields using fresh water, and these are the yields using sewage water. So here you can say, see, the multi-cut or hybrid fodder crops are not supported by this, although our indigenous crops are supported by this sewage wastewater. So we have to take care while using wastewater in hybrid crops or multi-cut crops. Similarly, next year's 70 acre data, these are the same, and these are the water intake, and these are the water intake of different animals.
Major.
Like that, we have all data, and like that.
Hello.
Where that is.
Hello. Hello, Dr. Saab. Can you please conclude? Please, Dr. Ashutosh.
Yes.
Please, can you conclude? We are dealing.
Yes, 2 slides only left. 2, 3 only left.
Okay, sir. Please.
So, here. Please unshare. Yes. Yes. I'm again sharing. Just 2 minutes left. Only 2 minutes left. Yes. So again, we fixed this system to one of the oldest Gaushala in Agra, that is Radha Swami Satsang, and they have issued the appreciation letters to NDRI that they were very much benefited by our technology of water devices. And these are the complex, we are sensitizing farmers about this technology. And these are the photos, if we are not attentive at this stage, we have to develop such type of systems of step wells as occurred in ancient India to solve our problem. And for this work, we got Global Water Award this year conferred by one multinational agency, that is Energy and Environment Foundation. And the award was conferred by Honorable Judge Minister. And we thank you very much for this.
Thank you, sir. That was an enlightening educational session for all of us. I thank all the presenters for sharing their views. Now we move to the second technical session, which is the Young Scientist presentation. I take the honor of introducing the jury for the session. Dr. N.D. Jhala, Director of Research, Anand Agricultural University, Dr. K.C. Supekar, Managing Director, NCDFI, and Shri Manoranjan Pani, Senior General Manager, Sales and Marketing, GCMMF. I request Dr. Smita Mahapatra to kindly felicitate the jury. This session would be a research work presentation competition. Each presenter will have 2 minutes to present, followed by a Q&A round of 2 minutes. We start the session by presentation of Dr. Pratik Ramesh Wankhare.
Good afternoon, sir. Hello.
Please go ahead.
Yes, sir. Thank you, sir. Sir, does the slides are visible, sir?
Yes.
Okay. Thank you, sir. So shall I start?
Please start.
Okay, thank you, sir. Thank you so much, sir. First of all, very warm good afternoon to one all, and thank you to the organizer for this opportunity. My name is Dr. Pratik Ramesh Wankhare, and my topic is consumptive water uses in the milking parlor at organized dairy farm. First of all, since morning we have seen what is water, what is water footprint. It is nothing but the amount of water through direct and indirect ways utilized for the production process. Like in our case, it is a mill. There are mainly three methodology for the assessment of water footprint, like volumetric water footprint approach, life cycle assessment, and water productivity. In this study, we have used the volumetric water footprint approach because there we have measured the water usage in the milking parlor directly through the utilization of water meter. First of all, the study is conducted at our own milking parlor in Upper Gangetic Plain of our institute. The duration of study was of 11 months, which was again subdivided into three different seasons like summer, rainy, and winter season. The management and the study animals, we consider lactating animals. Lactating Vrindavani, Vrindavani is a crossbreed breed. Vrindavani machine milk and hand milk cows, Tharparkar, Sahiwal, indigenous cows, and buffalo, Murrah buffaloes. The animals were separately kept into loose housing system as per the BIS space recommendation. In the milking parlor, all the animals were provided with a 3 meter square surface area. All the animals were cleaned and washed into separate washing unit before entering into the milking parlor. Then the milking parlor surfaces were cleaned and washed with the help of the dung was scraped with the help of scraper and cleaned after each milking by using 1.5-inch hose pipe, and the water uses were measured utilizing the water meter. The milking equipments and the utensils were combinedly washed into separate washing unit. So their water usage is recorded separately. The general linear model we use to test the significance of the data, and values are explained as liter per animal per day. Result. As the study period was divided into three seasons like summer, rainy, and winter season, different meteorological parameters like mean ambient temperature, mean relative humidity, and precipitation were recorded during the study period. Then the water uses for the cleaning and washing of the milking parlor surfaces. Tharparkar and Sahiwal cows required significantly higher water uses, followed by Vrindavani machine milk. Vrindavani machine milk, this red one. Then buffaloes, Murrah buffaloes, and Vrindavani hand milk cows. There was a significant influence of season, as we can see higher water uses during the summer season, followed by winter, and followed by rainy and winter season. Then as the milking utensils and these equipments are washed separately, we divided into 2 times milker and 3 times milker. As Vrindavani machine milking cows, they were milked 3 times a day, and remaining animals like Tharparkar, Sahiwal, Vrindavani hand milk, and Murrah buffaloes were milked 2 times a day. So 3 times milker obviously required significantly higher quantity of water. There was also significant influence of season on the water requirement for the washing of equipments and utensils. Then the total water uses in the milking parlor. It is a combine of water uses for the surface, water uses for the washing of surfaces and equipments. In this also, Tharparkar and Sahiwal cows required significantly higher quantity of water, followed by Vrindavani machine milk, then Murrah buffaloes, followed by Vrindavani hand milk cows. The season had significantly influenced the water uses in these animals. Higher water uses during the summer season, followed by rainy and winter season. Then this is the lactic water uses as per. Sir. So milk yield, as the machine Vrindavani machine milking cows, they were high yielders, producing more than 14 kg of milk. Then followed by Vrindavani hand milker, then Murrah buffaloes, then Sahiwal and Tharparkar cows. There was no season, as these are study animal. We did not only except in the Sahiwal cows, other groups they did not have any significant influence on the milk yield. Then the water uses per kg of milk produced. As Vrindavani animals, hand milk and machine milk were high yielder compared to the other breeds of animal, Tharparkar and Sahiwal cows. Higher water uses per kg of milk produced were observed in Tharparkar and Sahiwal cows, followed by Murrah buffaloes and Vrindavani cows. then the water uses per the area provided into the milking parlor, all the animals were provided into equal amount of area of 3 meters square. However, higher quantity of water were recorded in Tharparkar and Sahiwal cows, followed by Vrindavani machine milk cows, Murrah buffaloes, and Vrindavani hand milk cows. One thing I want to mention here that why these higher quantity of water is observed in Tharparkar and Sahiwal cows is because very less number of animal compared to Vrindavani machine milk 80 number of cows, Vrindavani hand milk 65, Murrah buffalo 63, and only 22 and 9 number of Tharparkar and Sahiwal cows were present into the study. Due to this reason, the per animal share of water uses was higher, were higher in Tharparkar and Sahiwal cows compared to other breed of animals. Then these are the previous repeated value compared to our study. Only in this study, Hingam et al. They have reported higher quantity of water than our study because they have calculated in the pasture-based grazing system. However, very less quantity of milk water were reported in other study like in automatic milking system or double herringbone parlor or rotatory parlor system. Then, in conclusion, the water used in the milking parlor was affected by the number of animals and the frequency of milking. As higher number of milking followed in the Vrindavani machine milking cows, the season has significant influence on the water demand in the milking parlor. Compared to these Tharparkar and Sahiwal cows, Vrindavani cows and Murrah buffaloes were more water efficient. Thank you.
I have just one query because the sampling in all the 4 breeds which you have included in your study, number of variation in the number of animals is so vast. So whatever conclusions you make, do you think that it is a valid conclusion?
Sir, based on the number of animals available at our farm, the conclusion was made on the basis of that only, sir. Because it was the study was conducted at an organized dairy farm. So the conclusion drawn are based on the our observations, sir.
Okay, and the second thing that, of course, you have found some correlation between the season and the consumption of water or water usage, right?
Yes, sir.
Probably the reason, or how would you correlate? I mean, the reasons behind that. That in particular season, suppose you have found higher. So the obvious reasons, I mean, with a physiological sense or other parameter, can you correlate your findings?
Yes, sir. Because, sir, why I have recorded the meteorological parameters also, because during the summer, compared to summer, rainy and winter season, sir, there will be, due to the higher humidity, many a times the floor remain wet, sir. So whenever we perform milking, after finishing milking, we are washing those surfaces. So as those surfaces were wet due to higher humidity, less quantity of water were consumed for the washing purpose, sir. So this was our hypothesis behind this correlation.
Okay. So
this was our hypothesis, and subsequently, from our result, we proved it also, sir.
Okay. Any questions? I mean, participant? Yeah.
Hello, Dr. Asutosh. You say you have taken the sampling where you have included buffalo in the sample of cows. Any particular reason of taking this common sampling of buffalo and cow? And second, do you find some correlation after taking the buffalo sample in your sample, but what is the outcome? Means you compared buffalo with cow, but what is the exact reason of taking this sample?
So first of all, we targeted the milking parlor, sir. So in our milking parlor, all the cow we have in our milking parlor, we have separate wings where all the animals were milked at a time, sir. So there was no hard and fast rule, but all the animals were milked together. That's why we consider buffaloes also together with the other breeds of cow while the measurements, sir. Then yes, sir.
Might be different from cow. Have you considered that?
Sorry, sir, I didn't get your question, sir.
Logical requirement of water of buffalo
Yes, sir.
from the cow. Have you considered that in your presentation?
Yes, sir. I compared cows, the breed of cows with the buffaloes also, sir. Murrah breed of buffalo we consider that we compared with the Vrindavani Tharparkar Sayolo breed of cows also, sir, at the time of analysis.
Okay, thank you.
Yes.
Hello.
Presenter is Dr. Francis.
Dr. Francis, please go ahead.
Hello, it is audible?
Audible.
Okay, my presentation is visible, sir.
Yes, please go ahead.
Sir, can I start now? Sir, can I start now?
Please begin.
Okay, good afternoon to all the panelists and the jury members present over here. I'm moving to the topic directly: physiological, hematological, biochemical, and molecular responses of native gods for the efficient water utilization in different agroclimatic zones. And as we already know that livestock production is an intensive water consuming activity, and the quality and the quantity of the water affects the livestock production. And we know that among the livestock population, goats are the efficient water utilizers. And coming to the India and the goat population, India stands second in the goat production in the world, and more than 70% of the goat population thrives in the arid and semi-arid regions. And many of these adaptations like physiological, morphological, etc. help these animals to survive in these climatic zones. And we know that the coming decades are due to the intensified global warming and erratic patterns. Water scarcity is inevitable. So we already know that by the by 2025, it is said that about 2/3 of the world's population is going to be living in water-stressed regions, and this is going to affect the human population along with the animal population. Understanding and exploitation of the full genetic potential of the native god breeds is required for developing the new strains of breed for the coming decades. So the experiment was studied, carried out with the objective to study the hematological, physiological, biochemical and molecular adaptations of the native gods in the arid and semi-arid areas, and we studied on the two god breeds, Barbary and Sirohi. And we also studied the seasonal variations in the adaptive response of the native gods. And coming to the materials and methods, we divided the experimental animals into 3 groups, consisting of 10 animals in each group. Group 1 consisting of 10 animals from the Sirohi breed of god from the semi-arid region, that is from the UP. We collected the samples from the CIRG UP. And group 2 consists of 10 animals from the Barbary breeds from the semi-arid region. And 3 consist of the 10 animals from the Sirohi breed of god from the arid region. And all these animals were of 1 to 2 year old and non-gestating healthy animals. And we collected the sample during the winter season and summer season, and we measured the physiological responses of blood temperature, respiration rate, pulse rate and skin temperature. And we considered hematological parameters of hemoglobin, packed cell volume, total erythrocyte count, total leukocyte count, and plasma electrolytes of sodium, potassium and chlorine, and plasma hormone levels. And also we considered blood urine nitrogen, glucose, and also we studied on the gene expression studies. Gene expression studies was carried out in vitro as we collected the skin explants directly from the Sirohi and Barbary breed, and we established the skin fibroblast cell lines in the lab. And these were treated at different temperatures of 25 degrees Celsius, 37 degrees Celsius, 45 degrees Celsius, and two hyperosmotic conditions at two temperatures, that is 37 degrees Celsius and 45 degrees Celsius. And we carried out the expression analysis. Coming to the results of the gene expression studies, as we know, when we compare the gene expression studies, the relative expression of aquaporin, we studied on the three aquaporin genes. As we all know that aquaporin genes are responsible for the expression of the aquaporin water channels, which are responsible for the movement of water across the skin membranes. So we studied upon the aquaporin 1, 3 and 5. Out of this, aquaporin 1 and 5 are selectively transporting water, whereas aquaporin 3 transport water along with some solutes. So when we studied about the expression of these genes in the Sirohi breed, we found out that there is an increased expression of the aquaporin 3 and aquaporin 5. And their increased expression of aquaporin 3 at a high temperature, that's at 42 degrees Celsius, it is seen, and it may be as an adaptive mechanism of these Sirohi breeds to maintain the skin hydration status. And when we move into the high temperature, there's hyperosmotic conditions at the normal temperature. There was also a significant rise in the aquaporin 3 expression. But when we consider the aquaporin 5 expression, this was increased during the high temperature. But when we consider to the hyperosmotic condition at normal temperature, the aquaporin 5 was found to be decreased, as aquaporin 5 plays a role in the sweat physiology. So this may be a mechanism due to the decreased sweat production in the hyperosmotic conditions, as this hyperosmotic condition was induced as given as a treatment to mimic the dehydration status of the animal. So maybe this is a decreased expression of the aquaporin 5, maybe because of the their mechanism to reduce the sweat production, or and thereby conserving the water mechanism. And moving to the expression patterns in Barbary breeds, altogether when we consider the expression of the aquaporin genes was lower in the Barbary breed, and the expression patterns which are seen in aquaporin 3, it was similar, that it was increased, and aquaporin 5 was also showing an increase at high temperature. But as hyperosmotic conditions in Sirohi breed, they showed a lower expression of the aquaporin 5. But in the case of Barbary breed, it showed a higher expression of the aquaporin 5. That means these Barbary breeds has a lesser tendency to conserve water. That means there is more sweat, more water loss through the sweat mechanism, Then coming to the physiological responses, we considered the physiological response of the breeds in winter season and summer season, and in two zones, semi-arid zone and arid zone. In the semi-arid zone, there was an increase in the physiological responses from winter to summer in irrespective of the breeds, and the variations we seen in the summer to winter, the physiological responses were very less compared to the Barbary breeds. And we can see that all the height and the skin temperature and nectar temperature of the Barbary breeds was found to be high, and this was considered as an adaptive mechanism of these Sirohi breeds to those arid conditions where there is waterless conditions, water scarcity, and also in the high temperature. And it is said that those breeds which is having a high core temperature, this will have the water loss will be very less. So the high core temperature maintained by the Sirohi breeds is a mechanism to reduce the water loss. Then seasonal variations which were seen in the arid and semi-arid state, there was less seasonal variation, less variations between the arid and semi-arid breeds like Sirohi breeds. Coming to the hematological responses, all the hematological parameters like hemoglobin, packed cell volume, total erythrocyte count, and total leukocyte count, these was found to be decreased from winter to summer in both the Barbary breeds and Sirohi breeds. And another important factor, we found out that there was less significant variation in the total leukocyte count in the Barbary breeds, and this is due to that the Barbary breeds are facing less stress in the arid conditions, even though there is water stress. Because we know that the stress, whenever there is a stress, the cortisol is being produced, and this cortisol will result in the increase of the total leukocyte count. But due to the decrease, as we know that the Sirohi breed is adapted to these regions, the cortisol production is less. That this may be according to the very less variations in the total leukocyte count. Then we can see that here there's like all comparing the seasonal variations of the hematological responses between the arid and semi-arid zone of the Sirohi breeds. We can see that there's less variations between the all these hematological parameters, showing that this Sirohi breed is well depicted to survive in the semi-arid zone. Coming to the blood electrolytes, it shows that there's a like sodium and chloride concentration was increased from winter to summer in the Sirohi breeds and Barbary breeds, and but the potassium showed a decreased, and that means it's decreased from winter to summer. And the decrease of the potassium was found to be higher in Barbary breeds, depicting that there was a higher loss of potassium through the sweat. Maybe through the sweat in the Barbary breeds. That means higher water loss has been found in the Barbary breeds from winter to in summer season. But the Sirohi breed showed only very less variations in the potassium excretion or potassium levels. This depicts that.
Francis, time is up. Yes. Judges. Hello, Dr. Francis.
Yes, sir.
With regards to the gene expression studies, what you have done under in vitro condition, right? And you have observed certain variation in expression of EQP3 and EQP5. Now, what could be the real application of this finding? Because whatever under experimental condition you have found out, right? The expression, upregulation or down-regulation of certain.
Yes, sir.
Primary concern is to reduce the usage of water or the need of the water.
So, in coming decades, we know that there's water scarcity. So if we are developing those breeds which will use less water or which requires less water, it will be helping into sustain the livestock production in coming years. As we all know, we have intensified our milk production system using more crossbred cows, but these can survive very less in these water scarce conditions. So if we are using these genetic manipulations in the coming in devising the breeding policies, it will be helpful for us to sustain the milk production and sustain the animal productivity in coming decades.
It's okay, but see, the particular breed, when it is established for generation of a particular environmental condition, it's arid condition or semi-arid condition. Okay, so the physiology of the animal and the genetic pool is already as per the stress, and certain genes are already accustomed to perform to the best of the environmental stress conditions. So that is in balance already in a natural track of those animals. So how do you explain in this regard?
So we have to do more experiments on in vivo, directly collecting from skin samples and looking on these things. And we have to we have to select those breeds which are more expressing these which are having more water conservation through the manipulation of these genes, sir.
Okay, thank you. Any other query? Dr. Francis,
yes,
because you couldn't complete presentation, can you just share your finding, how it was relevant to the topic of water resource management?
Okay, sir. So I will just share the conclusion part, sir.
Yes. Yes.
So there was Sirohi breeds was found to have according to my research work, it was found that Sirohi breeds was found to have high blood urea retention capacity and was able to maintain the glucose level despite of the poor quality forage and less water availability. And the Sirohi breeds of the arid region showed less variations in all these responses like physiological responses, hematological responses. All these responses, the Sirohi breeds in the arid region depicted or showed only very less variance. This means these breeds are well tolerant to survive in this like water scarce conditions. So we can also see that the level of the aldosterone, all these hormones were set high with high in these animals. So these animals are set up like to survive well in these water deficit areas. So if you are understanding the or more understanding and more studying on the like genetic potential and more studying on these responses will help us to devise the breeding policies, future breeding policies, such that we can maintain the productivity of the population in coming decades. It is of the like wherever when coming decades, whenever there is a water scarce conditions.
Okay. What was the sample size of your study?
Yes, sir.
Sample size.
So 10.
Only 10.
So 10 animals. So we took like 10 animals from 10 animals of each breed from arid zone and semi-arid zone, sir.
Okay. Do you think the sample size is right to conclude?
So there was some limitations of the availability of the Sirohi breeds in like semi-arid region, and also there was limitation for availability taking Barbary breeds from the arid region.
Thank you. Next, Dr. Kumar. Please go ahead. You need to unmute yourself. We can see the screen, but you need to unmute yourself. You are not audible.
Hello.
Yes, you are audible. Please go ahead.
Is it visible, sir?
Yes, it is visible. Please go ahead.
Okay. Very good afternoon to all of you. I, Gaurav Kumar, belong from Uttar Pradesh. I have completed my UG graduation from College of Veterinary and Animal Science, Meerut, and master from National Dairy Research Institute National Dairy Research Institute, Karnal. Now I am pursuing my PhD degree from NDRI itself. Today I am going to present a small oral presentation on my research work on topic effect of treated wastewater intake on physiological growth and health parameter of crossbred lactating goat. As we all know that Earth is also known as a blue planet because about 71% of Earth is covered with water, out of which only 2.5% of fresh water, and our country represents about 20% of world's livestock population, but only 4% of world's water resources present in India. And also the availability of water per capita decreases day by day. At present the availability of water per capita is about 1486 cubic meter, but it is expected to further decrease up to 1140 cubic meter by 2050. It clearly indicates the critical crisis of water in our country for livestock as well as human beings. So the need of reuse of treated wastewater for increasing the efficiency of water. Introduction. Water is important nutrient of sustaining life to optimize the milk production and growth rate and reproduction of livestock. Mainly three sources of water for animal and as well as human being. First, by direct water intake. Second, water in feed. Third, water produced during the metabolism. Factors affecting water intake. Many factors affect the water intake, mainly environmental temperature. Higher environmental temperature requires more water. Quality of water, poor quality of water requires lower water intake. Supreet, according to Supreet in 2018, discovered higher concentration of aldosterone, ADH, and angiotensin second present during the summer season. During the summer season, here showing the plan of work of my research work. For my research trial, I have collected treated wastewater from effluent treatment plant at NDRI, which is treated with alum at the rate of 1 gram per liter, which coagulate the impurities present in the water, and add 0.5 gram of activated charcoal, which absorb the impurity and settle down to the bottom. After that, filter it and add disinfectant at the rate of 2.5 ml per liter, and also select 12 healthy crossbred lactating goats and divide it into 2 groups, control and treatment. 6 animals in each group. And in control group, feed offered as per standard management practices in LRC, and drinking water, normal drinking water is provided. In treatment group, treated wastewater provided as a drinking water, and the sample collection at the fortnight interval. Here the comparison of treated wastewater parameters with control and dairy NRC standards. Total derived solid salinity, pH, and turbidity are significantly different with the control group water parameters, and these values were found under the range of dairy NRC standards. Here the physiological parameters of physiological responses were numerically higher in the treatment group than the control group, but it was non-significantly changed, and the values were under the normal range of the physiological parameters of goat. The values of growth parameter were numerically lower in the treatment group, and then the control group. Here the graphical representation of hematological parameters were found non-significantly different with control group, and these values of hematological parameters were found under the normal range of hematological parameters of the goat.
Please conclude.
No significant difference was observed in physiological responses like heart rate, respiration rate, rectal temperature between control and treatment group of crossbred lactating goat, and hematological parameters and total erythrocyte count, total leukocyte count, packed cell volume, erythrocyte sedimentation rate, and hemoglobin between control and treatment group also were non-significantly different. No significant difference were observed in the change of growth parameter, body weight, length, height, heart rate between control and treatment groups. Conclusion. Based on observation of the study, purified wastewater can be provided as a drinking water to the lactating goats without any detrimental effects on the physiological and productive performance parameters. Thank you, sir.
Dr. Gaurav,
Yes, sir.
you have collected along with the blood fecal samples also, right? So what?
Yes, sir. For parasitological examination.
You have not presented any result of it. I mean, in both the groups, control and so why it was collected and what was that?
No, sir. I found there is no significant variation on parasitological parameters of the goat in control and treated group.
Basically, my question is why fecal samples were collected?
Because sir, treated wastewater contain microbial contaminants
Because
and parasites also.
sample analysis.
Yeah, sir. X of parasites.
Okay. Second question is, of course, your finding says that purified waste water can very well be used, right? And that's an important finding, actually. But that is concerning the goats. Now, of course, our concern is water management in dairy sector, where contribution of goat, as you know, may not be that significant if we want to really apply it for the whole dairy industry. So, if this same, do you think that is applicable to the cow and buffaloes also, cattle and buffaloes?
Yes, sir. My senior Dr. Ankita Rautula worked at large animal, cattle and buffaloes.
No. So the same thing would be applicable probably in cattle and buffaloes also?
Yes, sir. Yes, sir.
Okay. Thank you. Other question?
Next, we have Dr. A.B. Parmar.
Dr. Parmar, please go ahead.
I'm audible, sir?
Yes. Please go ahead.
Is it visible, sir?
Yes.
So, good afternoon to respected jury members and dear participant. I am Dr. Abhishek Parmar from the Animal Nutrition Research Station, AU Anand. And today I am here to deliver my presentation on the research work influence of feeding formaldehyde treated guar meal and krill fed supplementation on water intake and the water requirement of growing dairy buffalo cows. As we know, in the livestock production, nutrition is contributing around the 60 to 70% of in the production cost. So against that, in the water crisis, so we need to work out to interact with the nutrition and the water consumption. As the protein and fat are the major nutrient for the effective growth, reproduction, and production of the animal. In India, since the poor availability of the feed resources and the poor quality roughages, the bovine production is hampered with the true protein as first limiting nutrient. According to the protein quality, 60 to 70% of the protein in the animal feeding are degraded in the rumen for the production of the microbial protein, as well as and due to that reason, there is a lacking some of the amino acid sequences in the muscular development. So there is reduce the production as well as the productive performance of the animal. So for alternative to this, the one technology that is called as the rumen bypass nutrient technology. That through the this technology, the dietary protein that can escape the rumen degradation and protected from the rumen degradation. It can be digested and absorbed, metabolized and absorbed in the lower GIT of the animal. For this experiment, the guar meal is a combination of the hulls and jumps that are recovered from the mechanical splitting of the guar seeds and separating the endosperm, germ, and hulls. It is being considered as the relatively inexpensive vegetable high protein source, and that contain around 30 to 60% of the protein. But however, the protein of this guar meal is highly degradable, that is around 68 to 70%. And due to this, there is one treatment that is called as the formaldehyde treatment, that is for the bypassing this high amount of protein in the guar meal. And by the finding of the research study, there is a 72% of the rumen undegradable protein are there with the treatment of this formaldehyde. Another is the prill fat, that is the non-hydrogenated vegetable oil, and that contain more than 85% of the palmitic acid, and that having the high melting point, that is by due to this that is protected from the rumen degradation as well as the rumen environment, and that can also absorb in the lower GIT. So therefore, we have, for interacting the water consumption and the nutrient, we decide this study. The objective of this study was to study the influence of feeding formaldehyde treated guar meal and prill fat supplementation on growth performance, water intake, and water requirement of the growing dairy buffalo cows. Second objective was the study the influence of feeding formaldehyde treated guar meal and prill fat supplementation on water intake based on the nutrient intake and the body weight of the growing dairy buffalo cows. This study was conducted at the Reproductive Biological Research Unit, AAU Anand, and for this study, 16 Surti buffalo cows of the both sexes of 5 to 9 months of age were selected. These are the tables showing the details of the age and body weight of the selected cows. The duration of the treatment given for this experiment was 280 days, and there are 4 groups were there, and that is distributed into 4 treatments. And the basal diet were formulated as per the ICAR 2013 nutrient requirement for the dairy cattle and buffalo. These are the dietary treatment groups and its regimen. There are 4 groups were there, and each group contain 4 cows, and total 16 number of cows are there. In T1 as a control group, there is a basal diet were supplemented as per the ICAR 2013 nutrient requirement. In the T2 group, along with the basal diet, the 30% of the protein of the concentrate were replaced with the protein of this formaldehyde treated guar meal. Third group is the T3 as a prill fat group, in which the additional along with the basal diet, there is a additional supplementation of the 100 gram prill fat was there, and T4 was the combination group with the same dosage. The sum of the production parameter like daily feed intake, growth performance, feed conversion efficiency, water intake, and economic was calculated. These are the animal photographs of the animals at the different age and during the experiment of Surti buffalo breeds. First, in the result, the chemical these are the tables showing the chemical composition of the treatment diet, in which in T3 and T4 group, due to the additional supplementation of fat, there is a slight increasing in the ether extract content of the diet. All other components are not affected with the dietary treatments. These are the tables showing the dry matter intake and nutrient intake of the growing Surti buffalo cows under this experiment. Due to the inclusion of this formaldehyde treated guar meal and the combination group, there is a significantly reduction in the dry matter intake by the animals. Same trend was observed for the crude protein intake in the T2 and T4 group, followed by the T3 and T1 group. These are the tables showing the feed conversion efficiency of the animal, in which, however, the decreasing in the feed intake of the T2 and T4 group, there is an improvement in the feed conversion efficiency in the T2 and T4 group. These are the tables showing the monthly water intake of the buffalo cows, in which during the early month there is not any significant effect was observed for the water intake by the dietary treatments. However, since the month of November, there is a little bit significant influence was observed in the dietary treatments. However, the mean consumption of the water by the cows were not affected significantly. The water intake per kg of the dry matter intake. The water intake per kg of dry matter intake was significantly affected during all the months of the experiment. The mean water consumption was significantly higher in T2 and T4 group, where the combination formaldehyde treated guar meal and the combination of fat and formaldehyde treated guar meal were supplemented. The water intake per kg of the body weight was not affected significantly during all month, as well as the mean water consumption per kg of the body weight. The same trend was observed for the per kg of the metabolic body weight for the water consumption. Similar trend was observed per kg of the water intake per kg of the gain by the buffalo cows. That is also not affected with the dietary treatments. Then this table showing the water intake per kg of the crude protein intake. Here in the during all the month, the water consumption was significantly affected in the T2 and T4 group as compared to T3 and T1 group, and the mean water consumption was significantly higher in the T2 and T4 group, where the this formaldehyde treated guar meal were supplemented. The water intake per kg of the digestible crude protein was not significantly affected with the.
Conclude kar dijiye, please. Please conclude the presentation.
Yes, sir.
That's right.
Do you have a slide on conclusion?
The conclusion of the dry matter and nutrient intake were significantly impacted with the inclusion of this formaldehyde treated guar meal, and revealed the lower dry matter crude protein and digestible crude protein intake in the T2 and T4 group. All the reduction in the dry matter and nutrient intake, the better feed conversion efficiency has been observed in the T2 and T4 group. The replacement of protein with the formaldehyde treated guar meal and pure fat has the greater influence on the water intake of the growing dairy buffalo cows. The inclusion of protein-rich ingredient and fat supplementation in diet affect the water requirement of the buffalo cows. However, the water intake for the weight gain was less or not affected significantly, so that it can be reduce the water requirement for the daily buffalo cows for gaining in the body weight, and ultimately minimizing the water usage for the drinking purpose by the animal, along with the economical aspect.
Thank you. Judges. Hello, Dr. Parman. Now, since your feed formulation includes treatment, right, formaldehyde treatment and the feed fat, so in terms of the increase in the cost of the feeding, how will you correlate with the similar water? Because it will definitely increase the cost of your feeding, right? Now, because you are going to treat the user with formaldehyde, and that needs that will incur some additional expense, right?
Sir, in the formaldehyde treatment for the protein, there is a 0.40 rupees for 1 kg of the protein.
Okay.
And the economic are also in the presentation.
So I think that is important, because in
Yes, sir. In the sir, in the T2 group and T4 group, there is formaldehyde treated guar meal were supplemented, and there is a benefited over the control group with the 28.35 rupees and the 23.59 rupees. But however, the fat supplementation was not having the benefited.
Okay. And second question is, of course, your study includes growing dairy cows, right? Now, same thing would be applicable to the adult lactating animals?
Yes, sir, we can.
In buffalo, same thing could be there for the cows as
in the our another project was also carried out on this with the same treatment on the heifer.
Okay, thank you. Any other question?
Good afternoon, Dr. Parman. It's a nice presentation. Just have a suggestion. Can briefly explain in one line regarding rumen bypass protein. My point of asking this question would be because ours is a mixed crowd, and that would give a little more idea to all of us.
Can you repeat, ma'am, question?
Rumen bypass protein.
Wants to know rumen bypass protein, or just a general.
Rumen bypass protein means we give the treatment like heat treatment or the formaldehyde treatment, as we supplemented without treatment the protein of the higher quality, that is degraded around 60 to 70% in the rumen. With this treatment of the formaldehyde, there is a coating of this protein, and so that can not degraded in the rumen pH as, or the rumen micro by the way of rumen microflora, and that is get passes out the degradation of the rumen and goes to the lower GIT for the digestion, metabolism, and absorption, and so ultimately increasing the utilization of protein.
Next, we have Dr. Ramesh.
Ramesh, please go ahead.
Yes, I am audible to you, madam.
Audible and visible.
Yes, sir. Yes, sir. So, sir. Oh, shall I share the slides for presentation?
Right.
Okay.
The screen is visible, please. Please go ahead.
It's visible, sir?
Yes, it's visible. Please go ahead.
Okay, so good afternoon to jury members and participants. I, Dr. Ramesh HS, I am assistant professor in the Department of Veterinary Biochemistry, Veterinary College, Hebbal, Bangalore. Today I am going to present my topic on effect of different concentrations of amphiregulin on ovine granulosa cell monolayer formation and its importance and role in water management. As we know that India is home for 42.2 million sheep, and also it contributes more than 50% of the meat produced in the country and has a pivotal role in rural economy. And it is considered as the animal of the future with its ability to survive in harsher conditions as compared to the other animals. And as we know that how it is related to water management, because as we know that in the lifespan of an animal, hardly it produces 7 to 8 offsprings, isn't it? And as we know that ovaries contains millions of preanther follicles. And if you use those preanther follicles for culturing and for the production of embryo, and we can produce thousands of embryos and also offsprings from a single elite animal. And also we have tested, and we are the first person to produce embryo from the large animal in case of buffalo, and also same thing we have published. And same thing we are trying in the sheep also, and we are not able to get the embryo till now, but still we are trying, and with so many techniques we are using to produce embryo from the in vitro grown preanther follicles, so that from a single animal we can produce a number of offsprings, and we can so no need of rearing one non-producing cow or other for a years together, so that we can select a elite cow, and we can rear the elite cow, and we can, so that we can reduce the water scarcity also in this case. And it's considered that animal, and because of urbanization, dairy, and industrial purposes, so many things are, because of all these things, we need to select a animal, and also we need to develop a techniques to overcome all these things. As you know, the sheep contributes important role in our country and has a pivotal role position in our rural economy. And next we move on to next materials and methods, how we are going to produce the first embryos. So first, before producing, going to the embryo production and offspring, we need to do research on so many things so that we can produce better embryos like monolayer. This is one of the important things, so that we can use the monolayer, granulosa monolayer, granulosa monolayer, cumulus monolayer to develop or to grow the embryos in vitro. As we know that, as I said initially, ovaries, they contain thousands of preanther follicles, and different in different species. And these ovaries were brought from the lab to the laboratory from the slaughterhouse, which and that should be supplemented with gentamicin and also isolation media for the isolation of preanther follicles. And as on these are the materials and methods how we are going to do in the laboratory, and these are washed initially with 0.9% normal saline, and the surrounding, as we know that it contains ligaments surrounding the ovaries. This need to be removed, and this has to be washed thoroughly with the DPBS, because of so many debris and other so many things will be there, so that it infect the culturing media also. And coming to how we are going to isolate preanther follicles from the ovaries, and how we are going to separate the granulosa cells from the preanther follicles. As we know that, first we need to get the ovaries from the slaughterhouse and make a thin and small sections from the ovarian cortex. Ovarian cortex and medulla both will be there. From the ovarian cortex, as we know that it contains number of preanther follicles on the cortex, and these sections were washed with first preanther follicle isolation medium. And for this we need a trypsin 1% we are using for we need to incubate for 10 minutes in the trypsin, 1% trypsin. And here we are separating the preanther follicles from the ovarian cortex by using combined mechanical and enzymatic method, because we are using the trypsin here, and mechanically we need to separate the preanther follicles from the ovarian cortex, and by using the 26 gauge disposable needle and with the scalpel blade. And these preanther follicles, there are different groups are there, preantral and preanther follicles and anther follicles. Here we are we are separating the preanther follicles. We are not concentrating on the anther follicles. Okay, preanther follicles, as you know that 1,000, millions and lakhs together in different species. And during isolation process, we need to add isolation medium, because under sterile zoom microscope we are separating. It's going to dry the tissues and also preanther follicles. In between, you should be very careful while separating the preanther follicles. And diameter is also very important, because we need to take only the preanther follicles, not other things there. So diameter is very important there. Preanther follicle, it will be different in different species, and under sterile zoom microscope there will be calibration will be there. Under that we need to separate the preanther follicles, and also we need to check the survivability of also, and whether it is dead or alive, by using trypan blue there. And coming to the isolation of granulosa cells, this is actually granulosa cells we are using for the formation of to culture the under in vitro condition. So here first granulosa cells, as we know that it contains inside the preanther follicles. So follicles will be there inside, oocytes will be there surrounding the oocyte, granulosa surrounding. After it attains to the follicles or anther follicles, it becomes a cumulus cells there. So we are concentrating on the granulosa cells, because as you know, the granulosa cells secretes so many growth factors for the development of the oocytes, isn't it? And these granulosa cells were separated from the preanther follicles by dissecting out the oocyte. Oocyte is there. You are not taking the oocyte there. Only granulosa cells we are taking for the culturing. Okay, oocytes were removed from the using needle, and also that is called as oosectomized follicles. That is, it contains only the granulosa cells in that, and and this is used for the culturing of these cells. Coming to the preparation of the monolayer, and here we are using the tissue culture medium 199, and also as we know that this is actually, and also BSA we have used, and also we have used, and this has, because to get only the granulosa, we are centrifuging at 2500 for 5 minutes at 4 degrees Celsius, and also thin pellet. After getting the thin pellets of granulosa cells, we are culturing in the in vitro condition. Only the number also we are counting in that, and in the 100 microliter droplet in the petri dish, we are culturing in the CO2 incubator by using these additives. And droplets were these need to be covered under paraffin oil, and this has to be kept in the CO2 incubator till their what is the monolayer? As we know that monolayer means till it gets the confluency. Sometime we will get the confluency after 2 days, 3 days. So maximum days we are culturing is only for the 5 days. So if you are getting at the second day, that we can say that it is a good monolayer formation has happened. Okay, so that we are concentrating, we are taking for the culturing of the oocytes, in vitro fertilized oocytes for the embryo culturing. And coming to the results and discussion, here we are granulosa cells monolayer formation. Actually, here we are testing with amphiregulin. So, okay, neuroregulin we also tested. We are testing with the neuroregulin, TNF transforming TNF alpha. We are testing with IGF-1. So many still it is going on. So now we are cultured with amphiregulin at different concentrations from 5 nanogram to 150 nanogram. So here formation of a monolayer it's better with 100 nanogram, either 100 nanogram or 150 nanogram of amphiregulin compared to all other lower concentrations. And also it was significantly higher in the group treated with some 50 nanogram also. So compared to control and groups with 5 nanogram or either 10 nanogram or 25 nanogram of amphiregulin. So hence we can say that the amphiregulin at the concentration of 50 nanogram, 100 nanogram or either 150 nanogram is better for the culturing, for the formation of monolayer. And also this is actually, we can conclude that by this way of culturing of embryos, and we can produce number of embryo offsprings from single elate animal, and also we can reduce the usage of water for the production, for the management of dairy for a long time by keeping a non-producing cow. Okay. This is how we are doing, and still some more research we need to do. We are doing that one, and definitely we are going to success in embryo production in case of ovine by using preant follicles. So thank you for giving.
Please go ahead. Yeah, Dr. Ramesh.
Yes, sir.
Yeah, of course, this entire work is highly, research-centric in vitro condition, right? And I think is based on your cell culture studies on ovine granulosa cell. So how exactly this can be, percolated to the real water? Because in your abstract here, that link is missing what you have submitted.
Yes,
These are few of the laboratory-based data, right? So how it can be really...
Yes, sir. I got your thing, sir. Because here we are using different monolayers to because at the same time we need to produce the IVF, that is in vitro fertilization, and also we need to produce the embryos. So for at the same time we need to produce the monolayers, because as we know that granulosa monolayer we are using, cumulus monolayer you are using in the in vitro, because these monolayers they produce the different growth factors to enhance the development of embryo, and that can be implanted into the recipient cow or recipient any species. So from a single animal, from the elite, you can take elite cow or any genetically having a high, for example, in case of sheep, having a high meat production. So those you can select the animals, and we can produce thousands of even we can, because so many lakhs together preanta follicles are there. We can isolate these preanta follicles from each ovary. From single ovary, you can produce number of offsprings from a single elite animal, so that keeping so not producing cow for a long time, because in a lifespan we are getting only hardly we are getting 7 to 8 offsprings, isn't it? That way we can contributing to our rural economy, sir.
Whatever the advantages are with in vitro fertilization, some advantages tapped here. No, that's what you want to say, no? From a single
Yeah, singers, because we are even the rural sector, what they are doing, sir, they are keeping animal as such. It's because sometimes they produce very less milk production. They are keeping like that, and they are managing in their managing with, because they, as you know, that they are feeding normally, water consumption, everything is going on, but less milk production there.
Thank you, Mr. Ramesh. Thank you.
Thank you, sir. Thank you very much, sir.
Next, we have Dr. Ajay. Sorry.
Hello, sir. This is really a nice presentation. But I'm asking one thing: how the supply chain of this embryo can be managed? Once the embryo is developed at the laboratory, how is able to transfer this to the farmer? Will there be change in the or differentiation in the embryo while the entire transfer takes place?
That is a separate technique is there. A separate procedure is there that for that purpose. That is implanted. We are that is recipient, donor, and synchronization. So many techniques it comes there. Synchronizing the animals there. So many the embryos we are getting. We need to synchronize the recipient. We are saying recipient. Donor to recipient. We are donor. We are developing. Donor is not there. Donor from the donor. That is an in vivo method. In vitro we are culturing in the laboratory. So whatever the embryos we are getting, we are putting in the recipients there, sir.
Okay, sir. Means we will synchronize the recipient so that we can transfer with them.
Yeah. That is a separate procedure, sir. That we are not up to that time, up to that level. You are not sir, actually.
So how much embryo can be produced from one over?
Actually, in my research, actually, we are the first person to produce the embryo. In case of buffalo, we are trying in the sheep, but in buffalo, we have tested with different cells, cumular cells, granulosa cells, oviductal epithelial cells. We tried, and also coconut water. Also, we have used coconut water to culture the embryos, which oocytes isolated from the preanther, in vitro grown preanther follicles in the laboratory, and we got embryos in different embryo. We are able to get embryos in different culture, not the same in coconut water or cumular cells. We can say that it is a better for the development of embryo. In that experiment, we got highest number of embryos. First time we produced in that.
Okay, thank you.
Thank you, sir. Thank you very much.
Next, we have Dr. Ajay Singh Sirohi.
Please go ahead. Your screen is visible to us. Please go ahead. So you need to unmute yourself.
Hello, am I audible?
You are audible now. Your screen is visible. Please go.
Are the slides visible?
Yes, please go ahead.
Okay. Good afternoon, everybody. Respected dignitaries, jury members, and esteemed delegates. The topic of my presentation is assessing service water saving devices under intensive cattle production systems in Western Uttar Pradesh, India. Okay. Now the slide of introduction is visible. Actually, when I pressed 2 times, it was not there, but I think now it is visible now. Okay. Everyone knows the availability of pure drinking water is becoming a huge problem in many parts of the world, including India. And you see there is a news cutting, and the available reports at different fora, they indicate the annual depletion of the 32 to 96 centimeter in the groundwater level in western Uttar Pradesh. And in this area, the Meerut district is at the top. And on the other side, when we see the cattle population, the composition is changing. As per the livestock census 2019, during the period 2012 to 2019, the indigenous cattle population decreased by the 6%. However, the crossbred and the exotic cattle population increased from 40 to 51 million, means 29% exotic and crossbred cattle population was increased. But as per the reports, the demand for the water in livestock production is influenced by several factors such as type of animal, its management, and microclimatic conditions. That's why the increase in the population of the crossbred cattle is important. Besides consumption of the drinking water, a huge quantity of surface water is utilized in animal production systems. Surface water requirement is more for crossbred than the indigenous because of soiling of those animals, and they need water for thermoregulation, especially during summer season to reduce the heat stress. That's why it has been found that the water requirement is more for the crossbred cattle than the indigenous cattle. Considering these facts, the present study was planned to explore the strategies for enhancing water productivity through optimizing the surface water uses under cattle production system. In the methodology, actually the some trials were conducted at this institute at CIRC Meerut, and the freeze wall breeding bulls were maintained in 2 types of the housings, east-west oriented and north-south oriented. The floor of the open area in the east-west shed made of the cemented concrete, whereas it was the earthen floor, the kacha floor in north-south oriented sheds. However, the covered area under both the sheds, it was made of the cemented concrete. And for recording of the quantity of the water utilized, the magnetic water meters were used, and for the climatic variable data loggers were used. In the series of trials, the 4 strategies were executed to assess the surface water utilization pattern in breeding bull production system. In the first one, washing of the experimental bulls inside the shed with the hose pipe in the control group, and in the customized animal washing system in the treatment group. The second trial was on the observation on the floor washing inside the shed with the hose pipe and trigger shut off on the hose. In the third trial, the observations on the water uses on cooling of the shed with the shower and the fogger. Shower in the control group and the foggers in the treatment group during the summer season. In the fourth trial, the observations on the washing of the animals as well as floor with the hose pipe and pressure wash machine were recorded. And here are the results. Washing of the experimental bulls inside the shed with the hose pipe and in the customized animal washing system. The customized animal washing system, it was framed at this institute with the aim to reduce the water utilization on the washing of the animals. And it was found that average water utilized on washing of the bulls kept in east-west, where the floor was completely cemented, the water requirement was lesser than the bulls kept in the other type of the sheds. And the more water utilized for washing of the bulls in mixed type of the floor might be due to the swelling of the bulls which came in the contact with the earthen floor also. The bulls of both the sheds were washed with significantly lesser water quantity in animal washing system than using the hose pipe. And the water saving in the animal washing system was due to controlled use of water through the jets in the animal washing system. In the next trial, the observations on floor washing inside the shed with the hose pipe and trigger shut off on hose. And it was observed that the use of trigger shut off reduced the water requirement for the floor cleaning significantly than the cleaning with the hose pipe. And for cleaning of the floor, about 90 liters water per bull per day was saved with the use of trigger shut off on hose, then the control group. And the controlled release of water from the trigger shut off whenever it was required, attached with the hose, was the main cause of the less water uses for the floor cleaning. In the next trial, the water uses on cooling of the sheds with the shower and the fogger systems during summer season. This slide shows the climatic variables recorded inside the bull sheds, both the type of the bull sheds, and here average climatic variables and water utilized through shower and the fogger systems. Ambient maximum and minimum temperature and relative humidity were comparable in both the sheds. And it was found that with the use of the foggers, about 200 liter waters per bullpen per day was saved as compared to the shower group. In the next trial, washing of the animal as well as the floor with the hose pipe and the pressure wash machine. And it was found that average water utilized per bull per day for the same purpose, for the washing of the animal as well as the floor, about 200 liter lesser water was used in the pressure wash machine group compared to the hose pipe group. And the high pressure of the pressure wash machine cleaned the soil coat of the bull and the floor surface more efficiently than the control group. And in the conclusion, we can say that the following or these four devices were found suitable in reducing the service water uses at animal farm. The customized animal washing system, this can be designed at any animal farm, and the trigger shut off on hose for the controlled release of the water. The foggers where the fine mist of about 50-60 of the microns they release and they keep the microclimate comfortable. And the use of the pressure wash machine for the cleaning of the floor and washing of the animals. And it can be concluded that 1,000 liters of the service water could be saved annually by adopting newer technologies, devices strategically in intensive livestock production systems. Actually, the aim of the study was to aware the bullmen, the workers who are engaged in the animal production system. And in the last, I acknowledge the kind support of the Director, ICR CIRC, Director Fishwal Project, and the Director ICR IIWM Bhubaneswar. Thank you.
So please. Yeah, Dr. Sironi.
Yes, sir.
Yeah. What would be the cost of this customized animal washing system which you have described, actually, which you have designed at your institute?
It was prepared with the cost of 15,000.
15.
15.
Okay, and but that is also that will require electricity as well, right?
Yes, one motor pump is there for lifting and putting the pressure with the pressure into this customized animal washing system. And one thing important is here that sir, we can replace or we can close the jets.
Okay.
Nozzles.
This will be applicable mostly to the larger dairy farms, but I think our dairy.
Yes, sir, of course.
You said that most of the farmers, they have 2-3 animals and they are keeping. So in that, the economics needs to be worked out for that. Yeah.
Of course, sir.
Yeah. Thank you. Any question? Dr. Ajay Singh, my question is that you are saying usage of water and saving water through the technology. But what about the used water being recycled and used for cleaning of animals?
Yes, sir. Actually, there is a pit alongside of that animal washing system, and from where that water is utilized for the irrigation purpose. And also some portion of the water, it is used for the vermicomposting at our institute.
Thank you. Next, we have Dr. Sanat Mishra.
Hello, ma'am. Am I visible and my presentation is visible?
Visible and audible. Please go ahead.
Thank you. Esteemed panelists, esteemed jury members, ladies and gentlemen. This is Dr. Sanat Mishra from Odisha University of Agriculture and Technology, Bhubaneswar. My presentation is on the interdependence between water, crops, milk, a case study of Odisha. Let me, before I start my presentation, let me give a little background of how I developed this paper. In fact, this assignment was given by a publisher who wanted to publish a document, this chapter, on infrastructure, crops, and other livelihood development. So I was preparing an article for the book chapter. This paper, as a corollary to that publication book chapter, I thought when I came across this workshop at ILMA, I thought I'll do some research work. This is basically a meta-analysis of two published papers of Government of Odisha. I am a part of the Directorate of Planning, Monitoring and Evaluation of Odisha University of Research and Technology. So as a part of that research work, I did a meta-analysis of on water, the available irrigation potential that has been created in different parts of Odisha, and the quantum of as well as the value of crops produced for the state, and milk produced, value of milk produced everything. So I wanted to establish the organic linkage to see how this is. The result of this paper is provision of water to irrigation system is the prime mover for agricultural production. As you know, this is a well-accepted fact.
Please share your screen.
May I know? I'm not able to hear you.
Please share your screen because your presentation.
Okay. Okay. Just a minute, ma'am. Allow me a couple of minutes.
Yes, I know it's visible. Please go ahead.
Yes. As I said, this is the interdependence between water, crops, and milk. A case study from Odisha. I'm from the Director of Planning, Monitoring and Evaluation. So the result of this study, as you know, it's a well-accepted fact that water is linked to development, and water touches every part of development work. It links to nearly every SDG, Sustainable Development Goal of a life. So I wanted to look at the interlinkage, the organic linkage that exists. We always know this is an obvious fact that water leads to generation of increased biomass, increased crop residue, and that provides an opportunity for animal husbandry and for the animal development, and specifically for the milk production. So this organic linkage between water, crops, and milk in the locality wanted to study. For that, the objective of our research work was to evaluate the correlation that exists in a given district on the area of irrigation with the value of total crop and with the value of milk produced. And of course, the correlation between the value of total crop produced as well as the value of milk produced. Similarly, we wanted to match the performance of each district of the state with respect to irrigation potential created, value of crop, and value of milk. These three parameters were studied. And to draw evidence on the linkage between water, crops, and milk. So, as you know, though it sounds obvious, but when we started looking at the paper, background papers in our state, hardly there was any very limited scope paper to evidence. Then we started doing meta-analysis. We took cognizance of three published data: gross area under irrigation, that is from Department of Water Resources, value of crops in current prices from Department of Economic and Statistics, similarly value of milk in current prices on Department. We took into account the 2015-16 because the Department of Economic and Statistics published each 5 years. So 2020 publication is yet to come. So 2015-16 data is taken into account for this analysis. So in order to arrive at a consistency and parity among these three data series, so we divided the data available with the area of the district so that we can able to make compare between these three district data. Area of district divided by we arrived at factor of irrigation, factor of value of crop, and factor of value of milk. So these three values, then it can be compared and further analyzed for taking a decision. Similarly, as I said, correlation coefficient analysis was conducted between district-wise gross area under irrigation and value of crop, district-wise gross area under irrigation value of milk, and third, district-wise value of crops and value of milk. Then, what we did is district for each all 30 districts of the state were ranked from 1 to 30 based on these three parameters. The factors we arrived: factors of irrigation, value of crop, and value of milk. First, 1 to 10 are the top rank, 11 to 20 are the middle, and 20 to 30 obviously in the low range. Then we started matching. How do they match? Matching of all the 30 districts with respect to top, middle, and low rank. So if you look at this, all 30 district data, area under 1,000 hectares, similarly the value of crops, value of milk in lakh rupees. Then we divided with the area of the district to arrive at these factors. Then, sir, we compared the data, we ranked the data, as I said, top, middle, and low rank, then started matching. If you look at the findings, the correlation between these three parameters, the gross area under irrigation value of crops, it was 0.8. Similarly, gross area under irrigation value of milk is 0.809, and the correlation coefficient between value of crops and value of milk was 0.691. With respect to the matching of districts, out of 30 districts, 23 districts matching. Look at the how things are happening. It corroborates to the correlation coefficient that we have studied. The factor of irrigation vis-a-vis factor of value of crops in 23 districts matching, and in 7 districts not matching. Similarly, for in factors, irrigation value of 22 districts matching, and in 8 districts not matching. Similarly, for the third one, value of crops 19 and 11 not matching. If you look at these are the findings. Look at the conclusion. The positive correlation coefficient and matching of the performance with respect to key parameters underscore the fact that the need for irrigation water triggering agricultural development as an important pathway for crops as well as milk production in the locality. And I understand the policymakers with this data will be able to pinpoint the organic linkage between water, crops, and milk, and the interdependence continues. It doesn't happen in isolation because we have pollution water, we have pollution crops, we have pollution milk. What we intend to do is to build the organic linkage between these three major domains. So that this study gives the scope and the data to support, the evidence to support that these three are organically linked. Thank you.
Hello, Dr. Mishra.
Yes, sir.
Yeah, of course, a very good model and analysis, very interesting one. But my concern is only with regards to the data which we have used. I think it is of 2015-16, right? Where the irrigation area data of 5 years data, even crops, they were also for 15, 16 or only of milk also. So, I mean, in present context, how much that will be relevant because things might have changed drastically, and especially in your state during last 5 years, I think. So, the maybe the area of irrigation and other things might have changed. So, how will you, conclude in the present context what your side as a conclusions?
Yes, sir. You are right. Absolutely. In fact, 2020 data from the Director of Economic Society is yet to publish, which I could have. In fact, we wanted to do that projection. With the data sales analysis, we could have projected the data for the estimated value for 2020-21, but we confined ourselves to the available data. Instead of projecting, we could have done that, sir. Given a projection based on the year-on-year growth, we could have done that for 2021 and compare. But we wanted to do the analysis on the existing data available, published data. So that's the reason we did it. Maybe in a couple of months' time, once this 2020-21 data comes published, I am told that it's delayed because of some obvious reasons of Corona and so on. But maybe in a couple of months' time, when it comes, then we'll be able to publish another series of data and can more concretize, more emphatically we can say this clearly.
Okay, so this interdependence, any national agency is using this kind of analysis. You have any idea? Central government or any other agency?
Come again, sir. I'm not able to hear you properly. There is some response.
Whatever this interdependence model or formula you have worked out, any official government agency is following this kind of analysis?
Yeah. In fact, sir, what we are doing correctly is for the state of Odisha. And as the only agriculture university in the state, every year we used to process them, give them the information as a finding that this is the model to be followed, how this is linked. And also we are part of that every 5 years, we is given the assignment of preparing the district plans for all districts of the state. University is given the assignment. So I have been associated with this assignment for last years, 5-7 years. We have been associated with this planning exercise. So this helps me to build the data. As you know, the big data nowadays is a big data thing. So this helps me to prepare the district plans more emphatically, more with a concrete base and the scientific knowledge.
Thank you.
Thank you. Next, we have Dr. BP from
Dr. Bhupen Panda, please go ahead.
Good afternoon to all of you. Am I audible and visible?
Yes, your screen is also visible. You are audible. Please go ahead. Dr. Panda, please.
Good afternoon to all of you. Am I audible and visible?
Yes. Yes, please go ahead.
Hello. Hello. Am I audible? Hello.
Yes, you are audible. Please go ahead.
Yeah.
Your screen is
I'm Dr. Bhupendra Phonba, and from NDDB, and I'm going to present on ration balancing, a practical approach to improve milk productivity and reduce water footprint of milk in dairy animals. Since morning, we are listening that milk production is a crucial. Water is very crucial for milk production, and feeding accounts for more than 90% of the water footprint of milk. Now, various agencies in the country have estimated that there is a shortage of feed and fodder resources in India. For example, in case of concentrate, the deficit is 36% related to requirement of all animals, and in absolute terms, it is 35 million metric ton. Now, NDDB's data on feeding status of in-milk animals from 18 states of country indicate that 58% of the animals they are being overfed with energy and protein, whereas in 27% of animals there is deficiency of energy and protein. Now, this type of feeding pattern indicate typical tendency of farmers to feed prefer available feed resources for feeding first to lactating animals, and then whatever remaining feed resources are available, they are used for other categories of animals. Now, such type of practices are detrimental for animals, for farmers, as well as for environment. The reason is, for animals, there is a milk production efficiency becomes poor. For farmers, there is a higher cost of milk production and less income from dairying, and for environment, it results in higher water footprint of milk. On the right hand side, the areas represented in the circle contribute 40% of the national milk production, and these at the same time these areas are under high to extremely high water stress. So these facts indicate that there is urgent need to educate milk producers in the country to on scientific feeding of their animals, so that they can judiciously use available feed resources and contribute to lower water footprint of milk. Now, with this background, the present study was planned with objective to evaluate impact of feeding balanced rations to cows and buffaloes on milk productivity and water footprint of milk. Now, first, this study was conducted in Gujarat, and first we implemented a ration balancing program in Gujarat. For that, we analyzed chemical composition of feed and fodder available in the state, and feed data library was prepared. Then nutrient requirement of all animals were compiled, and information network for animal productivity and health, or ENAP software, was developed. This software performs ration balancing at the farmer's doorstep. Now, we trained local resource persons that visited at the farmer's doorstep. They collected information on traditional feeding pattern as well as milk production, body weight of animal, and based on this information, they formulated using this software, they formulated balanced ration advisory, which was issued to the farmers in their local language. So this program was implemented on total 592,000 animals, and when this study was conducted, at the time we obtained sample of 178,000 animals. So this is how the LRP visited at the farmer's doorstep and collected information and provided ration balancing advisory services. Now, using this data, we also estimated water footprint of milk. So in this, we have considered blue water as well as green water component, and direct and indirect activities. Indirect activities included consumptive water use for feeding of animals, for production of feed and fodder for animals. Then direct water use involved water use for drinking purpose as well as water use for farm services. Now, total consumptive water use required for these activities divided by milk production is the water footprint of milk. Now, coming to results, this is the various data that we collected, and these are the sources. So, herd and feeding related data was primary data that was directly collected from field, whereas agronomy and direct water use related to drinking, all this data was secondary data obtained from various prediction equations and various reports. Coming to results, Now, nutritional status of dairy animals in the Gujarat. So this this data of this is a mix of cows and buffaloes, and this total number of animals are 1,78,000, which includes 86,000 cows and 92,000 buffaloes. So this data indicates that this is the traditional feeding pattern followed by farmers. This data indicates that in 61% of these animals, there is energy and protein were overfed by the farmers, and the extent of overfeeding was 20% extra energy and 28% of extra crude protein. Where in case of minerals, 72% animals were deficient in calcium and phosphorus, and the extent of deficit was 20% for calcium and 31% of for phosphorus. So this type of feeding pattern is, because this is imbalanced feeding pattern, this is particular feeding pattern is responsible for poor efficiency of animals as well as higher water footprint of milk. Now, while balancing the ration, as we can see, we optimize the nutrient intake of animals. Before, we can see here that nutrient intake was much higher before RB or on the traditional feeding pattern, because these animals were overfed. Now, while balancing the ration, we optimize the intake and according to requirement and requirement or plane of nutrition of these animals. As a result, the milk production efficiency of animals, milk production was of cows and buffaloes was improved by 3%. There was animal produced milk with better fat, and milk production efficiency of animal was also improved in terms of kg of fat and fat corrected milk per kg of dry matter intake. Because the ration was optimized, overfeeding was avoided, there was significant reduction in the cost of feeding. Farmer earn more money because animal produce better milk, more milk with better fat, and as a result, the net income of these animals was improved by 30 rupees per animal in cows and buffaloes. Now, coming to results of water footprint analysis. Because more than 95% of the freshwater or consumptive water use was associated with feeding of animals, because of optimizing dry matter intake of animals and avoiding overfeeding of animals, there was significant reduction in total water use, that is liters per animal per day in both species. And both green and blue water component, they were reduced. The proportion of blue water was 65% here, and green water it was 35%. And because of feeding balanced ration, the water footprint of milk in both cows and buffaloes was reduced from 13 to 15%, in the range of 13 to 15%. Now, in practical situation where the dairy cooperative society, when milk is collected, cattle and buffalo milk is mixed together. So, if this milk is standardized at 4% fat and 3.3% protein, that is fat and protein corrected milk, then due to ration balancing, for production of every fat per kg of fat and protein corrected milk, there was saving of 155 liters of fresh water, and 103 liters of this was associated with blue water, and 52 liters of this was associated with green water. Now, this is another important finding that I want to share, because this is the water footprint of different feed ingredients that are used for feeding of animals. So, what we can see that because crop residue and their byproducts have lower water footprint than grains, they can be better utilized by value addition by incorporating in the total mix ration. Another important thing is green water have much lower water footprint than grains. So they can be, we need to promote green water production and also efforts are required for its conservation. So based on this study, we can conclude that feeding balanced ration to dairy animals improved milk yield by 3%, improved milk fat of animals. Then it resulted in higher income to farmers up to 30 rupees per animal per day. And there was a 14% reduction in water footprint of milk. And therefore, ration balancing can be used as the most practical approach to improve productivity of dairy animals and profitability of smallholder farmers in an environmentally sustainable manner. Now, based on these study, we have some recommendations for the dairy industry. First of all, Milk Union should seasonally issue ration advisory to the farmers in their milk shed area, and they can also advise based on the water footprint of crops, which crops are recommended in particular season. So this will help to reduce overall water footprint of crops as well as milk. Then crop residues can be incorporated in TMR. NDDB has already set up 2 TMR plants and promoting this technology. So there will be crop residue, because they have lower water footprint, they can be better utilized, and overall digestion of animals and efficiency is also can be improved. Then Milk Union should also plan for round-year fodder production and its conservation, because the green fodder is a much cheaper source of nutrients, as well as it has lower water footprint. And certified seeds, use of certified seeds is highly recommended because they will result in higher biomass production per hectare of land, and so this will reduce water footprint of crops as well as livestock products, or including milk. So with this, I would like to thank you for your attention.
Yes, Dr. Fonda. Hello. Hello.
Yes, sir. I'm listening.
Confirm that, of course, this is a very exhaustive study. It appears that this is an outcome of a comprehensive NDDB project, right? So I just want to ascertain that since when you have one co-author, so you two are only the stakeholders for this work, or there are other scientists are also involved in this, or it's entirely your work in this, or it's a project work outcome not taken? That's what I want to ascertain. Because this competition is for young scientist competition, right? So just I want to ascertain that it is exclusively your work under this, or it is a big project work which you are presenting. That's what I'm.
Okay, sir. Ration balancing program, in implementation of ration balancing program, several milk unions and several officers of NDDB were involved, and we have this data on Enough server, and I use this data to estimate water footprint of milk. So this is my contribution in this work.
Yeah, so that I think the organizers will, rather than co-jury members, may take a note of it, and accordingly the merit should be considered. Thank you very much.
Our last presenter for the day is Dr. Arjun Modi.
His full name? What's his full name? I don't think he's present. No. In the attendees, no. Raju Bhai. No.
You can just announce, I mean, if he's there or not. Just
Dr. Arjun Modi, if you are in the attendees, please raise your hand. Can you drop a message in the chat box? No. Dr. Prajapati is not present. Okay. By what name? By what name? Yes. Dr. R.J. Modi, if you are in the attendees, I request you to either drop a message in the chat box or raise your hand.
कि इसके साथ बहुत सारे को-ऑथर्स थे ना, उसको आगे पीछे कैसे लेना?
No, you cannot speak up. It's a webinar.
डॉक्टर मोदी किस नाम से किया? इट्स नॉट देयर.
Dr. RJ Modi, if you're in the attendance, either drop a message in the chat box or please raise your hand. No. चलो आप कंटिन्यू.
पहले that is सब ऑनलाइन है, बाकी सब ऑफलाइन. That is सब कुछ निकालो.
Please.
Thank you for being a part of the second technical session.
Let the judges complete it.
We'll begin the plenary session in 3 to 4 minutes. Thank you. I've unmuted your live.
Thank you all for being a part of the second technical session. We are now moving towards the plenary session. Now I would like to introduce Dr. C.L. Darich, Secretary and Treasurer, Indian Society of Agricultural Economics, who will chair this session. The co-chairmen are Dr. Atanu Jana, Professor and Head, Anand Agricultural University, Dr. N.K. Jhala, Director of Research, Anand Agricultural University, and Dr. J.B. Prajapati. Okay. Dr. J.B. Prajapati, Chairperson, BKCOE, and Dr. N.K. Jhala, Dr. K.V. Supekar, MD, NCDFI. I now request Dr. Darich to address the plenary session.
Dr. Darich.
Hello.
Sir, yes.
Hello.
Yes, sir, you're visible and audible.
Am I audible?
Yes, sir.
Good evening, honorable organizers, dignitaries, and learned delegates. At the outset, I would like to thank organizers and in general and Dr. Saha in particular for inviting Indian Society of Agricultural Economics or to be a co-organizer and inviting me as well. So on behalf of the Indian Society of Agricultural Economics and on my own behalf, I'm grateful to them for giving us the opportunity to understand this problem and try to help our members to do more and more research work in this area. Friends, as you know, when I was doing my today's conference, some homework, I realized the economics, as Marshall defined, is a study of scarce resources which have alternative usage, and how to get the maximum satisfaction is the study of economics. We are at the same level today when water is a scarce resource and it can be used for a different purposes, it has alternative purposes, and how to get the maximum out of a one drop of the water is the discussion which we had today. Friends, unlike the Green Revolution, which is a technology based, White Revolution is a market led or the demand led. As a result, the whole approach had been that we augmented the milk production. And that augmentation of the milk production was through the increasing the large number of the animals. And yield has not contributed much towards the total milk production in the country, though India is the highest milk producer in the world.
but the yield is much less, and we have increased the number of the animals. Water consumption has increased. Tushar Shah, then his study published in the EPW, and he brought out that dairy sector is a water guzzler. And this study, when has addressed the milk production increase through the increasing the number of the cattle heads. And as a result, there is a more concentration of the animals in the areas which have more of the cooperation. And large number of the large quantity of the milk production was through this. And then composition of the herd, if you look at, instead of indigenous cow, more number of the buffalo increased, the crossbred cow increased, which required green fodder, or not only the which are having the water scarcity, particularly in the region of Mehsana and Banaskantha, Sabarkantha, these areas where water was less, and these animals which are consuming more. That's why the first study, the gravity of the problems, that water is a shared resource. A lot about how to minimize the water use and how to increase the water productivity and the yield productivity of the animals. So unless yield increases, we will per drop of the water, we will require more of the water for a per drop of the milk. How we have learned so many things in the technical session now, which Professor Jana and Dr. Jala will make the presentation. We will come to know how to face this challenge. That in the discussion we had a lot of things we can use but finally I would like to say that unless you reduce the water requirements in the dairy sector, we are not able to use the water judiciously. The future is very bleak, and we have to improve the productivity, we have to improve the yield, and that's why actually in the second white revolution, where NDB tried to have a national dairy plan, and we have addressed all these issues through the ration balancing or less requirements of the water, how we can go ahead. Now I will request my other colleague, Professor Jana, to have the discussions on the technical sessions. Thank you. Nice of you.
Thank you, sir. I now invite Dr. Jana, Professor and Head, Anand Agricultural University, to give a brief about the technical session 1.
Yeah, good evening, everyone. Well, the technical session 1, chairman was Professor Tushar Shah, and for co-chairman myself and Dr. Preeti Shukla from Amul Dairy, she was there. There were total 8 presenters. The first one, Shri Subir Mitra, Group Head, SAS NDDB. The topic was water management in dairy sector. He emphasized to have a holistic approach in reducing the wastage of water in the dairy industry. India, with the years passing by, we saw that the water-stressed areas in some corners of India were dominating, say, showing from 1961 to 2012. India is having 18% of the global population, which utilizes 4% of global water resource. India represents 22.7% of the global milk production. The water usage breed-wise, when studied for cow and buffalo, they were found to be different. The water management at farm level could be tackled through feed and fodder, looking at those aspects, the animal productivity, and to reduce water footprint, ration balancing is very much required. Through such ration balancing, the water footprint of milk reduced by 15% for cows and by 13% for buffaloes. Other means to reduce the water usage is to recycle the steam condensate, reuse CIP solution, recycle ETP treated water, and we have to closely monitor and track the COD and BOD. One very alarming situation, example given by for the Kohler Milk Union Limited, the water scarcity, they need to purchase more than 7 lakh liters of water from nearby. So that caution was given so that those who are coming with the new dairy plants may look into that aspect, water first before you start your dairy plant. The second was Shri Amit Vyas, Managing Director, Amul Dairy Amul. Topic was again water management in the dairy sector. Started with the genesis of Amul, the pattern, and the 75 years of celebration which they are enjoying with a known brand which is globally renowned. To conserve the water, there is a need to measure, and they have installed more than 400 flow meters, and they wish to add more numbers so that they can analyze the data and act on it to reduce the water usage. IoT-based system, hydroflow system, water treatment plant simultaneously helped in reducing the power consumption as well. He was just taking an example of Banas Dairy, now transforming towards automated milk plant, which will help in reducing the water usage or in generating the wastage. At Amul itself, in Amul 2 plant, they are again trying to convert it into a fully automatic plant. The CIP system needs to be updated with, the rotating spray balls, with pressure system, the water gun for cleaning, use of evaporator condensate water, using the rims recovery tank, and so on. Automation at even the ETP, including the anaerobic digester. Rainwater harvesting, they've already got 57 units of Amul, and within few months they expect to rise it to more than 100 units to tackle such a situation, inching towards zero liquid discharge targeted in 5 years by Amul. Even they have gone for sorted sex semen, avoiding use of artificial insemination, which is giving better birth to the female calves. The third presenter is Shri Sangram Chaudhary, Managing Director of Banas Dairy. The topic again the same, water management in the dairy sector. The wastewater generated in dairy plant depends on the product mix and the automation they have adopted, the technology they have harnessed. He depicted 2 videos which all of us enjoyed. One was from Milan, Italy, a lady speaking about again the significance of saving each drop of water. Having sensitivity about water is what we need to teach each and every one, make them aware of, and value something which we have like a precious water. He gave example of the recent oxygen requirement during the second whatever this thing of corona pandemic, what has happened. Even certain dairy plants have started producing oxygen plant. From 2020, they started water conservation activities at Banas Dairy. Jal Sanchay Day also they are celebrating religiously to bring about the awareness at that particular dairy plant. The next presenter, fourth presenter, Dr. Dharma Hagare from Western Sydney University, Australia. The topic was sustainable water and nutrient management within the dairy farms. He gave a brief idea about the Dairy Australia, 4.8 billion US dollar worth dairying with a herd size of average 279 in the farm. 8.8 billion per year is the milk yield there. The water usage for producing cheese was as high as 39%, for processing and producing milk 32%, for butter 22%, for whole milk powder only 4%, and rest 3% for others. The dairy farm in Australia is highly mechanized. The Jersey cow there yields 19-liter milk per day, whereas a Holstein 53 liters per day, and 2 to 3 times milking is carried out as against 2 times we have in India. The milking system there is consisting of double up herringbone milking system, and another one is rotary milking system. They have already gone for IoT based and lot of automation in the dairy farm based on the mechanization. He narrated a case study with 370 cows with a land of 142 hectares. The milk production on an average was 23 liters per day per cow. The water usage mainly for the cleaning of milk equipment, cleaning cow holdings and feeding them drinking water for the cows. And they have specialized particularly in integrated water and nutrient recycling system, wherein he gave an example of a stormwater harvesting in a 6-hectare catchment area could reduce fresh water consumption by 324 meter cube per year, translating to 887 liters per day. Recycling of dairy effluent and secondary pond water has also been used. And again, particularly the nutrient concentrated in the pond supernatant in terms of nitrogen, calcium, etc., the data was given. The next presenter, 5th, Shri Vijay Kumara, former Managing Director, Milma, Kozhikode. The topic was water conservation experience from Malabar Milk Union, Kozhikode, Kerala. There they say the Milma mantra, particularly growing moringa, which uses a low water, and you can grow that fodder for the feed, as well as selling seeds of sorghum and guinea grass to the farmers at a subsidized rate. Feeding such fodder to the animal increased the fat and SNF content to a certain extent, which he specified, and even there was increase in the milk production too. Direct rain or stormwater harvesting in Palakkad Dairy, given an example, which is having a 2 crore liter pond. Rain harvesting from rooftop, which was found useful in about 4 to 6 months in a year. Reuse of the cooling water for milk packaging machine and homogenizer, which also helped in reducing the refrigeration cost as well. And the ETP treated water, example of Wayanad Dairy used for rinsing of soiled milk trays, etc., could go a long way in giving avenues into this particular direction. The 6th presenter, Dr. K. Latha Devi, NIENP, Bengaluru. The topic was water use and productivity with reference to dairy farming. The water scarcity has affected more than 2.7 billion people for at least 1 month each year in a year. She posed certain pertinent questions related to water conservation, such as how well the regulations are there, whether they are protecting our water resources, what is the water availability in a particular region, and what is its quality. They have a direct impact on health and production performance in crops as well as animals. We need to surmise starting from supply chain directly to the end user. The water usage measure can be in terms of the volume of water used to produce the product as well as to use of the polluted water per unit of time. She gave an idea about the average virtual water requirement for some selected products, which many speakers have given with the slides also, such as milk versus rice, cement, black coffee, tomato, etc. 2 components needs to be considered: internal water footprint for our own country, and second is external water footprint relative to other countries. The major determinants of water footprint based on one is the consumption characteristics, and number 2 is the production circumstances. She gave some model and formula to evaluate water use efficiency for example, washing of the animals, cleaning of the cancer equipment, washing the shed, drinking water, etc. Second last presentation, seventh, were Professor Shankar Murthy, NITIE, Mumbai. The topic was wastewater management in dairy industries with the purpose of reuse. The wastewater in dairy plant, according to him, would depend on several factors, including size of the industry, the technology used, best practices used for manufacturing products, and so on and so forth. The water used at every stage of milk handling and processing needs to be looked into and even dwelt into. The total world milk production allocated for dairy products, he gave some example for liquid beverage world, global. 39% is used for liquid beverage, 33% for cheese, may not be for India, 32% for butter, 6% for WMP, and 2% for concentrated milk products. The wastewater generation source may be from primary production of milk at the farm itself, and second is the processing of milk at the dairy plant itself. He described several flow chart of the production of certain products, including UHT milk processing and utilizing ultra high temperature treatment at around 140 degrees centigrade for 5 seconds. Then he stressed on measurement of biological oxygen demand, which gives an idea about the strength of the wastewater indicator, and particularly the dairy plant handling cheese, cream, butter, etc. The COD in water was, according to him, about 1.5 times the BOD level. Then he emphasized on the total dissolved solids, the total suspended solids, the pH control. For example, in the acidic cleaners, the pH range from 1.5 to 6. The chemical characteristics of different wastewater was very well dealt. The biological treatment of dairy wastewater by two methods, namely aerobic biological system and anaerobic biological system. And he emphasized that BOD to COD, if it is greater than 0.6 ratio, they can be easily treated without any acclimatization. Lastly, he emphasized use of certain enzymes. जो आजकल हम even in detergents also we are trying to use special enzymes like Actizyme from Switzerland, BioLear from UK, and they found that the utility of the processed water can be utilized very well. The last presenter, 8th, Dr. Ashutosh from NDRI Karnal. The topic was conservation of water in livestock-based farming system. He started by giving an example that just for 1 cup of tea, about 32.4 liters of water was required. Global freshwater resources need to be looked into. The global water footprint, according to him, was 7,450 GM cube per year. With increasing urbanization, there was an increase in the per capita water consumption. The livestock sector uses 10% of the annual global water flows. In India, more than 27 districts have been implicated to have stressed situation for the water. So it's a grave situation. What will happen in 2050? Wastewater generated was 17.3 meter cube per day per tap for a half-inch diameter tap, whereas a continuous open tap led to wastage of 28.3 meter cube per day water wastage. So even in the engineering aspect, you can look into the diameter of the pipeline and the taps which we are installing in the dairy plant. One project of separating water from dung, plastic bags, bottles, polythene, insoluble matters generated 32,000 or 35,000 meter cube of water, which is quite noteworthy. Wastewater treatment methods, namely 3 parts. Number 1 is coagulation and flocculation. Number 2, sedimentation. And the third is disinfection. And he said that disinfection can be carried out with sodium hypochlorite, potassium permanganate, iodine, or even using UV radiation. Simple technique of adding just a float, which we have in every water tank, to drinking water tank for the cattle also helps in saving the water. Use of water cum air pressure cleaning, gun with pressure, for effective cleaning with less water usage. The dairy should try to use step wells. We gave an example of a Chand step well example. And finally, he said that because of the projects which they have handled regarding usage of water. They have, NDRI has got Global Water Award. Thank you all. It was really a learning situation for all of us. Thank you.
I invite Shri K.C. Supekar, Managing Director, NCDFI, to give a brief about the technical session 2 and then to announce the winners for the same.
Good evening, everybody. First of all, I am thankful to the organizer for this very fruitful seminar, and it was a great learning for a person like me who spent most of the time with the district union, farmers, politician, and field. And this was really a sort of a feast for me, people like that getting into the mode of academician. And let me admit, frankly, that many of the presentation that they were highly technical and very much say subject oriented, and people could give a lot of input on overall situation in the country as well as abroad. And as we all are aware, like Professor Tushar sir is the authority on the water management and water resource and all, and he gave a very good presentation and this thing. In technical session, there were a couple of papers. There were total 8 participants presented various aspects on the overall issues, right from beginning like use of different chemicals, use of water, then comparison of say water requirement by the crop, milk, and the other sector. And in fact, it was very much sort of informative, and the researcher paid substantial thrust on the various aspects of the water management and how this scarce commodity could be better utilized for the benefit of the farmer and how we can retain this thing. And let me share with you the participant that when I was posted in Palampur, and then I published one case study on Palampur also, that water level used to be 650 or 700 feet. There was a rainfall condition before Narmada, and a lot of efforts have gone from the Vanas Milk Union. And when I was there, way back in 91, procurement was much less, and now average procurement is almost 65 to 70 lakhs. Peak procurement is almost 85 lakhs. And when we look at the 85 lakhs of the presentation done by Mr. Amit Vyas, so that the kind of need for the saving of water is very much need of the hour. And I keep giving example when I take session in the other state that there is a real example shared by the Amul and Amul's associated milk union where everything, whether it's a pasteurization cost, processing cost, energy cost, any costing if you take, their costing is much say below the required level. And then that's a great example that about the management efficiency. And we keep telling you that your landed cost is why high because you are having an inbuilt inefficiency. Now, as far as these technical sessions are concerned, so based on my colleague Dr. Jala and Mr. Manoranjan Pani, based on the assessment of the all 8 participants, now I announce number 1, first prize winner is Dr. Abhishek B. Parmar. Now a big applause. Dr. Abhishek B. Parmar, that present whatever he has presented, influence of formulated treated good meal and fill for supplementation on the water intake and water requirement of the growing dairy buffalo cows. So he will be given one certificate and 10,000 rupees cash prize. Number 2, second prize winner is Dr. Ajay Singh Sirohi, he also made a very fantastic presentation and elaborative. He will be given the one certificate and the cash prize of 7,000 rupees. The runners of number 3, Dr. Sanat Mishra, is from Odisha. He has also given a very interesting presentation, and will be given the certificate and the 5,000 rupees. So I am again thankful to the organizer to give the opportunity to address this thing. And I wish that maybe in the next seminar, whenever it happens, maybe next year, I will be in a position to present some small aspect of the dairy cooperative. Thank you.
Thank you, sir. The Student Core Committee of Irma Water Center had organized a picture extempore competition for the participants of PRM 41, 42, PRMX 3 and FPRMs on 10th October 2021. I now request Navan Sampath Kumar of PRM 41 to give a brief of the competition.
A very good evening to one and all. The first event for the banner of was organized, and it was named as Jal Anant, a picture extempore competitions. The event was 2 rounds. The round 1 was a write-up. The participants had to write up an essay of 500 words on the topic New Water Policy. A total of 16 teams had participated. Round 2 was a picture extempore competition where 4 teams were finalized based on their write-ups. The 4 teams were Team Tribe, Team Illuminati, Team Action and Team Aquavan. The participants of Team Tribe were Shashikant Shukla, Mahapriya Srinivasan, Krishna Chaudhary. Team Illuminati consisting of Prakhar Pratik and Ashna Sharma. Team Irrigation Mavericks, Purushottam Mankade, Prayash Chauhan. Team Aquavan, Shreyan Singh, Vidhu Verma and Drumil Shah. And the competition was judged by 3 panelists, Dr. R. Subhaya, Shri Yogesh Joshi and Sri Sachin. Now the award for the competition will be presented by Shivansh.
Manager Communication Irma to felicitate the winners of the competition.
So 2 teams in the second runner place, they won a cash prize of 3,000 rupees and certificates. These teams are Team Illuminati and Team Aquavan. Second runner is Team The Tribe. They have won a certificates and a cash prize of 4,000 rupees. And of course, the winners are Team Irrigation Mavericks, who have won certificates and a cash prize of 5,000 rupees. Congratulations to all the winners. Thank you.
Thank you, Shivansh. I now invite Dr. J.B. Prajapati, Chairperson VKCOE, to conclude the plenary session.
So, dear Dr. Dadish, the chairman of the session, and all the delegates who are physically or virtually present in this conference, the whole day session, 8 hours, were very fruitful, and I will not take more than 2 minutes to just summarize. We are very happy that this hybrid event is successful. We were about 50 persons sitting in this hall, but probably the online you could not see us, but it was a good moment for us, and there were more than 100 people viewing us online. The morning started with a pious lighting of the lamp, and then we paid tribute to our beloved leader, late Dr. Balgis Kurian, whose centenary we are celebrating. In the inaugural session, Dr. K.B. Kathiria, Honorable Vice Chancellor of Anand Agriculture University, presided over the function. And then we had recorded messages from the chairman of NDDB, Sri Nilesh Shah, and many other dignitaries whom we had invited as guest of honors, especially Dr. G.S. Rajoria, Sri Basant Maheshwari, Pranav Shah, Sri S.K. Panigri gave their good messages. And the chief guest of the session was Sri Amajit Sen, President of Indian Society for Agricultural Economics. The gist of all these speakers and our Director of Institute of Rural Management, Professor Santosh Biswas, also addressed the gathering. But the gist of all the guests is that water is very essential. We know that nobody can live without water, and there is likely to be water scarcity in future. And as we all are connected with dairy sector, it is our duty to conserve each drop of water in the dairy sector. And as we classify here, most of the water requirement is going for milk production. That means it is animal husbandry side, that how we can reduce water uses. And then part of it is going to dairy processing, how we can save water, how we can reuse it. So main focus has to be on recycling the water as many times as possible. पानी भी थक जाएगा, कितनी बार मैंने यूज किया? How many times you are using me? So उसको 4 बार, 5 बार, 6 बार use करो, so that your efficiency is 6 times, 7 times more. And so that is the only way, because everywhere we need water. And then we had 2 very good technical sessions, 1 and 2. Dr. Jana probably gave very elaborate summary of the both sessions, so I need not talk about. But we had a practical example of how the water can be conserved in the emergency. That is a Amul experience. And that can be replicated. If it is even 20% replicated in other unions, will have a great savings, I'm saying. And then Banas Dairy is following. Sangram Chaudhary, sir, very briefly noted it. So this is the summary of the whole day. The second session, as Dr. Supekar already told, this was from young scientists, and we had very good initiatives in that. But we have very good research in production area, but we have very few research, almost no abstract we could receive in the processing side. So I wish that we should encourage such research in the dairy processing side also. So with this, I complete my concluding remarks, and I thank one and all, including my very good friend and colleague, Professor Uday Shankar Saha, for being with us in organizing this event. And I'm thankful to Bajish sir for presiding over this concluding ceremony. And thanks once again to all of you. Thank you very much.
Thank you.
Thank you, sir. With this, we conclude the plenary session. I now invite Professor Kushal Anjalia, Assistant Professor IRMA, to give a vote of thanks.
Yeah, good evening, everyone. First of all, I thank IRMA Water Center for providing me an opportunity as an IWC member to deliver the vote of thanks. IWC, I extend a really hearty vote of thanks to our chief guest, Professor Abhijit Sen. I thank Dr. K.B. Kathuria, Sri Basant Maheshwari, and other guests of honors who presented here. Further, we are thankful to Director in Charge, Professor Shashwat Narayan Biswas, to be here. Professor Tushar Shah, member of IWC, for chairing the technical session also and for guiding us. I thank all the co-chairs, jury members, Professor Jena, Professor Supekar, who are here, for chairing technical sessions and summarizing the sessions for us as well. I also take this opportunity to thank our presenters, young scientists and participants for really enriching our knowledge. I thank Mr. Shivans for managing IT activities, anchor, Smriti Smita Mohapatra, Mrs. Prakriti Pranami, Dr. Pankaj Parmar, Ms. Madhura Sampurkar, and Pranjali Pechkar. Yes, of course, Ankit as well from BKCU, my friend. Yes, of course, Raju bhai for taking a photograph and covering this entire event. I also thank IDA, Indian Society of Agricultural Economics, NDDB, to be partner and co-sponsor of this event. I also thank the student core committee of IWC for managing this event and to actively take part and support us to organize this event. On this note, I thank and in fact I congratulate Dr. Prajapati and Professor Shah for successfully organizing this event. Thank you. Thank you very much.
Thank you, sir. It is indeed an educational fulfilling day. I thank all the guest speakers, presenters and attendees for participating in today's e-conference on water management in dairy sector. Thank you.
Special thanks go to Professor Tushar Shah, who has given excellent presentation in the morning. And Badish sir, we take your permission to close the session now.
Thank you. Nice of you.
Thank you, Professor. Thank you, Doctor.